Hey there, future coders. My name is Jesse, your instructor for this course, and whether you're brand new to coding or have some experience, this course is here to guide you through the basics of Python programming. In this course, we'll cover a wide range of topics starting with the basics of Python syntax, data types, and control structures. As we progress, you'll delve into functions, data structures, and even get a taste of advanced concepts like file handling and object-oriented programming. By the time you finish this course, you'll have a strong grasp of Python fundamentals. You'll be equipped with the skills to write code, solve problems, and understand the logic behind it all. Before we get started, please click those like and subscribe buttons, and if you have any questions throughout the course, please post those in the comments below. The first thing I'm going to do is show you how to install Python onto your Windows 10 or 11 machine. Start by opening your browser and navigating to www.python.org. When the website loads, click the Downloads tab here. The website will know what operating system you're using, and it will offer you a download button for the most recent stable release version of Python right here. But if for some reason you want a different version of Python, you can scroll down a little bit, select any one of these versions here, and click the download link over here to the right. Now I'm just going to say go ahead and download the one that they are offering. Once the download completes, navigate to where the executable was downloaded and double click on it to run it. Once the window opens, click the checkbox down here that says add python.exe to path. This will allow us to run Python through the command prompt or through a terminal, and then click install now. After installation is complete and you see the setup was successful window, if this button right here that says disable path length limit is available, go ahead and click it. If this window pops up asking if you want to allow this app to make changes, click yes. This is so that if the path to your Python executable is longer than 260 characters, it still functions properly within the command prompt or terminals. And then you can click close. Now we want to double check to make sure that Python is successfully installed and we have access to it. So go to your search bar, type in CMD and open the command prompt. When the command prompt opens, type in Python space -- version and hit enter. And if Python was successfully installed, you will see Python and a version number here. If it did not work for some reason, you would get an error message saying that Python was not a recognized command. Now, to actually open a Python terminal, we can just type Python by itself and hit enter. And this brings us into a Python terminal where we can type Python commands such as print. And when I run this, it'll output hello world to the console. Now that you have Python installed on your Windows machine, you're going to want an interactive development environment to actually do development on. So I'm going to show you how to install Visual Studio Code. Open your browser and navigate to code.visualstudio.com. Just like the Python website, the Visual Studio Code website is going to determine what operating system you're using and provide you a download button for your operating system right on the front. If for some reason you don't want to go with the one that they're offering, you can click the download button over here on the top right corner. And then underneath the Windows section here, there are some options for user installer, system installer, .zip, and command line interface for 64-bit, 32-bit, and ARM64. Or you can just click this button right here, which is going to download whichever one it thinks is best for you. So go ahead and click that button now. Once the executable is done downloading, navigate to where the file was downloaded and double click on it to run it. First thing you're going to see is a license agreement for Microsoft. Please read through the entire thing, and as long as you agree to everything in it, click the I accept the agreement button, then click next. I'm going to go ahead and leave it as the default location for where to install it, click next. And I'm also going to leave the default name for the start menu and click next. Here, you're going to want to click Add Open with Code Action to Windows Explorer File Context menu and Add Open with Code Action to Windows Explorer Directory Context menu. This will give you a right-click option that when you right-click on a file, such as a Python file, you can click the Open with Code button and it will automatically open with Visual Studio Code. Click Next. Just double-check that everything looks correct and click Install. Once installation is complete, make sure that you have Launch Visual Studio Code here checked and click Finish. The first time you open Visual Studio Code, you should be presented with a Welcome tab here. The only thing that we really need to do on this screen is pick a theme for our Visual Studio Code. I personally prefer the dark high contrast. I like the black background with brightly colored lettering, but you pick whatever works best for you. The other thing that we need to do is install the Python extension. To do this, we can go over here on the left side and click the extensions icon. And then in the top search bar here, type in Python. You'll see one here that says Python by Microsoft with the verified blue check mark. Click the install button. And it's going to download and install the Python extension for Visual Studio Code. Give it a couple minutes. Once the Python extension is finished being installed, you'll be presented with a new welcome screen for it. The only thing that we need to do here is select a Python interpreter for our development. There's an option right here for select a Python interpreter. If you click on that, it'll give you this button here. Click that, select Python interpreter, and then up here it will give you a list of all the Python executables on your system, and it'll give you a recommended one. Just go ahead and select whichever one you would like. If for some reason this welcome screen did not open up or you closed it out before you selected a Python interpreter, over here in the bottom left corner is a manage icon. Click that and then click command palette. Start typing Python select interpreter and you'll see the option for Python select interpreter. You can click on that and then select your version of Python that you would like to use. That's it. Visual Studio Code is set up and ready to go for Python development. So let's go ahead and create our first Python program. Over here in the top left corner, click on the Explorer tab. You could do File, New File, and create a single Python file, but I prefer to do an open folder. That way there I can create new Python files or switch between files very easily. It also allows me to trust any Python file that is in that folder so that I don't have any issues running them. So click Open Folder and navigate to a place where you would like to put your Python files. I'm going to go to Documents and create a new folder called Python Projects. I'm going to select it and then click Select Folder. The first time that you open up a folder, it's going to ask you if you want to trust the authors of the file. Click the Trust Authors of all the files in the parent folder, and then this is going to be whatever folder you chose, and then click Yes, I trust the authors. If you don't trust the authors, you can open the code, read it, write new code, but you cannot run the files. I'm going to go ahead and zoom in a little bit, make it easier to see. Up here in the Explorer, you'll see this icon here that says New File. Click that. And you can name it whatever you want as long as it has the .py extension. And you can see right here, we have the Python logo because Visual Studio Code knows that anything with the .py extension is a Python file. And for our first program, it's going to be a very simple program that prints hello world to the terminal. So type in print, parentheses, and then in quotes, type hello world. And then over here in the top right corner is a play button that runs the Python file. Click that. A new terminal will open and this file will be sent to our Python executable where it will be run. And we have an output of hello world. And that's it. You now have Python installed, you have an interactive development environment installed, and you have created your first Python program. I'm going to be using terminology such as function, parameters, and arguments throughout the course. And I want to make sure you understand what I mean when I use those terms. I'm going to be talking about the print function and the arguments that it takes to perform the output to the console. You can see that I have one line of code here, and it is the print function that we use from the previous video to output hello world to the console. Inside an interactive development environment such as Visual Studio Code, when we hover over certain parts of the code, it'll give us more information. So if I hover over the name print here, Visual Studio Code will tell us that it's a function, and then inside the parentheses after the name, it tells us what parameters the function takes, and then after the end of the parentheses, it's got a little arrow, and it tells us what the return type is, if there is one. In this case, this function does not return anything, so it is none. Now, these are the list of the function's parameters, values, separator, end, file, and flush. The values that we pass in are arguments. So here, hello world is the argument for print's values parameter. Now this little asterisk that's to the left of values means that it takes a variable number of values. As long as I separate them by a comma, I can put as many as I want in. So if I did 1, 3, 4, run that, we'll get the output hello world 134. Now the other arguments that the print function has are separator, end, file, and flush. Now separator is shortened to SCP. And if you don't pass a value in, it defaults to just being a space. And that is what it gets put in between each of these values here. So if I were to change this to be SCP equals, and then in quotes, put a dash and run this again, now we can see that hello world 134 is separated by a dash. The end parameter is done in a similar fashion where you would put a comma and then end equals. And you could put whatever you want here. I could put some exclamation points and run this. And now it's going to append whatever this string is to the end of the last value here. So down here, we can see we have hello world 134 and then some exclamation points. Now, it is important that if you do change the end, that you should probably go ahead and use the new line character, because what happens if you don't is if I were to do another print statement down here and run this, it's going to put this all on the same line because there's not a new line character at the end of the previous line. So down here we have hello world 134 and our exclamation points and goodbye all on the same line. But if I added that escape character, which we will talk about more later, it goes to two separate lines like it should. That's all I had for this video. I just wanted to make sure that you knew that if I say function, I'm talking about the name that we're calling, and if I say arguments, I'm talking about the values that we pass into the function. Variables are a named location in memory. Basically, you assign a value to a variable and you use that name to access that location in memory to retrieve that value. A variable is a reference to an object. It's not the object itself, it's just a reference. That object might be a string, a number, a list, a dictionary, or as you'll learn later in the series, you can even create your own. Because Python is a dynamically typed language, the variable type is inferred from the value that's passed into it, not declared at the time of creation. There are rules for naming variables. They can only contain alphanumeric characters and underscores. They must start with a letter or an underscore. They cannot contain any spaces. They are case sensitive, and by case sensitive, that means that two variables with the same name, they could both be age, but one is all capitals and one is all lowercase. Python views that as two separate variables, and they cannot contain any Python keywords. Keywords have a special meaning in Python, so when the Python interpreter sees one of these keywords, it expects to be able to do something with it, so it cannot be used as a variable name. Here's a list of the keywords here. Now, because Python is case sensitive, you could use these words. You would just have to change. For example, you could have a variable named false with a lowercase f, or you could do something like my underscore class, or you can make and all capitals. So you can use these words, you just can't use them as you see them here. Here we have some examples of valid, invalid, and bad names for Python variables. Under valid names, we have all lowercase age, age with a number at the end of it, underscore my, underscore age with some mix between capitals and lowercase, and then we have an all uppercase age. Invalid names include names that have spaces in it, so my space age, names that begin with a number, one age, names that have invalid characters such as a dash, my dash age, and names that are Python keywords such as class. Bad names are names that are valid. Python has no problem with them, but they're probably not the best names to choose for your variables. So something like X, Y, Z, A, B, stuff like that, it has no meaning, so you don't really know what it is. Now, if you're doing something that's just like a real quick test, it's not a big deal. But if you do this in production code, or even if you do it in your own code and have to come back to it a week, a month later, and you see this or somebody else sees it, they're going to have no idea what that X is for. So try to use names that are meaningful. Try to avoid using acronyms. So this word here, nod, is actually an acronym that I made up for number of days. And if I did this and a week later I went back to my code, I might be trying to figure out what NOD stands for. And then also try to avoid abbreviations. The word year is commonly written as YR, but not everybody knows that. And just throwing the S on it for YRS here may make it very difficult to understand that this is supposed to be years. So try to avoid doing bad names like this. Let's jump into Visual Studio Code and practice making some variables. For our first one, we'll give it the name age and then use the equals assignment operator to give it the value of 36. Now, to use a variable, we simply take this name that we gave it and type it somewhere else in the program. So I could type a print function, and instead of passing it a string like we did before, I'm just going to pass it the variable age. So it's not going to print the word age, it's going to print the value that's associated with a variable named age. So when I run this, we'll see down here that we get the output of 36. We could also create a string by typing the name, first name, and using the equals assignment operator to give it the value of Tim. And if I print the first name variable and run that, we'll get the output Tim. Now, one thing that you want to be aware of is that since Python is a dynamically typed language, when you change the value of a variable, you could also change its type. So if I had something like x equals 7 here, and then somewhere along the line, I changed it to x equals, and I made it the string value 7. Now, if I print this, it's not going to be a huge deal. Python's going to know what to do with it. It's going to print and output 7 down here. But let's say that I expected this variable x to be some sort of numeric value, and I changed it to a string value, and then I tried to do some kind of arithmetic on it. So if I tried y equals 5 times x down here after I've changed x to a string, and I try to print y out, well, because I've changed the value from a numeric type to a string type, I'm not going to get the result that I expect down here. And when I run this, I just get the word 7 printed 5 times in a row. Another example would be if I tried to divide 5 divided by x. When I run it now, I get an error because it's trying to divide the integer 5 by the string 7, and it's an unsupported operand, so it can't do that. So just be aware that when you change the value of a variable that you don't accidentally change the type as well, or if you do change the type that you intended to do so. And now let's just quickly look at some additional ways to assign values to variables. We can actually do this all on one line where we can assign 3 variables 3 different values by typing the variable's name separated by a comma, then the equal sign, and then the 3 values that we want to associate with these 3 variables. So I'll do apple, banana, and coconut for ABC. And then if I go to my print function and I pass it the variables A, B, and C and run it, we'll see down here that it prints out apple, banana, coconut. We can also assign a single value to multiple variables by using successive equal signs. So here I'm going to change this A, B, C to A equals B equals C equals, and then the value that I want to give it, and we'll just make it fish. So now when I print A, B, and C, it's going to be fish, fish, fish. And that's basically it to creating variables. It's just a name, an assignment operator, and a value to associate with the name. Now I want to talk about the input function so that you can actually interact with your programs. Inside Visual Studio Code, I'm just going to type the name of the function, which is input, and give it some parentheses. Now if I hover over this, we'll see that the input is a function. And inside the parentheses, it shows that it only has one argument, which is a prompt. And if we don't pass any value in, it defaults to being an empty string. And after the parentheses, we'll see that this arrow here is pointing to str, indicating that the value that this function returns is a string. Now, if I just run this here, it'll run, but nothing really happens. It's actually waiting for me to type in some kind of input and then hit enter. And then the program just ends. So that's a little boring. Let's make it a little more interesting. And we'll put in a prompt of enter your name. And now if I run this, it tells me that it wants me to enter my name. So at least now I know what kind of information it wants. But again, it just ends. So let's actually do something with this. This function returns a value, and there's 2 ways that we could use this. We could actually just put this function into another function that uses the value that it returns. So I could wrap this all up into a print function here. And if I run this, when I put my name in, it's simply going to print whatever value I put in, and we'll see that it outputs my name right here. But that doesn't really help us, doesn't do anything interesting. So instead, we're going to pass the value that this returns into a variable and then use that variable to print a personalized greeting. So I'm going to say my name equals, and then whatever the value that this function returns is going to be assigned to the variable my name. And then on the next line, we're going to do the print function, and in a string, in a pair of quotes, I'm going to do hello and a comma. And then I'm going to do the comma separator for the variable number of values that the print function takes. And I'm going to pass in the my name variable. So this time when I run it and it asks me to enter my name and I put my name in, it's going to give me a personalized greeting and say, hello, Jesse. Now I want to talk about 4 key aspects of Python syntax: indentation, statements, expressions, and comments. Python uses indentation to define the structure of code blocks. whereas many other programming languages use curly braces to define their code blocks. A statement is just a complete instruction that performs some action. An expression is a combination of values, variables, and operators that produce a result, and comments are just a way to add notes to code to explain the purpose of that code. If you look on the right side of the screen, I have some examples of indentation, statements, expressions, a statement containing an expression, and comments. I have a if conditional that ends in a colon. Anything that ends in a colon requires that the code for that below it is indented. A statement can be as simple as x equals 25, or an expression as simple as x plus 5. A statement containing an expression will be something like y equals x plus 5. And for comments, you can use either a hashtag to create a single line comment or the triple quotes to create a multi-line comment. So if I jump into my development environment here, I have some code ready to explain some of the stuff regarding indentation in Python. So I have an if, elif, and else conditional statements here. And under each one of these, they are indented because I have this colon here. So the first one here under the if conditional is indented to the standard 4 spaces, which is common in many interactive development environments to put in 4 spaces when you hit the tab key. And then under the elif conditional here, I actually have 12 spaces. And the Python interpreter does not care how many spaces you actually indent, as long as all the code that is supposed to be indented is indented the same amount for each code block. So here I have 12 spaces. Up here, I only have 4 spaces. And down here under the else conditional here, I only have 1 space. Python interpreter does not care. Now, if I were to change the spacing for this one here, which has 2 statements, and I add an additional space, we'll see that I get this red squiggly line indicating an error. And if I hover over it, it tells us that it's an unexpected indentation. And if I were to remove a few spaces and hover over it, now it says unindent amount does not match the previous indent. As you can see, Python is very strict about its indentation. And if you are outside of any area that requires indentation, so if you're not under an if conditional, inside a loop, under a function, under a class, something like that where you are required to have indents and you put space before the code, it doesn't like that either. So here outside of the if conditionals, I just put a single space before this statement, x equals 5. And if I mouse over it, it's telling me that it's an unexpected indentation. And if I try to run this, it's going to give me an indentation error and the program is never going to execute. Now let's talk about comments in Python. Comments are something that you add to code to help explain what it's doing or how it works. Even with your own code, it gets very complex and you might come back to it a week or 2 weeks later and look at it and not remember exactly what that code is supposed to be doing or even how it works. So you would add comments to it to help explain to either you or other developers that might be reading your code what that code is doing. Comments can be added anywhere to your Python file, and the Python interpreter simply ignores their presence. And you create a comment by typing a hashtag or pound symbol and then putting in your comment. Now, anything after this first hashtag symbol on that line is going to be considered a comment. I can make this as long as I wanted, or I could add other hashtag symbols to it, and it's just going to see this entire line as a comment. If I wanted to create additional lines, I would just simply add more hashtags and add another comment. And then below the comments, I would write some code. So I can put the print function here to output hello to the console and run it. And the interpreter is going to simply ignore these 2 lines here that are comments and output hello to the console. And I could also add another comment after the statement. So if I wanted to maybe put a comment saying what this is going to output, I could do that. And if I run this again, we'll see that it simply ignores this line as well and just outputs hello. Another way to do comments in Python, and is often used with multiple lines, is to use the triple quotes, which are a set of 3 single or double quotes, and then your multiple line comment could go in between them. And if I run this, we'll see that it has no issue with that, runs properly. Even though this is technically a string in Python, because it's not being assigned to a variable and it's not being used in any way, the interpreter simply ignores it. Comments are also useful for testing out different parts of your code. So let's say that I had 2 print statements here, and maybe I was trying to test something or figure something out, and I only wanted one of these to run, I could simply add the hashtag before this statement here. Now when I run it, it only outputs goodbye. And then maybe I decide, okay, let me try the other one. So I'll remove the hashtag from it, add a hashtag to the next line, run that, and now it only outputs hello. There is one other thing about comments that will be talked about later on in the series when we get to functions, which is docstrings. Docstrings are a way to help interactive development environments such as Visual Studio Code provide additional information about functions and classes. So if I hover over the print function here, we'll see that we have this information down here. It says prints the value to a stream or to sys.stdout by default, and then has information about the arguments that it takes. This information is likely being provided by a docstring. So when we get to functions, I will explain how docstrings work and why they are so useful. Now let's talk about Python's built-in data types. Data types define the kind of data that can be stored and manipulated in variables. Each data type has unique properties, behaviors, and operations associated with it, and Python provides numerous built-in data types and allows users to define their own data types by creating classes. As you can see here, we have numeric types, sequence types, mapping type, set types, Boolean type, and none type. Under numeric types, we have int, which is short for integer, float, and complex. Integer values are whole numbers, 1, 1000, -25. Unlike other programming languages where the minimum and maximum integer is determined by the type of int, by the data type, Python does not have that limitation. You can have an integer that's 200 digits long, and Python handles it just fine. Floating point numbers are basically numbers with decimal places in them. Python can handle up to 17 significant digits. However, due to the way that floating point numbers are stored in binary, there are some issues when doing arithmetics with floating point numbers. We'll go over that in more detail later in the series, but for now, just be aware of it. Then we have sequence types, which are str, which is short for string, list, tuple, and range. A string is just a sequence of characters, so this right here would just be a sequence of the characters HELLO. A list is an ordered collection of items. You can see here in square brackets, we have 1, 2, 3. Square brackets denotes a list in Python. Python is a zero index language, meaning the first element in the list is index 0, index 1, index 2, and so on. A tuple is an immutable ordered collection of items. This word immutable here means that once a tuple is created, it cannot be changed. It cannot have any elements added to it, taken away from it, and no elements in it can be modified in any way. You'll see that the tuple is in parentheses. Then we have a range, which is an immutable sequence of numbers. And the interesting thing about ranges is the numbers aren't actually generated until they're needed. So if I created a range and assigned this to a variable, and I told the print statement to print that variable, it would literally print this out right here where it says range, and then in parentheses has 1, 10, 1. But if I were to use this in a for loop, it would generate the numbers needed to use the for loop, or I could put this range into a list and it would store the sequence of numbers in the list properly. Then we have mapping type, which is just dict, which is short for dictionary, which is a collection of key value pairs where each key is unique. And you can see that these are in curly brackets. And then we have an ID or a key, and then a colon, and then the value that's associated with that key. So if I told Python that I wanted the value that was associated with key 2 of this dictionary, it would return me the value Jane. Then we have set types, which are set and frozen set. A set is a mutable, unordered collection of unique elements. This means that because they're mutable, it can be changed after you create a set. You can add elements to it or remove elements from it. However, they're unordered, which means that you cannot access any individual elements in the set to modify them or get any information about that individual element. They contain unique elements, meaning that if you passed a list into this set constructor here that had duplicate values, the set that was returned would not contain those duplicate values. They would be stripped out and only one of each value would be returned. Then you have a frozen set, which is just a set that's immutable. It's a set that cannot have values added or taken away from it. Then we have the Boolean type, which is just a value of true or false. And finally, the none type, which is the absence of a value or a null value. So if you wanted to create a variable, but you didn't know what value you wanted to initialize it as, you could just create the variable and set it to equal none. Or maybe you had a function that is supposed to return something, but maybe you have an option where if things don't go quite right, it returns the none value instead of an integer. Now that we know a bit about data types in Python, let's go ahead and talk about the integer data type. Integers are a fundamental data type in Python used to represent whole numbers. They encompass positive, negative, and zero values without any decimals or fractional parts. They are utilized in various computational tasks ranging from simple counting to complex mathematical calculations. Python's integer data type can accommodate a wide range of whole numbers from very small to very, very large. Common uses for integers are counting and indexing. Integers are essential in counting iterations and indexing elements within data structures like lists, tuples, and strings. They are used in mathematical calculations and often used for constructing algorithms and solving numeric problems. And integers are used in control structures. Integers play a key role in conditionals, loops, and decision-making, allowing programs to respond dynamically based on numeric values. There are a couple of ways to create integers. The easiest way is to simply create a variable and use the equal sign to assign it a whole number value, such as my_int equals 5. You can also create integers by using the int function, and you can pass different values into the int function and it will attempt to convert it to an integer. So if I pass in the value 5.3 and then I print my_int and run this, we'll see that I get the output of 5 with the decimal part removed. You can also pass a string representation of an integer value into the int function, such as 123. And if I run this now, we'll get the output 123. However, if I tried to pass in the string representation of a float value into the int function and run this, it will raise an error. I get a value error that it's an invalid literal for int with base 10. So try to remember, if you do use the int function with a string value, that it is a whole number with no decimal or fractional parts. You can use common arithmetic operations with integers, such as myint equals 10 plus 35. And if I run this, we'll get the output 45 down here. Or if I did something like 25 minus 24 and run that, I'll get the output 1. And unlike floating point numbers, which we will look at in an upcoming video, Python does not have any limitations with integer values. So I could have these two variables x and y that have these extremely large integer values here. And if I try to output either one of these, it works just fine. It outputs it with no issues at all. And I can even add these together by doing x plus y. And if I run this again, we'll see that it added these two very large integers together just fine. Now I want to show you some built-in functions that Python provides to work with numeric values. So I'm going to go ahead and remove this code here, and I am going to create a result variable, and I will set it to equal ABS. And in ABS, I will pass -12. So this is the absolute value function. It returns the absolute value of the argument. And what the absolute value is essentially the positive value of a numerical argument. So here I am passing in a -12, but when I print the value of result, it will output a positive 12 down here, and we can see that right here. The next function I will show you is the min function, and that is just min. And in the min function, we can pass a group of variables separated by a comma. And what the min function does is it returns the smallest item. We can see here it says with a single iterable argument. So if we pass in like a list or a tuple, it returns the smallest item. With 2 or more arguments, it returns the smallest argument. So here I am passing in 4 arguments separated by a comma. And when I run this, it is going to return the 1 because the 1 is the smallest item. So down here, we get this output of the 1. And I can also pass a list into here. And if I put in some square brackets, I can put in a list of numbers here. And if I run this, it is going to output 21 because 21 is the smallest number in this list. So down here, I get 21. And there's also a max function, which returns the maximum number in the arguments or the list. So this time when I run it with the max function, it is going to return the 27. And when I run that, we'll see that we get this 27 down here in the terminal. Python also has a built-in sum function. So if I replace this max function with the sum function and hover over it, it says it returns the sum of a start value plus an iterable of numbers. What this means is that I could provide a start value and then it would add these numbers to that start value. Or if I just pass in the iterable, it will simply get the sum of the numbers in the iterable. So when I run this here, we'll get 71, which is the sum of 23, 21, and 27. And I could add a start value here, such as 10, and it would add all these numbers here to this value 10. And when I run this, I get the output of 81. The next function is the pow function. So I will put in pow and a set of parentheses. And when I hover over this, it says the equivalent to base asterisk asterisk exponent with 2 arguments, or base asterisk asterisk exponent and then the percent symbol and then mod with 3 arguments. And what this means is that if I do 5, 3, 5 is my base, 3 is my exponent, and it is going to raise 5 to the power of 3 and return that value into the result variable. So when I run this, I get the output of 125. And if I add a third argument, it would return the remainder of this value here divided by that third argument. So if I pass in the value of 17 here and run this, I get the output of 6. 125 divided by 17 is 7 with a remainder of 6. So that's where we get this 6 from, is the remainder. And finally, I want to show you the divmod function. With the divmod function, you can pass in 2 arguments, and it is going to return the floor division of the first argument divided by the second argument, so the whole number. And then it is also going to return the remainder of the first argument divided by the second argument. So if I pass in a 26 and a 7 separated by a comma and run this, we are going to get the output 3 and 5. And 26 divided by 7 is 3 with a remainder of 5. And that is where we get this tuple here, which is denoted by the parentheses on either side of these numbers. Now let's talk about the float data type and some of the issues that may arise when using arithmetic with floating point numbers. Floats are a type of data that represent real numbers. They are stored as 64-bit double precision floating point numbers, which means that the float data type can represent numbers of up to 17 significant digits. However, it is important to note that the actual number of decimal places displayed may be less than 17. This is because Python rounds the number to the nearest representable value when it is displayed. And like with integers, there are a couple of different ways to create floats. So as you can see here, I have my underscore float equals 1.0, and I have this decimal place here. And anytime you have a number with a decimal place in Python, it is a float. And if I output my float, it will simply output 1.0 here. And just like the integers have a int function, the float has a float function. So I could say my float equals float and then pass in an integer value such as 99 with no decimal or fractional parts. And when I output this now, you'll see that it outputs it as 99.0 and it has added the decimal place here. I can also pass in the string representation of a decimal, such as putting the value of 3.14 in quotes. And if I run this, I'll get the output 3.14 down here because it has converted this string to a float. Using certain mathematical operations also creates floats. So if I have the integer value 4 divided by the integer value 2, and run this, we'll see that it actually outputs 2.0, which is a float value. And this is because anytime you use regular division, it always returns a float value. And if I were to do something like 4 plus 2 and run this, we'll see that we get the integer value 6. But if I were to make this 4 a 4.0 and run this, now I get the output of 6.0. Because anytime that you use a float with arithmetics, if the type of arithmetic you're using doesn't explicitly return an integer value, it will always return a float value. So now I want to show you some of the limitations that floats in Python have. I'm going to replace this here with this number here, which is 0 with 18 digits after the decimal place. And as I mentioned earlier, the floating point precision in Python can display up to 17 significant digits, and this 0 to the left of the decimal is considered insignificant, so it is not factored into those 17 digits. Now, when I run this, where I try to output this number here, we'll see that it actually removes the 9 here from the end of the number, and it only goes up to 8. And Python does round the number up to the nearest representable value. So in this case, it did not have to actually change this number. But if I remove this decimal here and put it here after the 9, so I have 9 significant digits on the left side of the decimal and 9 significant digits on the right side of the decimal, totaling 18 significant digits, when I run this, I get the output where the 9 was removed and then the 8 was rounded up to 9. So I have 1, 2, 3, 4, 5, 6, 7, 9. And this was just an example of it rounding up to the nearest representable value. If you use a floating point number where there are more than 17 digits on the left side of the decimal, so if I add 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 here, it will essentially remove all of the decimal places and turn this number into a scientific notation version of it. So when I run this, I get this output here, which is the scientific notation version of this number here. And if we look at this, we can see that all of these numbers were removed and the 7 here was rounded up to 8. Now, if I try to convert my underscore float, this value here, to an integer using the int function, so I'll do result equals, type in my int function and pass in the value of my underscore float and output this, we may not always get the result that we expect. So if I run this here, you'll see that we get this number here, which is not quite the same as the whole number that we had when we created my underscore float. You'll notice that the last 2 digits in this number are 6, 8, whereas the last 2 digits up here are 8, 9. And if I added just a single 0 to this and run it again, we'll see that now the last 3 digits are 1, 6, 8 instead of 8, 9, 0. So this doesn't always convert the number back into an integer the way that we would expect it to. So it's important to try to remember that if you are working with large float values and you are converting them to a different data type, you may not get the results that you expect. Due to how floating point numbers are represented in computers, performing calculations with floats can sometimes lead to unexpected results. So it's important to be aware of these floating point precision limitations and consider using the decimal module or other techniques for precise calculations involving decimal numbers. And one very simple example of that is if I have x equals 0.1 and y equals 0.2, and then I do z equals x plus y, and I try to output z, I'm not going to get the result as 0.3 like I would expect. I'm actually going to get 0.3 and then this whole bunch of zeros and this 4 here. And this is an example of how working with floats can sometimes generate imprecise values. And although this is an extremely small number, depending on what you are doing with this number, it could have a very big impact on the program. So just remember, when you are working with float values, there can be some imprecise results generated. So extra steps have to be taken to make sure that the program is doing what it is expected to be doing. Now that you know a bit about the integer and float data types, let's go over arithmetic operators, which are used to perform mathematical calculations on numeric data types in Python. They follow the precedence rules of parentheses, exponents, multiplication, division, addition, and subtraction. The addition operator adds 2 operands together or concatenates sequences. The subtraction operator subtracts the right operand from the left operand. The multiplication operator multiplies operands together to produce a product or repeat sequences if used on a sequence type. The division operator divides the left operand by the right operand to produce a quotient. The floor division operator performs division and returns an integer quotient. The modulus operator performs division and returns the remainder. And the exponentiation operator raises the left operand to the power of the right operand. In my development environment here, you'll see that I have created some variables to work with, and down here I'm going to output the result of our operations. So the first thing we'll do is the addition operator, so I will type in x plus y, and if I run this, we'll get the output down here of 13. Then if I were to subtract y from x, I will get the output -7. If I were to use the asterisk to multiply x and y, which is 3 and 10 together, we get the output of 30. And if I were to divide x by y using the / character, I would get 0.3. For the more uncommon operators, such as floor division, I'm going to swap the x and y variables here. So we're going to do floor division, y divided by x, And when I run this, it's going to return the integer value of 3 because floor division returns whole integer numbers and gets rid of the decimal and anything after the decimal. The next operator will be the modulus operator, which is the percent character. And this is an important operator to know because it is used heavily in mathematics and used for encryption and decryption. And what this does is it divides the left operand by the right operand and returns the remainder. So in this case, the remainder would be 1. So we get the output of 1. And then finally, we have exponentiation, which is 2 asterisks. And this is going to raise the operand on the left to the power of the operand on the right. So it's going to be 10 to the third power, which is 1,000. And you'll see here we have the output 1,000. So now let's look at some examples that use the precedence rules. So we could do something like x plus y divided by x to the power of y. And when I run this, the first thing that's going to happen is because exponents comes before division or addition, it's going to raise 3 to the power of 10. And then it is going to divide 10 by whatever the result of raising 3 to the power of 10 is. And then finally, it's going to take 3 plus whatever the result of this is. So when I run this, we'll get this output here, which is 3, and then a very, very, very small decimal place after it. And that is because 3 to the power of 10 is a really large number, and 10 divided by that produces this very, very tiny number here. We can also use some parentheses to have a bit more control over the precedence. So if I wanted to, let's say, do x plus y before I did anything else, I could put those in parentheses. And now when this runs, it's going to perform the operations inside the parentheses, then the exponents, and then it's going to divide the two. So this is going to end up being 13 divided by 3 to the 10th power, and it's going to be a very, very small number. And we get this down here, which is indeed a very small number. Now let's look at assignment operators, which combine the arithmetic operators with the equal sign to change the value of variables. We've been using the equal sign, which is the assignment operator, to assign the value on the right to the variable on the left. But you can combine the assignment operator with arithmetic or bitwise operators to perform an operation. And each time one of these assignment operators performs an operation, it assigns the result back into the variable. So with the addition assignment, it adds the value on the right to the variable on the left. With subtraction assignment, it subtracts the value on the right from the variable on the left. With multiplication assignment, it multiplies the variable on the left by the value on the right. With division assignment, it divides the variable on the left by the value on the right. Floor division assignment, floor divides the variable on the left by the value on the right. And if you remember, that returns a whole integer with the decimals removed. The modulus assignment operator computes the remainder of the variable on the left divided by the value on the right. And the exponentiation assignment raises the variable on the left to the power of the value on the right. And if we jump into the development environment, you'll see that I have created a number variable equal to 5, and down here I'm outputting the number. So before I actually start outputting this, I want to perform some kind of assignment operators on it. We'll start by doing the addition assignment operator. So I will do number plus equals, and I'm going to add 5 to it. So now when I output this, it's going to take this variable, add 5 to it, and then return that value back into the variable. And when we output this, we'll see that we get 10. Now, the reason for even doing this is because it is a shorthand way of typing this right here. So rather than having to type all this out where you're typing the variable name twice, you just shorten it to the variable and then the assignment operator and then the value. So the next one is the subtraction assignment operator. So if I subtract 5 from our number here, we're going to get the output 0. And then if we multiply 5 by 5, we're going to get 25. And if we use the division assignment operator, we'll get 1. And if we use the floor division, and let's change this to 2, we will get 2. Because 5 divided by 2 is 2.5, but floor division removes the decimal place and returns the whole integer. Then we have the modulus assignment operator, which is going to return the remainder. So 5 divided by 2 is 2 with a remainder of 1, and we will get the output of 1. And finally, we have the exponentiation assignment operator, which is going to raise 5 to the power of 2. And when I run that, we'll see that we get 25 as the output. The addition assignment and multiplication assignment operators also work on sequence types to perform concatenation and repetition. So I'm going to go ahead and show that too. I'm going to create a new variable called my_string, and I'm going to set it to the value of hello, and I'm going to put a space in there. And then for the addition assignment operator, I'm going to type my_string plus equals, and then a new string of world. And when I print my string to the console, it's going to concatenate these two together and output hello world. And if I wanted to repeat this string for whatever reason, I would use the multiplication assignment operator, which is the asterisk equals. And let's say I wanted to repeat hello 10 times. I would do times equal 10. And when I run this, we'll see that we get the output hello 10 times. Now let's look at the string data type. Strings are a sequence of characters that are enclosed with either single or double quotes. We've seen that I've used strings in a few of the videos doing the hello world, and you can see that we have double quotes on this one, but you could also use a single quote. Strings are a built-in data type to represent text in Python, and they provide numerous methods to manipulate, analyze, and format the text. Key features of strings is they are immutable, which means they cannot be changed. And this doesn't mean that you can't change the value of the variable. This just means you can't change the string itself. So I could change what message here equals and have it say goodbye world, but that wouldn't actually change this hello to say goodbye. It would create an entirely new string. Strings support indexing, which means characters can be accessed using indexing starting at 0. And you'll see here that I put this hello world in these little boxes, and each character is kind of in its own little box with a number starting at 0. So if I wanted to access the exclamation point from message, I would use these square brackets here with 11 in it because that is the index that the exclamation point's at, and it would return that exclamation point to me. Strings also support slicing, which allows you to receive a subset of characters. So if I wanted to maybe grab just the word world or just the word hello, I can use these brackets and then a colon with the starting number on the left side of the colon and the ending number, which is non-inclusive, on the right side of the colon. So with this one here where it says 0:6, it's going to go from 0 up to 6, but not including it, which will be HELLO in the space. Strings also support concatenation, which means that I could take two separate strings and use the plus operator to join them together. So if I had greeting here, which would just be hello in a space, and then name, which would be the word world, and then I use greeting plus name, it would make the string hello world. And they also use escape characters to put characters that would not be allowed in the string into the string. So they have a tab, which is a \t, which you could put a tab into the string just by adding a few spaces to it. But an actual tab, you would have to do \t. If you have a string where it is enclosed in double quotes, you would not be able to put another double quote in here because then Python would think that that's where the string is supposed to end. So you would put a / and then a double quote, and then you could put something in quotes in here. Or if you use double quotes to enclose the string, you could put a single quote anywhere in here. Or if you used a single quote to enclose a string, you could put a double quote anywhere in the string. Inside my interactive development environment, I'm going to create two variables. First one I will call greeting and give it the value of hello in double quotes. And the next one I will call question and give it the value of how are you in single quotes. And the only reason I did one in double quotes and one in single quotes was to show you that Python does not care which one that you use as long as whichever one you start with is also the one you end with. And on line 3, I'm going to concatenate these two strings together and pass that value into a variable named message. I'm going to do this by typing the first string greeting, and then I'm going to use the addition operator, the plus sign, and then typing in the next string, which is question. And then finally on line 4, I am going to print message to the console. When I run this, we'll see down here, we get the output, hello, how are you? But you'll notice that we don't actually have a space between hello and how are you. This is because unlike the print function where when you put multiple variables in here, it automatically adds the space. When you concatenate two strings together, it simply sticks them together exactly how they are. So to get that space in there, we could either add a blank space at the end of hello, a blank space at the beginning of how are you, Or in the concatenation, we can simply add a blank space into it and use another additional operator. And now we have 3 strings concatenated together. So when I run this, we'll see that we have hello, how are you? And it's all looks correct with the space in there. The next thing I'm going to show you is string repetition. So I'm going to create a new variable called laugh and set the value to ha. And down here in the print function, I'm going to change this to print out the value of laugh. But before I do that, I am going to repeat laugh 3 times. I'm going to do this by typing in the variable name, and I'm going to use the multiplication assignment operator, which is the asterisk equals, and I'm going to tell it to repeat this 3 times. So when I run it now, we'll see that it says ha ha ha. And this isn't really something that I would say is commonly used with strings, but it is commonly used with stuff like lists, where you want to initialize a set number of elements to a specific value, like a whole bunch of nuns or a whole bunch of zeros for integers, something like that. So the next thing I want to show you is multi-line strings. So I'm going to create a new variable called multi-line. And down here in the print function, I'm going to tell it to print out multi-line. And to do a multi-line string, you need to do what's known as triple quotes. So we have either 3 single quotes or 3 double quotes on either side of the multi-line string. And we're going to type in, this is a, oops, not sure why I capitalize that, multi-line string. And now when I run this, we'll see that it's going to output it into the terminal exactly as it's written here. And it is important to note that this does retain any white space that is either at the end of the line or at the beginning of the next line. And if I run this now, we'll see that it put multi-line way over here. And if I highlight this, we can see we have a bunch of empty spaces here. And the reason that this might be a problem is if you're trying to print this to a file or something, and the file only can go so many characters wide, and you have a whole bunch of blank space here for whatever reason, it's going to start affecting the rest of the file after that. And finally, I want to show you Python's built-in length function, which allows you to get the number of elements that are in a container. So I'm going to create a new variable called password, and I'm going to set it to be a very bad password of just password. I'm going to create another variable called password length. And the value that I'm going to pass in here is the number of characters that are in this string here. And I'm going to do that by using Python's built-in length function, which is just len. And then in parentheses, I'm going to pass it the password variable. And if I hover over length here, we can see that it returns the number of items in a container. So a string contains characters. So these characters would be the number of items in the string container. If it was a list or a tuple or something like that, it would return the number of elements in that list. And down here, I'm going to tell it to print out password length. And when I run this now, we'll see that I get the output of 8, which is how many characters are in our password. And if I wanted to make this password a little more secure, add some numbers and some special characters and run it again, now we get the output 12. Now let's look at how we can use indexing and slicing to get individual characters or substrings from a string. I've created the variable my_string and given it the value of hello world, and I am calling the print function and passing in my string. But I don't really want to output this entire string here. Instead, I just want to output the capital H. Now, the way we do that is by using indexing, which uses square bracket notation. So I'm going to type in my 2 square brackets here. And in order to get the first character, since Python is a 0 indexed language, that means that this first character is at position 0 and then 1, 2, all the way up to the end of the string. So I'm going to put in a 0 in these square brackets. So now when I print this, it's going to output just the capital H. And if I wanted to, let's say, grab the last character here, which is the exclamation point, I would put in the number of characters that are in this string minus 1, which in this case, there's 13 characters in this string. So I would put in a 12 here. And if I run this, we'll see that I get the exclamation point. I could also use negative indexing. So instead of putting in a 12, I would put in a -1, which would give me this last character here. If I run that, we'll see that I do get a exclamation point here. And I would do the same thing for any character in this string. So if I wanted, for example, this capital W, it is at 0, 1, 2, 3, 4, 5, 6, 7. It's at the 7th position. So I would put in a 7 here. And when I run this, we'll see that I get the capital W output. Now that you know about indexing, let's go ahead and look at slicing. Slicing is similar, where it uses the square bracket notations, but we can add in a colon here. Now, because I don't have a number on the left or right side of this colon, if I were to run this now, it will output the entire string. But let's say that I just want these first 5 characters here. To the left of the colon, I'm going to put in a 0 because I want it to start at the beginning of the string. And on the right side of the colon, I'm going to put in a 5. This 5 here would actually be at the position of this comma. So the way that slicing works is it goes from the starting number inclusive up to, but not including the number to the right. So this is just going to grab hello. If I run this, we'll see that. However, in this example, this 0 is actually unnecessary. If I don't put anything to the left of the colon, it's just going to grab whatever the starting position of this string is up to, but not including this end position. So if I run that again, we'll see that we get hello again. And it works the same way for the other side. So if I were to put a 7 here to start at the capital W and nothing on the right side, it would grab everything from the capital W to the end. If I put in, let's say, a large number here, like 20, we know that this string isn't 20 characters long, but it's not going to cause any issues. It's just simply going to grab from 7 up to whatever the last character in the string is. Slicing also supports negative indexing. So if I wanted to grab the word world, I would go -1, 2, 3, 4, 5, 6. So I would go from position -6 up to -1. And just like not using negatives, it is up to, but not including whatever is on the right side of the colon. So this actually isn't going to include the exclamation point here. And when I run that, we'll see that I only get the word world. So if I wanted to grab the end as well, I would simply leave the right side of the colon blank. And then we get the output world with the exclamation point. I'm going to show one more thing with slicing, which is you can add another colon here, and then a step or increment value. So if I wanted to grab every other character in this string, I would simply leave this blank, have 2 colons. So it's going to go from the start of the string to the end of the string, but it's only going to grab every other character. And if I run that, we'll see that we get HLO space OL exclamation point, which is every other character. And let's say that I wanted to instead grab every other character starting from world on. I could type in 7 here, and I'll go ahead and type in 13, which will get us the entire word world, including the exclamation point. And if I run that, we'll see that I get W, R, and D. Now let's take our first look at using the Python standard library documentation and using built-in functions and strings. Open up your browser and navigate to docs.python.org. It's going to bring you up to a page similar to this, although it might be up to a new version. You'll see a link here that says library reference. Click that. And we're going to scroll down a little bit. This right here contains all the different built-in functions, methods, classes, everything in the Python standard library. But right now, all we're interested in is under built-in types, text sequence type str, which is short for string. And if we scroll down just a little bit, we're going to see this header here that says string methods. And under this header, it tells us all the different methods that are built into the string class. So right here, you see str and then dot, and then the name of a function and some parentheses. Now, the way this works is this str you would replace with either a variable that contains a string, or you could use just the string itself. And then this is called dot notation. And then this is simply the method that the string has. And a method is just a function that belongs to a class. And if we look at this first one here, it says str.capitalize, and it tells us that this returns a copy of the string with its first character capitalized and the rest lowercase. And I'm going to jump into my development environment here. I'm going to go ahead and change this capital H to a lowercase h. And down here in the print function, I'm going to tell it to print my underscore string dot. And then when I type the dot inside a development environment such as Visual Studio Code, it's going to present me with a list of all the different functions and some other stuff that I can do here. So I'm going to go with dot capitalize. And then in the parentheses, we're just going to leave it blank. There's no need to put anything in here. So when I run this, we'll see that it outputs hello world with a capital H, even though it's a lowercase up here. Now we could also do this with the string directly. So if I were to type something like, this is a string, and run this, it will capitalize the T in this is a string. So So if we jump back into the website, it says the next one here is str.casefold, and it says it returns a casefolded copy of the string, which a casefolded string may be used for caseless matching. And it's saying that it's similar to lowercasing, but more aggressive so that it can handle non-English alphabets as well. So if we jump back into our development environment here, I'm going to put this back to a capital H. And this time we are going to tell the print function to print my underscore string dot casefold. And when I run this, it should lowercase everything in the entire string. So the H is now a lowercase and the W is now a lowercase. And I'm going to jump back into the documentation. And these were just the first two methods in the strings. If I scroll down, you can see that there are many methods that are associated with strings. So let's go over some more of these string methods and get a better understanding of how to read the Python standard library documentation. So inside the documentation, we are still in the string types under string methods. Let's scroll down here a little bit and we'll see that we have this method count here, and it takes the substring parameter, which is sub, and then it also has optional parameters for start and end. And it tells us under here that it returns the number of non-overlapping occurrences of a substring sub in the range start to end. Basically, start and end are used to slice the string. So if we tell it to slice from 0 start to 5 end, it's going to look in the first 5 characters of the string to see if this substring is in there. So let's go ahead and jump into the development environment where I have this weird AB string. And the reason I did this is because I want to show you that when I do this count, it's going to find the first occurrence of ABA. And then even though this right here is an occurrence of ABA, this A overlaps with the first occurrence. So because it's non-overlapping, it's going to skip this occurrence and go on to this one, and then finally this one, and it's going to return the value of 3. And we'll see that now. I'll type in my string.count, pass it in the substring of ABA. And when I run this, you'll see that we get the return value of 3. And if I wanted to use the optional start parameter, I would put a comma, and then let's say I want to start at index 4, which would be this A right here. It's going to find this occurrence of ABA and this occurrence of ABA and return 2, as you can see here. And then if I also threw in the optional parameter for end, it's only going to look at this substring right here to see if it finds the occurrence of ABA, so it will return the value of 1. So let's go ahead and jump back into the documentation and find another method. Scroll down just a little bit. We're going to look at the find method, which again takes a substring and a start and end parameter. And it says right here that it returns the lowest index in the string where the substring sub is found within the slice. And it tells us that it's going to return -1 if the sub is not found. So jumping back into our environment, I'm going to change this string here to you know you can do it. And I'm going to replace the count method with the find method. And then in parentheses, I'm going to tell it to look for the substring u. And when I run this, it's going to return 0 because it's going to find this u here, and it's returning the first index where it finds this substring. And since this substring starts at index 0, that's the index that it's going to return to us. And when I run this, you'll see that we get the output 0. And if I were to throw in the optional parameter of start and I put a 1 in there, now it's going to start looking at this string from the O here. So it's not going to find the first occurrence of u until here, which is index 9. And we'll see we get that output there. There are times in Python where either in the standard library or maybe a third-party module, you're provided with multiple methods that basically perform the same operation but handle them differently. So if we look at the find method here, it told us that it will return a value of -1 if it does not find the substring that we're looking for. So if I change this to look for a z, which is not in this string up here, and I run it, we'll see that we get a -1 just like the documentation told us. But if we jump back into our documentation and scroll down just a little bit, we'll see that we have this method here, which is called index, and it takes the same substring start and end parameters. And it tells us that it's like the find method, but it raises a value error when the substring is not found. So if we jump back into the environment, if I change this find to the index method, and I tell it to look for this z again, this time it's going to raise a value error. Now, the biggest problem that happens when an error is raised is it will crash the program if it's not handled correctly. So error handling is something that we're going to talk about much later in the series, but just keep in mind that there may be multiple built-in methods where one method may have a standard way of dealing with an error, such as returning -1, and the other way would raise an error, which will allow you to deal with the problem however you see fit. Now let's say that instead of wanting to know what the index was of the first occurrence of a substring, I just wanted to know if a substring was in another string. I can do this by using the in operator. Whenever you use the in operator, it produces a Boolean value of true or false. So if I wanted to, I could say the string u in my underscore string. And since u is in this string, this is going to output the Boolean value true. So when I hit run here, I get this output true. And if I tried to check for something that was not in this string, like the word your, and ran this, I get the output false. The in operator is something that we are going to cover a bit more in detail once we get to Boolean values, but just know that the in operator works on collections to test for membership, so it could also work on lists, sets, tuples, or dictionaries to see if an element is in one of those collections. If we scroll back up to our find, well, actually, you know what, let's go up to our count. If we take another look at this count method here, we'll see that the optional parameters start and end are inside square brackets. What this means is the parameter that is inside the nested pair of square brackets cannot be used until the outer parameter has been used. So I can't do something like type end equals and then set the ending index number. I have to set the starting index first. And this is in contrast to methods like in code where the parameters are shown as the parameter name equals and then a default value. So what happens with this method is if I wanted to change errors but not change encoding, I could just type errors equals and then set the value to be whatever I want it to be. Now that we've gone over a few more methods and how to understand the documentation a little better, let's jump back into the development environment and practice using more string methods. As you can see, I have some string variables set up and ready to go. And down here in the print function, I have the space string in here, and I'm going to go ahead and run this just to show that too many spaces does get printed out with all this extra space before it and after it, although we can't actually tell that the extra space is after it. It's there. So on the space string, I am going to use the strip method to remove that white space. So I'm going to type in .strip and some parentheses. And when I hover over this, it'll tell us that it returns a copy of the string with leading and trailing white space removed. If chars is given and not none, remove characters and chars instead. Chars would be an optional argument that we could pass in here. And if we don't pass anything in here, it's going to remove any white space. And if we did, it would look for the characters in that string that we pass in to remove from the beginning and end of the string. So when I run this, we'll see that too many spaces outputs and it's removed these spaces from the start and end. Next thing I want to show you is the left and right strip methods, which work just like strip, but left strip only works on the left side of the string and right strip only works on the right side of the string. And that's what I have the dash string here for, so that we can actually see this happen. So I'm going to switch this over to dash string and we'll start with the left strip. And for an argument, since I'm trying to remove dashes and not the white space, I am going to pass it in a dash string. And when I run this, we'll see that we get too many dashes with the dashes removed from the left side. And if I switch this over to our strip, it will remove the dashes from the right side. So now we have our string here with the dashes removed from the right side. And to show how the strip method actually works, I have this symbol string here that has a caret, asterisk, and dash, and they're not in any kind of order. And then there's a hashtag here on each side. So I'm going to switch this to the symbol string variable, go back to the strip method, and this time in parentheses, I'm going to pass it a string with the caret, asterisk, and dash in it. And how this works is it's going to look at this first character and see if this character is anywhere inside this string that we've passed in as an argument. And if it is, it removes it. And then it goes on to the next character and so on and so forth until it reaches a character that is not in this value that we passed in. Once the left side is done, it goes to the right side and it does the same thing. It checks the very last character against the string that we passed in. If it's there, it removes it and moves on to the next character. And it does that until it runs into a character that is not in the string. So when I run this, it's going to return this string here with all these symbols on either side of it removed. And when I run it, we can see that we get that string right here. The next methods that I want to show you return Boolean values, and they are ends with and starts with, and we're going to use those on this quote string here. I'm going to go ahead and get rid of this and put in quote instead. And we will start with starts with. And if I hover over this, it tells us that it returns true if S, which is the string that we're checking, starts with the specified prefix, which is the string that we are looking for, false otherwise, with optional start and end arguments for the start and end of the search. So if I wanted to start searching at not and end searching at bug, I could pass in some optional start and end parameters. But for now, we're just going to start at the beginning of the string, and we're going to look for the word it. And if I run this, because it is the beginning of this string here, we're going to get the output true. And if I were to look for the word is, which is not the start of this string, and run it, we get the output false. Ends with works the same way. It looks to see if the last characters in the string match the characters in the string that we pass in it. So if I look for the characters RE, it will return true. And if I looked for something that wasn't there, it would return false. The next method I want to show you is the replace method, which will take an argument to search for a substring within a string, and then another argument to replace that string. So I'm going to go ahead and do the .replace method here. If I hover over it, it tells us that it returns a copy with all occurrences of substring old replaced by new, and then it also has an optional count, so that if I wanted to only replace 1, 2, 3, or however many I specified, that's all it would replace. So for this, I'm going to go through and replace all the spaces with dashes. So for the first argument, I will put in a blank space between some quotes. And then the second argument, I will pass in a dash. And when I run this, it will return this quote with dashes instead of spaces, which we see right here. And then if I wanted to, I could pass in an optional argument of, let's say 3, so it only replaces the first 3 spaces. And if I run that, we'll see that here. It is not A is separated by a dash, and then the rest of the quote is separated by spaces. The next method I want to show you is the split method. So I'm going to go ahead and remove the replace method here and put the split method in. And if we hover over this, it tells us that the split method returns a list of the substrings in the string using sep as the separator string. When set to none, which is the default value if we don't pass in any arguments, it will split on any white space character and discard empty strings from the results. So what that means is that if I don't pass in any argument here, it's going to split this string at each one of these spaces, and it's going to return all these individual words in a list. So if I run that now, we'll see that we get this list output down here, which is denoted by the square brackets, and then separated by commas are the individual words that are inside quotes indicating that they are strings. Now, if I wanted to split this at a specific character or a specific word, I could pass that value in. So let's say I wanted to split it at the word is. If I run this, we'll see I get it, not a bug it, and a feature. And you'll notice that the word is not in this list. So if you were to do this, and maybe there's a word in here that has the characters is in it, so I'll go ahead and just add them in the middle of the word feature here. If I run this, we'll see that it actually splits it there too. So if you're going to split it by a word, just be mindful that that might also split actual words where you don't want it to split. The next thing I want to show you is method chaining. So when we call this method here, it is returning a value, and that value can have another dot notation method call on it just the way this one here could. So I'm going to change this back to dash string. And the first thing that I'm going to do is strip it of its dashes. So I'm going to go ahead and call the strip method and pass in a dash as an argument. And this is going to return the string too many dashes. So right here, I can do another dot notation. And this time I can call the upper method, which will change all these characters to be uppercase. And then I can call the split method, and I'm going to leave it blank. And when I run this now, it's going to return this here as a list with these 3 words in it, all uppercase. When I run that, we'll see that we have our list with all uppercase words down here. The last thing I want to show you in this video is the join method. And just to make this a little bit easier, I'm going to create a new variable called myList, and I am going to give it the value that is returned by our chain methods here. And then down here, I am going to use the join method. Now the join method takes a string and it inserts that string in between iterables. So I'm going to go ahead and type in a blank space, and I want to rejoin my list, which is currently this list of the uppercase 2, many, and dashes. And I want to rejoin it into a single string that is separated by spaces. So I'm going to do a space, then dot join, and then in parentheses. And if I hover over this here, it's going to tell us here that it concatenates any number of strings. The string whose method is called is inserted in between each given string. So in the join method here, I'm going to pass it my list. When I run this now, we will get the output string too many dashes. Now, if I wanted to, I could add maybe 2 dashes in here. And if I run this, we'll get too many dashes again with the dashes in here instead. This works on any iterable. So a string is an iterable. You can iterate over each of these characters. So if I wanted to, I could pass in the dash string. And if I run this, it's going to give us this here, which is a whole bunch of dashes where it's trying to put these 2 dashes and spaces in between every single character that's in this string here. Now let's take a look at how to use escape characters in strings. Here's some examples of escape characters, which must be preceded with a backslash character. And the first one is the backslash, which represents a literal backslash character. Now, if you were doing something like printing out file paths, which contain a lot of backslashes, if the backslash happened to precede an N, Python would think that you were trying to insert a new line. So in order to avoid those kind of issues, you would always want to do 2 backslashes, which would then output 1 to either the console or the file that you were trying to print it to. Next are single and double quotes. If you have a string that's enclosed in single quotes, you can put double quotes in it and it won't be an issue. However, if you were trying to put a single quote inside a string that's enclosed in single quotes, you would have to precede it with the backslash character. Otherwise, Python will think that that's where you're trying to end the string at. And the same thing goes for double quotes. Next is the new line character, which represents a line break or a new line character. And this pushes all the text to the right of this escape character down to the next line. Then we have the tab, which just inserts a tab. Then you have the carriage return, which represents a carriage return. And what this does is it brings the cursor back to the beginning of the string and then starts overwriting the beginning of the string with whatever is after the carriage return. Then you have a backspace, which will just insert a backspace and delete whatever character immediately precedes it. And then you have the form feed character, which is not used very often anymore, but it will be used to push the cursor to the next form or page. Then you can insert characters based on their octal value, or you can insert characters based on their hexadecimal value, or you can insert Unicode characters using a 4-digit hexadecimal value or an 8-digit hexadecimal value, and you can insert Unicode characters by name. If we jump into our development environment, we can go ahead and start practicing these. The first character we'll look at is the backslash. So if I were to put this backslash just right here in the middle of the string and it has no escape character right after it, Python has no problem with this. So when I run it, it'll output hello world with the backslash in there just fine. However, if I were to try to put this backslash somewhere like before this R, it would now think that I'm trying to insert a carriage return here, and it would move this cursor back to the beginning of the string and start overwriting the string with whatever is to the right of the carriage return. So when I run that, we'll see that we get this jumbled up string right here. So in order to actually put a backslash before the R here, I would have to put 2 backslashes. Now Python knows that I'm trying to insert a backslash here. So when I run this, we'll get the hello world with the backslash before the R. Next thing we can look at is quotes. So this string here is enclosed in single quotes, so Python will have no problem with me putting double quotes inside the string. And if I run this, we'll get the output with the double quotes around world just like we expect. However, if I wanted to put single quotes in here, now all of a sudden Python has no idea what this world is doing here. It thinks the string ends at this single quote here. So if I wanted to enclose world with single quotes, I would put the backslash before them. And now it'll properly print with the single quotes around the word world. And it's the same with double quotes. If I had a pair of double quotes enclosing this string, I would not need the backslashes to print out single quotes inside of it. If I run that, works just fine. However, if I wanted the double quotes in there, it's going to think that that's where the string ends and start throwing up errors. I'm just going to go ahead and put the backslashes before these double quotes and run it, and then we can see we have world enclosed in double quotes. Next up, we have the new line character. So if I wanted to print hello on one line and world on the next line, I would put a \n in, and it would do just that. And we can see down here that we get hello on one line and world on the next. And we can also put in tabs. So if I run this now, we'll get a big space between hello and world. Then we have the carriage return, which will move this cursor back to the beginning of the string and start overriding these characters with whatever characters are after it. So if I run this, we end up with just world and an exclamation point. Then we also have the backspace character. So if I were to run this here, it is simply going to remove the space that's right before it. And if I run that, we'll see that we have hello world and they're kind of stuck together with no space between them. We can also insert characters based on their hexadecimal value, and we do this by doing a \x and then the 2-digit hexadecimal value. So for the new line character, the value is 0A. So if I run this now, it's going to insert a new line in right here. And if I run that, we'll see that we get hello world on 2 separate lines. We can also insert characters based on their Unicode character by doing a \u and then doing either a 4-digit or 8-digit hexadecimal value. So if I wanted to insert a smiley face here, I would do \u and then the 4-digit hex character for the smiley face, which is 263A. And now when I run this, we'll see that we get the output hello and a little smiley face right there. We can also insert characters based on just their name. And we do that by doing a \N and then in curly braces, we would put the name. So if I put in the name snowman and I run this, it's going to output hello and then this little snowman. And that's it for escape characters. As you can see, they are very easy to use. Now let's look at the different ways that we can format a string. In the documentation, we'll see we have this str.format, and then in the parentheses, we have asterisks, args, and then 2 asterisks and kwargs, which is commonly pronounced as kwargs. Now, I'm not going to get into what args and kwargs are right this moment. We'll get into that when we get to the functions. However, just know that args means I can pass in a variable number of values, and kwargs means that I can pass in a variable number of key value pairs. If we jump into our development environment, we'll see that I have some variables here for name, age, and job, and then I have a person string, and this is the string that we're going to be formatting here. And it says her name is, and then it's got these curly braces here. Well, these curly braces, wherever they're at, is going to be replaced by a value that I pass into it using the format method. And there are a few different ways that we can get the correct values into these curly braces. So the first thing we're going to do is we're going to type in our .format method on our string. And in this method, we are going to pass it the values that we want to replace these curly braces. So for the first one, I want it to be her name. So I'm going to type in the name variable. The second one, I also want to be her name. So I'm going to type in name again. The third one here is the age. So I'm going to type in the age variable. And finally, the fourth one is the job. So I'm going to type in the job variable. And now if I run this, you'll see that it's replaced these curly braces with the correct values that I have in these variables here. So down here, we get the output. Her name is Tina. Tina is 25 years old and a software developer. Another way that we could replace these curly braces is by using indexing. So let's say I want the name variable to be index 2. In the curly braces here, where I want the actual name Tina to go, I would put a 2 to indicate that that is index 2. Then if I wanted age to be in index 0, I would put a 0 in the curly braces where I want age to go. And then finally, if I wanted job to go into index 1, I would put job into index 1. Now you do have to make sure that you don't put more index numbers here than you're going to put variables down here in the format method. So now I can go back into my method and replace these variables with the first index, which will be 0 for age. So age goes in first. And then 1 is for job. So I will put job in second. And this is because if you recall that Python is 0 index. So this is the 0 position, 1 position, and now the 2 position, which I will be replacing with name. And as you can see, this allowed us to use less variables in the format method by reusing the same variable wherever it's going to go multiple times. So when I run this, we'll get the output of her name is Tina. Tina is 25 years old and a software developer again. The next thing that we can do is use a key value pair. So I'm going to go ahead and remove this name variable here. And up here, I'm going to change name to be a variable name underscore name. And I'll do the same thing in this set of curly braces here, underscore name. And I'm just doing the underscore to keep it different from this variable over here. And for age, I will leave it as index 0. And for job, I will leave it as index 1. So that can stay there. But now to replace this underscore name, I'm going to type underscore name equals, and let's make her name Debbie now. So if I run this, we'll get her name is Debbie. Debbie is 25 years old and a software developer. And as you can see here, formatting strings is pretty easy, and using the format method provides you with some flexibility to work with strings. Now, an issue that might arise is this string might be way up somewhere else in the code where you don't remember exactly how it was set up. So another way that we can format these strings, I'm going to go ahead and remove this format method here, is by using an F string. So to use an F string, before the quotes in the string, you would put either a lowercase or uppercase f. And as you'll see, it changed the color of my curly braces from blue to this orange color. And it's giving me errors because this variable right here does not exist. So I'm going to go ahead and change this to the variable name that does exist, name. And this allows us to directly replace this value in the curly braces with the variable without having to use the format method. And for here, I'm going to pass in the age variable. And for the last one here, I'm going to pass in the job variable. So if I run this, we'll now see her name is Tina. Tina is 25 years old and a software developer. Now, personally, I use this method almost exclusively. I almost never use the string.format method, but whatever works for you, whatever's easiest for you, that's what you should use. With string formatting, you can also use format specifiers, which are helpful when you're working with numbers, dates, stuff like that. So I'm going to go ahead and take all this out, and I'm going to create a variable pi equals 3.141592. Just going to go out to 6 decimal places there. And for my string, I'm going to call it pi string equals. The value of pi is approximately, and then I'm going to do my curly braces. And I forgot to add the F at the beginning of it. In the curly braces, I'm going to put pi, and then I'm going to do a colon. And then after the colon, I'm going to put 0.2. And then I'm going to create a print function to output the pi string. And if I run this, because I have this colon 0.2, it's going to only print out 3.1. The value of pi is approximately 3.1. That's because this is telling it to format the decimal place to only show 2 numbers. Now, if I put an F after this 0.2, it'll show it as 3.14 because now it's looking at it as this should be the number of digits after the decimal place. And I could change this to, let's say 4, and we'll see that it gives me 4 decimal places now. You can also use string formatting to add some space either before or after a variable. So if you were trying to print something to the console and we're trying to maybe make it look like a table, and you kind of needed to maybe center up some headings and stuff like that, you could, after the colon, put a right chevron to say that it should be aligned right. And then if I throw a 20 in here and I run this now, you're going to see that it gives me this big old space between the value of pi is approximately and the actual number, because Python has interpreted this to make the space before the number and the number itself total up to 20 characters. To see all the different ways of formatting a string, you can go back into documentation. If we scroll up here, back up to where the string methods header is, there is a link right here called Format String Syntax. And if you click that, it'll bring you to the format string syntax header, where it has all the information that you would need about formatting strings and tons of examples. Now let's look at how to convert one data type to another data type using casting. It allows the programmer to change the variable or value to match the data type for an operation or a requirement. It is beneficial when you need to perform operations that are for specific data types or you need to ensure data compatibility. However, not all casting is possible or meaningful. If I try to convert a string that does not contain a numeric value into a float, it would raise an error, and if I didn't handle that error, it would crash the program. As you can see, I am on the Python Standard Documentation Library website, and if I click on Library Reference and then scroll down just a little bit, there is a link here for built-in functions. I'm going to click on that. And this is the list of all the built-in functions that comes with the Python standard library. And it says the Python interpreter has a number of functions and types built into it that are always available. Now, the functions would be like len for length or print for print, which we've already seen, but it also has types. So range, set, tuple, int, float. These are all types. And to create an object of that type, we could put in the function name for that specific type and pass it a value. And if it can convert that value that we pass it into that data type, it will, and it will return it back to us. So I'm going to click on the type function here. And you'll notice that there is class type that takes a single object and then class type that takes a name, bases, dict, and keyword arguments. We're going to focus on the class type object. And here it says with one argument, which would be this one here, return the type of an object. The return value is a type object and generally the same as the object returned by object dot underscore underscore class underscore underscore. The isInstance built-in function is recommended for testing the type of an object because it takes subclasses into account. Going to jump into my development environment here and you'll see that I have result equals none and I am going to output result. So the first thing I'm going to do is replace none with the type function. And in the type function, I am going to pass it the integer value 5. And when I print this out, we'll see that we get the output class int. And if I were to change this to 5.0 and run it, we will get class float. And if I were to enclose this in quotes to make it a string and run this, we'll get class str, which is short for string. So now let's look at some actual data conversions. So I'm going to type in float to call the float function, and I'm going to pass it the value of 5. And what it's going to do is it's going to take this integer value 5 and convert it to a float by adding a decimal to it. So when I run this, I'll get the output 5.0 instead of just a 5. And if I wanted to, I could pass in a string decimal here. So I have 3.14 in quotes. And if I pass this in, it will convert it to 3.14. And if I were to simply print a string out, we would also see it as 3.14. So I'm also going to print an isInstance function call, pass it in my result variable, and it takes a second argument, which is the class that I want to see if the result is an instance of. So in this case, I want to see if it's actually turning it into a float. So I'm just going to type in the class name float here. And when I run this, I'll get my 3.14 and also outputs true because isInstance is returning that it is true that result is now a float. I'm going to go ahead and remove this, and I want to show you that there are some issues that can happen with casting. So if I were to try to convert this 3.14 string to an int by calling the int function and passing this value in, it is going to raise an error. It's saying that it's an invalid literal for int with base 10 3.14. Basically, you cannot pass the string value of a float into the int function because it does not know how to convert the string version of this float into an int. However, I could pass the float function into the int function with this string float here, and it will convert it to a 3 integer just fine. And how this works is the float function first returns the float value 3.14, and then the integer function takes that value 3.14 and converts it into a 3. I could also convert numbers into strings by using the string function. So if I did str and passed it 3.14, when I run this, I get the output down here is 3.14. So let me wrap the result in the type function. So it prints out the type that this is returning. And when I run this, we'll get class str for string. There are also conversions that you can do that are not quite so intuitive. So if I wanted to, I could convert int and pass in the Boolean value true. And when I run this, it's going to print out the value 1. Because when I pass true into the int function, the return is 1. Now, if I passed false into the int function, the result would be 0. And this works the other way too. If I were to call the bool function and pass in the integer value 1, this is going to return true. And if I passed in a 0, this bool function will return false. In the Python language, there's the concept of truthy and falsy, which involves using values here to determine if they are inherently true or inherently false, but that is something that we will go over more once we get to the Boolean section. Now let's start working with the list data type. Lists are versatile and widely used in Python due to their flexibility and ability to hold different types of data. They are useful for storing collections of related items, iterating over elements, and implementing various algorithms and data structures. Some of the key features of lists are that they are ordered, meaning that the order of elements is preserved and predictable. They are indexed, which means you can access each element by its index starting at 0. You can use slicing on lists to extract a subset of the list. They're dynamic, meaning that the list can grow and shrink as necessary. They contain heterogeneous elements, which is just a fancy way of saying that you can put different data types inside a list. So you can have strings, integers, floats, or any other object in a list. And they are mutable, meaning that you can add elements, remove elements, or modify the elements that are inside a list. Over here on the right side of the slide here, you'll see some of the common list methods. Append adds an element to the end of the list. Insert adds an element at a specified index. Remove removes a specified value from the list. Pop removes and returns an element. Sort sorts a list, and you can either sort it in ascending or descending. Reverse reverses the elements in a list. Clear removes all elements from the list. Extend adds the contents of an iterable to the list. Count counts the number of occurrences of a specified value. And index returns the first index of a value. And if we jump into the development environment, we can take a look at creating a list and using a couple of the methods to add elements to the list. There are two ways to create a list. The first way I'm going to show you is by using a pair of square brackets. And then inside the square brackets, you would pass the elements that you want to be in your list separated by commas. So if I wanted to pass in the string values cat and dog, I would separate them by a comma. And if I run this, we will get an output down here of a list containing the elements cat and dog. The other way to create a list is by using the built-in list function. And if I hover over this, it says that if no argument is given, the constructor creates a new empty list. So if I run this here, we'll get the output down here of an empty pair of square brackets. Now the argument that goes into a list function is an iterable, meaning objects such as strings, list, tuples, sets, anything that can be iterated over. So if I try to use the list constructor to create a list, and let's say I want to pass in the single element of cat, when I run this, it's not going to pass in the single element cat into the list. It's going to iterate over this string and take the individual character elements. So when I run this, we'll get the list down here of CAT instead of just cat. So to correctly pass in a list where if you just wanted a single element inside the list constructor, you could just close it in square brackets, and now the constructor will see this as a list containing the single element cat and create our list with just one element correctly. I'm just going to change this list function back to being a pair of square brackets, and I'm also going to add the element dog to it. Now if I wanted to add an element to the end of this list, I would use the append method. I would type my variable name for my list, or you could just use the list directly. And then I would do dot for the dot notation and append. And then in parentheses, I would put the object that I want to append. And if I hover over here, it says it takes one object and it appends the object to the end of the list. So, and this could be any object. Lists can handle different data types. So if I pass in the integer value 1 and run that, we'll see that my list now contains cat, dog, and the integer 1. But just to keep it simple, I'm going to pass in more string values of animals. So I have cat, dog, and cow now. And I'm going to go ahead and move cow up into my list. And if we wanted to insert an element somewhere that's not at the end of the list, we would use the insert method. So I'm going to replace append here with the insert method. And if I hover over this, it tells us that it takes an index, an object, and it inserts object before index. That means if I wanted to insert an object before dog, I would have to pass in the index value of dog and then whatever object I want. So dog is at index 1. So I would do 1, comma, and now I want to pass in duck. So now when I run this, it's going to insert duck right here between cat and dog, and it's going to output my list down here, cat, duck, dog, cow. Now let's say that you have another list. So I'll create a variable called myOtherList, and I will pass it the values horse, and I'll go ahead and add duck in here as well. If I wanted to combine these two lists, there's two ways I can do this. I can use the extend method. And if I hover over this, it says it extends list by appending elements from the iterable, and it takes an iterable as an argument. So just like with the list constructor that takes an iterable, if I passed in a single string value in here, it would separate the characters and extend this list with the characters, not the string itself. So I would have to make sure that I actually pass it a list or a tuple containing the strings that I want to extend the list with. So I would do the list that I want to extend, and then the dot notation, the extend method, and I would pass in the list that I want to extend it with. And if I run this, we'll see that we get cat, dog, cow, horse, and duck down here. Now you could also, instead of using the extend method, you could use the additional assignment operator by typing plus equals, passing in your other list or any iterable and running that. And then you also get your lists joined together that way. You can access elements in the list by using indexing. To do this, after your variable containing the list or the list itself, you would put a set of square brackets, and then inside the square brackets, you would put the index of the element that you want. So in this case, if I wanted the element cow here, I would start at 0 at cat and then go 1, 2. So cow is at index 2. And if I put that in the brackets and run this, we'll get the output cow. Similarly, if I wanted duck, I would go 0 at cat and then 1, 2, 3, 4. So duck is at index 4. So I would put that in my square brackets. And when I run this, I get the output duck. This also works with negative indexing. So if I wanted duck, I could do -1. And if I run that, you'll see that I do get the output duck. And if I wanted cat, we start at -1 at the end and go -2, -3, -4, -5. So when I put in -5 here, I get the output cat down here. We can also modify the elements of the list using indexing. I'm going to go down here. I'm going to type in my list. And then in the square brackets, let's say that I want to change dog to pig. So I'm going to put in 1 for the index of dog, and I'm going to do equals, and I'm going to put in pig. So now when I run this, it's going to output my list, which is now going to be cat, pig, cow, horse, duck. And when we run it, we'll see we get that down here. Lists also allow you to use slicing to retrieve a subset of the list. So I'm going to go ahead and remove that. And down here on my list, I'm going to put my square brackets back in, and to use slicing, you would put either a single or 2 colons into the square brackets. If you do just a single colon, on the left side will be the starting index, and on the right side would be the ending non-inclusive index. So if I wanted to start here at cat, I would either put in a 0 or I could just leave it blank. And then on the right side, let's say I wanted cat, dog, and cow. In order to get cat, dog, and cow, I actually need to put in the index for horse because it's going to be up to but not including this number here. So if I run this, we'll see that I do in fact get cat, dog, and cow. Now if I add another colon after the ending non-inclusive number, I can put a step or incremental value. So after each item that it retrieves, it will skip whatever this number is time. So if I were to put in here a 2, and let me go ahead and change this to a 5 so that it iterates over the whole list. It's going to grab cat, and then it's going to skip 2. It's going to go dog, and then cow, and then it's going to grab cow, and then it's going to skip 2 more and go over horse and grab duck. So now it's going to output cat, cow, and duck. And if I run that, we'll see that we get that down here. I could also make this 4. So now it's going to grab cat, and then it's going to skip 1, 2, 3, 4. and grab duck. And down here, I'll just get cat and duck. There will likely be many times where you are going to need the length of your list, especially if you're iterating over it in a for loop. And to get the number of elements in that list, you can use Python's built-in length function and pass your list in as an argument. And when I run this, it's going to output the number of elements in the list here, which just happens to be 5, and that's what we get down here. Now I want to show you ways to remove elements from a list, and the first one is the remove method. So I'm going to go ahead and take this length function out and put my list variable back in and type dot remove. And if I hover over remove here, it's going to tell us that it takes a value and it returns none, and it's going to remove the first occurrence of the value. And it raises an error if the value is not present. And by first occurrence, if I were to add cow to the end of this list here, so I have 2 cows in there now, and I tell it to remove cow, it's going to remove cow, and this is just going to return none. So down here, I get the output none. So I'm going to put in another print statement to print my list after we do the removal of cow to see that we get cat, dog, horse, duck, and cow, and this first occurrence of the string cow has been removed. And if I were to try to remove something that's not in there, like just co, and run that, we'll see that it raises an error and crashes the program because I did nothing to handle the error. You can also use the delete keyword, which is del, and then pass in what you would like it to delete. So in this case, I am going to tell it to delete my list at index 2, which is cow again. And this time here, when I print out my list, we will again see that I get cat, dog, horse, duck, and cow with this cow here removed. There is also a pop method. And the way the pop method works is if I don't pass an argument in here, it defaults to using -1, which will be the last element in the list, and it removes and returns the item. So if I run this now, it's actually going to remove cow from the list and return it. So if I do this print statement here, it's just going to return cow, and I'll add in another print statement to actually print out the entirety of my list. So when I run it this time, we'll see that we get cow because it's returning this element back to us, and then it's also removing it from the list, and we can see that cow is no longer at the end of our list here. We can also pass in an index. So if I wanted to say remove dog instead of cow, I could pass in the index, and it's now going to output dog, and then underneath that, when it prints the list, it's going to have cat, cow, horse, duck, and cow again. And when we run that, that's what we get down here. The last thing I'm going to show you for removing elements from the list is the clear method. The clear method removes all elements from the list, and we use it by typing our list variable and then doing the dot notation and typing in the method name clear. So when I run this now, it's going to clear my list and then output an empty list into our console. Click run, and down here we have an empty list now. Now let's go over the different ways that we can sort a list. As you can see here, I have an animals list containing some animals, and right here I'm going to print some information about this list. So the first thing I'm going to show you is the sort method. So on the animals list variable, I'm going to put .sort and some parentheses, and I'm going to hover over this so that we can see some information about it. And it says it sorts the list in ascending order and returns none. And it also says that the sort is an in-place sort. The list itself is modified, and it's stable, meaning that if there are 2 of the same elements in here, it will leave them in the order that they are in. So if I were to run this right now, you're going to see that I just get the output none. So in order to actually see the results of this sort, I will need to put in another print statement to print out my list. And when I run it this time, we'll see that it does output it in alphabetical order with cat, chicken, cow, duck, horse, and lizard. Now if I mouse over sort again here, we can see that it takes a key function, and the key function is a function that we can either create or use a built-in function, and it's going to pass the value in our list to that function and then return a value. And that value that gets returned is how it is going to sort the list. So what we're going to do is sort these using the built-in length function and sort these animals by the length of their names. So in the sort method, we're going to type key equals len. And we don't need to put any parentheses and we don't need to pass any values. We just want to put the name of the function in there. So now when I run this, we're going to see that it comes out in order from the shortest one, cow, to the longest one, chicken. And we'll notice too that cow and cat are not in alphabetical order. So keep in mind that if you do use the key, that it only sorts by that key. It will not sort it in any other way. And if we wanted to, we could throw in the reverse Boolean by typing reverse equals. And then I'm going to pass it the value of true. So now when I run this, it is going to reverse that order and sort them in descending order from the longest name down to the shortest name. The next method I'm going to show you is the reverse method. So I'm going to change this sort to reverse. What this reverse method is going to do is reverse the order of elements in this list in place. So chicken is going to become index 0, cat's going to be 1, duck's going to be 2, all the way down to cow, which will be 5. And if I run that, we'll see that we get chicken is the first one, cat is the second one, duck is the third one, all the way up to cow. The next thing I'm going to show you is Python's built-in sorted function, which actually returns a new list. So instead of just printing it out, I am going to create a new variable called result equals, and then I'm going to type in the sorted function name. And if I mouse over this, it's going to tell us that it takes an iterable, which in this case we are using a list, and then it takes a key so we can set our own function to determine how to sort the list. And then it also takes the reverse Boolean. And if I scroll down, it tells us it returns a new list containing all the items from the iterable in ascending order, unless we use the reverse equals true. And a custom key function can be supplied to customize the sort order. So if I were to pass it the animals list, and then down here, print out the result and run this, we'll see that we get our animals out in alphabetical order. And then I could pass it the key equals len. And if I run it now, we'll see that we get our animals in order by the length of their name. And finally, if I pass it the reverse Boolean, if I could get that pop-up to stop, reverse equals true. And if I run this, we'll get the output of our list with reverse order of the length of their names. If I hover over this sorted function here, we will see right here, it says that it always returns a list, meaning that if we put any other iterable in here, it is going to put those elements into a list and then return it to us. So if I go ahead and let me go ahead and remove all this, and just to avoid any confusion, I'll go ahead and get rid of our animals list here. So if I have result equals sorted and I put in a string here that says hello world, it is going to take these individual characters, sort them by their ASCII Unicode values, and return that list in sorted order. And if I run that, we'll see that we get this output here where we have a blank space and then the exclamation point and then the comma, the capital H, capital W, etc. until we get to the end of it. So just keep that in mind. If you ever want to sort any kind of iterable at all, this sorted function right here works great for that. It doesn't only work on lists. Now let's take a look at how to use multi-dimensional list. A multi-dimensional list is just a list that is inside another list. It can also be referred to as a nested list. And right here I have this variable matrix, and it contains a list that has 3 lists inside of it. And just to make this a little bit easier to look at, I'm going to change the way it's formatted here. So now when we look at it, we can look at it as each element that's in our outer list is a row, and then each element that's in the 3 inner list is a column. And to access an element that's in one of the inner lists, we would simply use an additional pair of square brackets. So if I wanted to, I could output this 5 here by typing in my matrix variable name using a set of square brackets. And this first set of square brackets is going to determine which element in the outer list we access. And since I want to access this second element in the outer list, I'm going to use index 1. And then if I want to access this 5, which is the second element in this list, that would also be index 1. So I would do a second set of square brackets, put a 1 in it. And now when I run this, I will get the output 5. If I wanted to access this 7 right here, this is the third element or second index in the outer list. So I would change this one here to 2. And it is the first element or the 0 index in the inner list. So I would change this to a 0. And when I run this, we'll get the output 7. You can go as deep with this nesting or multi-dimensions that you want. So if I wanted to, I could change this 5 here to be another list containing 1, 2, and 3. And now if I wanted to access this 3, I would use 1 for the first bracket to access this element here. Then I would use 1 for the second bracket to access this element, which is our third dimension list. So I would put a 1 there. And then I would create a third set of brackets. And let's say I wanted this 3, I would put the 2 because this 3 is at the second index in this list. And now when I run this, I will get the output down here, 3. Multi-dimensional lists can be a little tricky to start working with, but after you do it a few times, it becomes second nature and you won't have any issues and you can go as deep as you want. So if I wanted to, I could go one more level in, add a fourth set of brackets. And if I wanted that 1 right there, I would put a 0 in it. And if I run that, I get my 1 here. So I do encourage you to practice this, see how deep you can go without confusing yourself, and just play around with it until you really understand multidimensional lists. Now let's look at how we can create lists using list comprehension. List comprehension is a powerful way to generate a new list by performing some sort of computation or transformation on items or elements that are in an existing iterable. The basic syntax for a list comprehension is the new variable name equals, and then in square brackets, expression for item in iterable if condition. The expression defines how each item in the new list should be computed or transformed. The item is a variable that represents each item in the iterable. The iterable is any iterable, such as a list, a tuple, a string. And the condition is optional, and it's a condition that filters the items based on a Boolean expression. In my development environment here, you'll see that I have a numbers list, which is 1 through 5. I have a new list that is going to contain the list that my list comprehension creates, and then I'm going to output that new list. The first example of list comprehension I'm going to show you is by creating a list containing the squares of each of these numbers. So the first thing I'm going to do is put in a set of square brackets, and then I'm going to put in my expression, which is going to be num raised to the power of 2 for num in numbers. So this is my expression. This is for item in my iterable. So when I run this, it is going to, for each of these values, take that value, raise it to the power of 2, and add it to this list until it has gone through each and every one of these values. So when I run this, we'll get the output 1, 4, 9, 16, and 25, which are the square values of this list. The next example I'm going to show you is getting the even numbers out of this list by adding a conditional statement down here. For my expression, it's just going to be num for num in numbers if num modulus 2 is equal to 0. And the way this is going to work is this is my expression. This is my for item in my iterable if, and then this is my condition. And if you'll remember, the modulus operator returns the remainder of a quotient. So if this equals 0, it's going to put it in this list. And when I run this, it's only going to grab the even numbers, which would be 2 and 4. And we'll see that down here, our new list contains only 2 and 4. So as you can see, list comprehension is a powerful way to create new lists and filter specific items out of an existing list. Now I'm going to show you how to repeat the elements in a list using the multiplication operator. And the reason I waited until I got to list comprehension to show you this is because there's an issue that can arise if you try to do repetition using mutable objects such as empty list that list comprehension can help us solve. So I'm going to go ahead and remove all this and create a new variable called my_list, and I'm going to give it the single element of a 0. And then I'm going to use the asterisk to repeat it 10 times. And then I'm going to use a print command to output my list so that we can see that it creates a list containing 10 zeros, which we have right here. And if I were to go in here and maybe change the second index to equal something else, such as a 4, and print my list out again, we'll see that our second index is 4 right here with no issues. But let's take a look at what happens if we do this on a mutable object such as a list. So I'm going to go ahead and remove this line here, and I'm going to replace this 0 with an empty set of brackets, so it's an empty list. And I'm going to create 10 empty lists here. When I run this now, we'll get the output of our 10 empty lists, which is expected. But now if I wanted to change this second index here, I could go back up here, do my underscore list, second index, and because these are empty lists, there's no index for us to set a value to, so I have to append it. And if I try to append it 4, it's going to run just fine, and I'll show you that it does. I'll comment the printout so that we don't see that. You'll see that it runs just fine. There's no crash or anything, but it changes every empty list in here to contain the element 4. And the reason being is that because this is a mutable object, this repetition actually creates 10 references to the same list. So in order to fix this, we can use list comprehension. So up here, instead of using the multiplication operator to repeat this 10 times, we're going to use list comprehension by putting in an empty list for our expression. And then I'm just going to say for I in range and pass in 10 for my value of range. And I'm going to go ahead and remove this for now. And if I run this, we'll see that I again get 10 empty lists. But this time, if I attempt to append a value to the list at our second index and run it, we'll see that it sets that to have an element of 4 and all the rest of them are still empty. So this is an issue that happens when you're using default values with mutable objects such as lists that you kind of got to be aware of. There's another issue that we're going to run into when attempting to use a list as a default value in a function parameter, but we'll get to that once we get to the function section. Now let's take a look at working with tuples in Python. Some key features of tuples are that they are immutable, meaning that once you create one, the elements cannot be modified after creation. They are ordered. The order of the elements is preserved and predictable. They are indexed, so you can access the elements by an index starting at 0. They support slicing, so you can get subsets of the elements. They support packing and unpacking. Packing is where you put a number of elements into a single variable, and unpacking is where you put the elements of a tuple into multiple variables. And they support heterogeneous elements, meaning that each tuple can store different data types. Common tuple methods are the count and index method. Since tuples are immutable, they don't get a bunch of methods to work on them like lists do. The count method retrieves the number of occurrences of a specified value, and the index method returns the index of the first occurrence of a specified value, and it raises an error if the value is not found. If we jump into the development environment here, you'll see that I have a variable number set up and ready to go to create a tuple, and the print function to output it to the terminal. So there are a number of different ways to create a tuple, and the first one that I will show you is the parentheses. An empty set of parentheses will create an empty tuple. Now, if I wanted to add some elements here, I would just simply separate them by a comma. And if I run this, we'll see that I get a tuple containing 1, 2, and 3. However, if I tried to create a tuple with just a single element with some parentheses around it, and run this, we'll see that I get an output of 1 without the parentheses on it. That is because this is an integer. And if I wrap the type function around numbers in the print function here and run this, we'll see that we get the output class integer because it is an integer. So to actually create a single element tuple, I have to put a comma after the 1. And now when I run this, we'll see that I get the output class tuple. And the reason being is because the parentheses are actually not what creates the tuple, it is the comma that creates the tuple. So if I do just the element 1 with the comma and run this again, you'll see that I still get the output of class tuple. So the reason to use the parentheses is to make it obvious that it's a tuple and to prevent any syntactic ambiguities. So I'm going to use the length function as an example here, and I'm going to try to pass it 1, 2, and 3. But I'm trying to pass it a tuple 1, 2, and 3. But if I remove the type constructor here and I run this, I'm actually going to get an error because length takes exactly 1 argument. So that's why I would pass this tuple in here with parentheses so that there's no syntactic ambiguity with what's the tuple and what are our positional arguments for the length function. So now when I run this, I get the output of 3 because my tuple is 3 elements. Another way to create a tuple is by using the tuple function, which is just the word tuple and then a set of parentheses. And if I were to run this, we'll get the output of an empty set of parentheses indicating it's an empty tuple. And if I mouse over the tuple function, it'll tell us that it takes an iterable. If no argument is given, the constructor returns an empty tuple. And if the argument is a tuple, the return value is the same object. So what that means is that whatever value I pass into these parentheses must be an iterable object. So strings, lists, other tuples, anything that's iterable. If I were to pass in the string hello here, it's going to return a tuple containing the individual characters hello. And if I run that, we'll see that down here. If I wanted to pass in a list, I would have to put it in square brackets and then do my elements inside the list separated by commas. And now I will get the tuple back 1, 2, 3. And that is it for creating tuples. So let's look at how to use the built-in count and index methods and how to use sequence operations on tuples. As you can see here, I have a variable my_tuple containing a tuple with the values 1, 3.4, and high, showing that they are heterogeneous, meaning that they can contain multiple data types in a single tuple. And the first thing that I'll show you is how to access an element using indexing. If you remember from list, indexing is using a set of square brackets and then putting the index of the element that you want. In this case, I want the element high here, which if we count from 0, we have 0, 1, 2. So it is the second index. So if I put 2 in here and I run this, it is going to output high to the console. Now, if I tried to change this, so instead of equaling high, it now equals hello, we'll see that even before I run it, Visual Studio Code is telling me that something's wrong. But if I try to run this, I get a syntax error. Expression cannot contain assignment. This is because tuples are immutable. Once they have been created, you cannot change them. You cannot modify any of the elements in them. You can also slice to get a subset of elements from a tuple. So if I wanted, say, just 1 and 3.14, I would put in a 0, colon, and then 2. This indicates that I want to start at the beginning of the tuple and go up to, but not include the second index. So that's going to get this index 0 and this index 1 and return a tuple containing those elements. And if I run that, we'll see that I have my tuple 1 and 3.14 down here. And if I wanted to add the optional step in, I could do another colon and tell it that I want every other element. And I'll put a 0 in on the left side of the first colon to start at the beginning of the tuple, and a 3 to make sure that I can iterate over all the elements in this tuple, and my 2 to say that I want every other element, so I only get 1 and high back. And if I run that, we'll see that I get the tuple containing 1 and high. The next thing I want to show you is packing, which is basically just creating a tuple. So if I create a variable called my other tuple, and I set it to be the values 1, 2, and 3, I am packing these values into this variable, creating a tuple. And if I output my other tuple here, we'll see that we have the tuple 1, 2, and 3. Now you can also unpack a tuple. So if I wanted to, I could say A, comma B, comma C equals my other tuple. And what this is going to do is it is going to take the 3 elements that are in my other tuple, 1, 2, and 3, and put them into my 3 variables that I've created here, A, B, and C. So 1's going to go to A, 2's going to go to B, and 3's going to go to C. And down here in the print function, if I output A, B, and C, we will see that. I get 1, 2, and 3, and you'll notice that there are no parentheses around here because these are individual integers now. Now, if I tried to add a 4th variable in here, even though my tuple only contains 3 elements, it will give me a value error because there's not enough values to unpack. And if I only tried to use 2 elements with my tuple that has 3 elements, it will give me a value error telling me that there are too many values to unpack. So make sure if you are unpacking that you use the correct number of variables for your tuple. We can also join 2 tuples together using the addition operator. So if I were to put in my tuple plus my other tuple and pass that into a variable that I will call con_tuple, short for concatenated tuple. And then down here in the print function, output the elements of con_tuple. When I run this, we will get 1, 3.4 high, and 1, 2, 3, since both of these tuples are now joined together. I'm going to go ahead and move these up into my tuple just to make the next part a little easier, make more sense. I'm going to remove that. And I will show you how to use the count and index methods. So the count method is used by typing in your tuple variable dot count. And if I hover over this, we'll see that it returns a number of occurrences of value and it takes one argument for value. In count here, I am going to pass it 2. So I want to count how many times this value is in this tuple. If I run this, I'll get the output 1 because there's only 1, 2 here. And if I were to pass in the value 1 and run this, we'll see that I get 2 for this one here and this one here. You can also use the index method. So if I get rid of count and put in index, I'll mouse over this and it'll tell us that it returns the first index of value and it raises a value error if the value is not present. It takes a value and an optional start and stop. So if I wanted to only search through this portion here, I would put in 1 for the start and 5 for the stop. So if I search for, let's say the value 3, and I put in my start of 1 and my stop of 5, I get an error because it's saying that it's not in the tuple because this stop here is non-inclusive. So 3 here is at index 5, but because this is non-inclusive, it is stopping here at 2. So if I were to change this to a 6 and then look for the index of 3, it's going to output 5 because that is the index here. And if I wanted to search the entire tuple, I would only pass one value in. So if I wanted to see where high was, where the first occurrence of it was, I would put in just high and I get the output of 2, which if we count, we have 0, 1, 2. We can also repeat the sequence that's in a tuple using the multiplication operator. So if I change my tuple to just be 1, 2, and 3, and I tell this to multiply that by 3, this is going to repeat this sequence 3 times. And when I run this, I'm going to get a tuple containing 1, 2, 3, 3 times. And down here, we'll see that I have this tuple 1, 2, 3, 1, 2, 3, 1, 2, 3. Now let's take a look at the set data type. Some key features of sets are that they can only contain unique elements, meaning that they can only contain one of each element. They are unordered. The order of elements is not fixed or predictable. And if you do something like print a set out to the console, the order in which the elements are shown is not always the same. They are unindexed, meaning you cannot access the elements by using indexing. They are mutable, so elements can be added or removed from the set, but those elements are unchangeable. You cannot modify them once the set is created. Some common set methods are the add method, which adds elements to the set, the clear method, which removes all elements from the set, the pop method, which removes and returns a random element from the set, the remove method, which removes an element or raises an error if that element does not exist, the discard method, which will remove an element or nothing will happen if the element does not exist, the difference method, which returns a new set of elements only in the current set, the intersection method, which returns a new set of elements common to the current and specified sets, the union method, which returns a new set with all unique elements from the current and specified sets, and the update method adds elements from the specified sets to the current set. And if I jump into my development environment here, you'll see that I have a variable my_set ready to create some sets and the print function to output them to the console so that we can see them. There are a couple different ways to create sets. The first way I will show you is simply by using a pair of curly braces. And if I put some elements in here separated by a comma and output this, we will see that we get the output of 1, 2, 3 in the curly braces, indicating that it is a set. Now, if I try to add 2 and 3 again to this and print it out again, we still only get 1, 2, 3, and that is because sets must contain unique elements. It cannot have duplicates in it, so it simply ignores this 2 and 3 here and does not add it to the set. And if I were to remove all elements from within the curly braces and run this, we get an output of an empty pair of curly braces, but unlike list, where an empty pair of square brackets is an empty list, this is not an empty set. This is actually an empty dictionary. And if I wrap the type function around the mySet variable and run it, we will get the output showing that it is class dict, which is short for dictionary. I am going to remove this type function real quick. To create an empty set, we actually have to type the set function name with an empty set of parentheses. And if I run this, we get the output of set with an empty set of parentheses, which is how Python displays an empty set. To create a set using the set function, we have to pass in an iterable object. So I'm going to pass it a list containing 1, 2, and 3. Now when I run this program, we'll see that I get the output of 1, 2, and 3 in curly braces, indicating that it is a set. Sets also support set comprehension, which is pretty much the same thing as list comprehension, where inside a pair of curly braces, you could put a variable name, which will act as the variable for each item in the iterable, and then the for the variable name again, in, then the iterable that we're going to pass in. In this case, I'm going to do A, B, C, D, E twice or 3 times, and then a condition. So I'm going to put if L, which is going to be whatever item we are iterating on in this sequence here, is in the string ABC. So how this is going to work is L is my variable that each one of these characters is going to be passed into, and then it's going to check if that character is in this string ABC, and if it is, it will add it to the set. Now, because sets can only contain unique characters, even though it's going to see ABC 3 times, it's only going to put it into the set 1 time for each character. And when I run that, we'll see down here, we get the output CBA, and we'll notice that this order is CBA, even though it would have seen A, B, C, and that's the order that it would have been put in the set. But because sets are unordered, we cannot know how they are going to be output to the terminal if we pass them into the print function. So now let's take a look at how we can work with sets using their built-in methods and the different operators that work on sets. And as you can see here, I have a variable called my_set, and its value is a set containing the elements 1, 2, and 3. Now, if I wanted to add an element to this set, I would use the add method. So under here, I'm going to type my_set.add. And if I mouse over this method, it tells us that it takes an element and it adds an element to a set. This has no effect if the element is already present. So if I tried to add a 3, which is already in this set, and run this, we'll see that we just get the set of 1, 2, and 3 back. It did not add a second 3 there. But if I try to add a 4, it will add the 4 to the set, and now my set has 1, 2, 3, and 4. Now what if I tried to add something like a list? So I'm going to pass in a set of square brackets here, and I'll give it the element 4. When I run this, it's going to give me a type error and tell me that it's an unhashable type list. What this means is sets cannot contain unhashable types. Any type that we pass into a set must be hashable. So numbers, integers, strings, tuples, frozen sets, as long as it's hashable, it can be put in a set, but if it's not, it cannot go into the set. Now, if I wanted to remove an element from the set, I would use the remove method. And if I mouse over this, we'll see that it takes an element and it removes an element from a set, and it must be a member. If the element is not a member, it raises a key error. What this means is that if I tried to remove a 4, which is not a member of this set, when I run this, I get this key error, and it's letting me know that 4 is not a key that's in this set. But if I try to remove the 3, which is in the set, it will remove it, and my set will no longer contain that 3. Now, there may be a time where I don't know what values are in my set. So how can I remove or attempt to remove a value that won't crash the program if I forget to handle this error? Well, you could use the discard method. So the discard method works exactly like the remove method, except for it will not cause an error if you try to remove a member that's not in the set. So if I run this with this 4 here, I just get my set back as 1, 2, 3 with no errors or issues. And if I try to remove a 3, which is a member of the set, it removes it, and I get my set back with only the elements 1 and 2. Now, if I wanted to clear every element from my set, I would use the clear method, which removes all elements and leaves me with an empty set. And when I run that, we get the set constructor down here indicating that this is an empty set now. And if I wanted to just get rid of the set entirely, wipe it out of memory, get it out of my program, I don't want any trace of it at all, I could use the del keyword to delete my set. And now when I run this, I'm going to get an error when I try to print my set out, because after this del keyword here, my set no longer exists. It's gone. It's no longer in memory. So this has no idea what the name my_set is referring to. Sets also have a pop method that returns an arbitrary element from the set and removes it from the set. Now, if I were to switch my numbers around here, so it's 3, 2, 1 instead of 1, 2, 3, and output this set again, we'll see that it comes out as 1, 2, 3. And this seems to be the case with integers. It always puts them in order from lowest to highest. So just to show that the pop method always returns an arbitrary value, I'm going to make this set be a string of characters. I'm going to do that by calling the set function and passing it the value world. And down here in the print function, I will call the .pop method on this my set here, since it's going to return one of these characters here, and then I'll do a comma and also print my set. So when I run this now, we'll see that the pop method removed R from the set, and that's what it returned, and then my set contains W, L, O, and D. Now if I run this again, we got the R again, but this time the set is in order O, D, W, L, and if I run it one more time, now the pop has returned the D, and these are in a different order again. And this is because sets are unordered. The last thing that I want to show you is the update method. So the update takes a set and adds a variable number of iterables to that set to create a union. I'm going to set my set back to being the numbers 1, 2, and 3. And I'm going to create a new set called my other set. And I'll give those the number 3, 4, and 5. And then under this, I am going to type my set.update. And if I mouse over this, it tells us it updates a set with the union of itself and others. So when I pass in my other set, it is going to create a union between my set and my other set, which is all the unique values between the two sets. So it's going to be 1, 2, 3, 4, and 5. And down here in the print function, I'm only going to print my set. And when I run that, we get the output down here, 1, 2, 3, 4, and 5. Now we're going to look at some methods that actually return new sets instead of operating on the sets in place. So as you can see here, I have a few sets, and I am going to place the value that is returned by our set methods into the result variable, and then print the result to the terminal using the print function. So right here, I will put in my set1, and the first method I'm going to show you is the difference method. And if I hover over this, it says that it returns the difference of 2 or more sets as a new set, i.e. all elements that are in this set but not in the others. So if I were to pass in my set 2 here, and we look at the elements that are in these two sets, it says that it's going to return a set that's in the calling set, so my set 1, that are not in the sets that we pass in. So in this case, there's a 3 and a 4 in my set 1 and a 3 and a 4 in my set 2. So it's going to remove this from my set 1 and then just return a set containing the values 1 and 2. And if I run that, we'll see that we get the output here of a set containing the elements 1 and 2. Now we can also do this difference by using the subtraction operator. So if I did a minus my set 2 and ran that, I would get the same output of a set containing the elements 1 and 2. The next method is the intersection method. So if I type that in, mouse over it, it says that it returns the intersection of two sets as a new set, i.e. all elements that are in both sets. So this is going to return a set that contains any elements that are in both of these sets, which in this case would be 3 and 4. If I run this, we'll see down here, I get the output of a set containing the elements 3 and 4. And the operator to do this same thing without calling the method is the ampersand. So if I did my set 1 and using the ampersand my set 2 and run this, I get the same result of 3 and 4. The next method that I want to show you is the union method. And the union method returns the union of sets as a new set, i.e. all elements that are in either set. So if I were to pass in my set 2 here, it's going to return a set containing all the unique elements between these two sets. So it's going to have 1, 2, 3, and 4, and then 5 and 6. And if I run that, we'll see that I get the set with the elements 1 through 6. For the union operator, it is the pipe character. So if I did my set 1, pipe my set 2, and run that, I get the same output of a set containing the elements 1 through 6. The next method I want to show you is the symmetrical difference. The symmetrical difference method works like the difference method, but it returns the symmetric difference of two sets as a new set, i.e. all elements that are in exactly one of these sets. So basically, it's going to return elements that are in either one of these sets, but not both. So in this case, with my set 1, and if I pass in my set 2, 1 and 2 are the unique elements in 1, and then 5 and 6 are the unique elements in 2. So this is going to return a set containing 1, 2, 5, and 6. And if I run that, we'll see down here that we get the set containing elements 1, 2, 5, and 6. The operator to perform symmetric difference is the caret symbol. So if I did my set 1 caret my set 2, I'll get the same output, a set containing the elements 1, 2, 5, and 6. There are also methods to perform these same 4 operations that I just showed you that operate on the set in place, meaning that it changes the set itself and does not return a new set. So I'm going to go ahead and get rid of my result variable here, as I won't need it. And I'm going to do my set 1, and I will use the difference update method as an example. And if I hover over this, it says it removes all elements of another set from this set. So now when I call the difference update using my set 1 and I pass in my set 2, instead of returning a entirely new set, it's going to remove any elements that are in my set 2 from my set 1. So it will remove the 3 and 4 from my set 1, leaving my set 1 just containing elements 1 and 2. And if I output my set 1 here, we will see that that's what I get is a set containing elements 1 and 2. And if I wanted to use an operator to do this, I would do my set 1 minus equals, and then my set 2. And then you see I get the same output of a set containing the elements 1 and 2 here. And this works the same way with the intersection, union, and symmetric difference, that if I wanted to do the operation in place, I would use the ampersand equal for intersection, the pipe equal for union, and the caret equals for symmetric difference. And for the intersection and symmetric difference, they both have an update version of the method that operates on the set directly. The union, however, you would just simply use the update method. Now I want to show you some methods that return Boolean values. So I'm going to put my result variable back in here. And I'm also going to put my result variable back in the print statement. And the first one that I'll show you is the isDisjoint. So I'm going to put my set1.isDisjoint. And if I mouse over this, it says it returns true if two sets have a null intersection. So this is saying that it returns true if the two sets have no elements in common. So if I were to run isDisjoint with sets my set 1 and my set 2, it's going to come back false, because the 3 and the 4 are common between the two sets. And when I run that, we'll see that we get the output false. However, if I were to pass in my set 4, which has no elements in common with my set 1, I'll get the output true. The next method is the isSuperset method. And if I hover over this, it tells us that it reports whether this set contains another set. So when I call the isSuperset method using my set 1, if the set that I pass in as an argument contains all the same elements as my set 1, this will return true, but if it doesn't, it will return false. So my set 1 is the superset of my set 3 because all the elements in my set 3 are in my set 1. So if I were to pass in my set 3 here and run this, we'll see that I get the value true back. Now, if I were to say my set 3 is a superset of my set 1, it's going to come back false because this 4 here is not in my set 3. And the last method I want to show you is the isSubset method. If I type in isSubset here and mouse over it, it tells us that it reports whether another set contains this set. So my set 3 contains the elements 1, 2, and 3. So if I were to pass in my set 1, it's going to check to see if my set 1 has all the same elements that my set 3 has. So in this case, it's going to be true because my set 1 does in fact have 1, 2, and 3 in it. Now, if I were to pass in my set 2, which does not have 1 or 2 in it, and run that, I get false. Now let's take a look at how to work with dictionaries in Python. A dictionary is a mutable and ordered collection of key value pairs. It is a versatile data structure that allows you to store and retrieve data based on unique keys. Key features of dictionaries are that they have a key value relationship. Each key is associated with a value and must be unique. They are mutable, meaning that their elements can be modified after creation, and new elements can be added and elements can be removed. They are ordered. As a Python version 3.7, dictionary order is guaranteed to be the same as insertion order. They are dynamic, meaning that they can grow and shrink as needed. They are flexible. Keys can be various data types as long as they are immutable, and values can be any data type. They provide efficient data retrieval. Because the key is hashable, it uses this to retrieve the value, making it much faster than list. Some common dictionary methods are the get method, which retrieves a value or default value based on a key. The set default method, which retrieves a value with a key or creates a key value pair if the key is not present. The update method, which adds a new key value pair or pairs or modifies existing ones. The pop item method, which removes and returns the last entry. This works on a last in, first out basis. The pop method, which removes and returns a value or default value based on a key. The clear method, which removes all elements from the dictionary. The keys method, which retrieves all the keys in a dictionary. The values method, which retrieves all the values in a dictionary. And then the items method, which retrieves all the key value pairs in a dictionary. And if I jump into my development environment here, we'll see that I have a variable called myDict equals none, and I'm going to output this variable to the terminal. So the first way to create a dictionary is simply by using a pair of curly braces. And if I were to run this right now, we'll see that I get this output of empty curly braces, which is an empty dictionary. And to add elements to this, we would use a key value pair separated by a colon. So if I put a colon in here, on the left side of this colon would be the key, which could be any immutable value, and I'll just make it a 1. And then on the right side, it could be any value. So for key 1, I'm simply going to create the string 1, and I'll create another key 2 with the value 2. And now when I run this, we get the output of a dictionary containing the key value pairs of 1 with the string 1 and 2 with the string 2. Another way to create a dictionary is by using the dict function. And if I mouse over this function here, we'll get some information. If you call dict with an empty set of parentheses, you get a new empty dictionary. If you pass it some sort of mapping value, so something that has key value pairs already, it will use those to create a dictionary and return that to you. You can also use kwargs, so you can pass it any number of key value arguments. And the only catch to that is if you use kwargs, the keys must be a valid Python identifier. So it has to be a valid variable name. It cannot start with a number. It cannot contain special characters, stuff like that. And then you can also pass it an iterable. But if you pass it an iterable, it must be an iterable containing collections that have a length of 2. So it must be an iterable that contains lists, tuples, even sets, as long as they have only 2 elements in them. Now the problem with sets are unordered, and if you do pass in a set, you have no idea which one is going to be set to the value and which one is going to be set to the key. So I'll start by using key value pairs, and I will use the Python identifier 1 equals, and I will give it the string 1. And for the next one, I will do 2 equals, and I will give it the integer value 2. And if I run this now, we'll see that I get a dictionary with a key of the string 1 that contains the value of a string 1, and the key of string 2 with the value of the integer 2. And you'll notice that whatever you pass in for the key value arguments, the key being a valid Python identifier gets turned into a string. And now I'll create a dictionary passing it in an iterable. So let's create a list. And in this list, I will do 1, comma, and then a string value of 1. And if I run this, you're going to see that I actually get a type error, cannot convert dictionary update sequence element 0 to a sequence. And what this is because I'm passing an iterable in it, it's trying to create a key value pair from this 1, and then it would try to create a key value pair from this 1 if it got that far. So when you pass an iterable, it has to be a collection that's within another collection. So if I were to put another set of square brackets here, so that this here is a single element inside this list here, and run that, we'll see that I get a dictionary containing one key value pair with the key 1 and the value of a string 1. And I could also make this a tuple if I wanted to. And if I run that, we'll see that I still get my dictionary with the key 1 and the value string 1. But I could pass in another collection here. So if I wanted to, I could pass in a list, a tuple, it doesn't really matter. So I'll do a list this time with 2, with the integer 2 for the key and the string 2 for the value. When I run that, we'll see that I get that dictionary back just fine. It does not care that one of these is a tuple and the other is a list. And now I'll even pass in a set. So if I pass in the set of 3 and the string version of 3, and remember when you create a set using the constructor, you have to pass an iterable. So I put this in a list. And now when I run this, we'll see that I get the output there. And if I run this again, there we go. I was trying to get it to switch the 3s here since sets are unordered and we do not know how it's going to put them in order. We now have the string value 3 as the key and the integer 3 here as the value, whereas the time before that it put the integer 3 as the key and the string 3 as the value. Now that you know how to create dictionaries, let's actually look at some methods and ways to modify and use the data that's in them. As you can see here, I have a person dictionary with the keys first name, last name, and age associated with the values John, Smith, and 30. And down here, I am printing my person dictionary. If I run this, we'll see that I get the output, first name John, last name Smith, age 30 in my dictionary. Now, if I wanted to access just a single value in here, the way that I would do that is by using square bracket notation. So down here in my print function, after the dictionary variable name, I'm going to put a set of square brackets, and then I'm going to pass it in the key for the value that I want. Right now, I want the value for first name, so I'm going to pass it first name. And when I run this, we'll see that I get the output John because John is the value associated with the key first name. Now, if I tried to use this square bracket notation with a key that does not exist, it will give me a key error. So when I run this, we'll see that it raises as key error and it's telling me that job is not a key that's in this dictionary. Now, if I go up here and I want to say change the value of one of the keys, I would type the dictionary name, square brackets, the key that I want to change, and then the equal sign and the new value. And if I run this, we'll see that I get my dictionary and the value age has been changed to 36 here. But if I were to do this with a key that does not exist, such as job, and add the value of programmer and run this, we'll see that job and programmer were added to my dictionary. So it's a little bit of a caveat with dictionaries that if you try to access a key that doesn't exist, you get a key error. But if you're trying to set the value of a key that doesn't exist, it will simply create the new key for you. I'm just going to comment this line of code out for a second because I'm going to need it again. Now, another way to access a value is to use the get method. So I'm going to create a new variable called result equals, and I'm going to type in my dictionary's variable name, .get. And it says here it returns the value for key if key is in the dictionary, else default. Now, default is none. So if I were to look for the job key and try to get that value, since I have this commented out, this will not create the job programmer key value pair. So job is not in this dictionary. And then in the print function, I tell it to print result. It's going to print none because it did not find this key anywhere. So there's no value associated with it. Now, if I wanted, I could add the optional default value and maybe give it a message to return, such as no job found. And if I run this, we get the output no job found. And if I were to print out my person dictionary again, we'll see that it does not in fact do anything with the key job. It does not create it. It doesn't give me an error. It just gives me this output of no job found. But if I uncomment this line of code out, so job will be in my dictionary, and run this, we'll see that job does get added to the dictionary. And if I set this to print that result out, that it does in fact print out programmer. Another method you could use to get values is the set default method. I'm going to go ahead and comment this out again. And this time I'm going to say result equals person dot set default. And the way the set default method works is that it will look for the key that I pass in. So in this case, I'm going to pass in job. And then it is going to either set the value to none if I did not pass in a second argument, or I can have it set the value to whatever I want. So in this case, I'll set it to programmer. So now since I have this person job equals programmer commented out here, job is not a key that's in this dictionary. But if I run this, we'll get the output programmer. And if I print out my person dictionary so that we can see that, we'll see that it does in fact add the job programmer key value pair here. Now, if I were to uncomment this out and change this to, let's say, coder, then my dictionary will contain the key value pair job with coder. So when I run this, result is going to come back as coder, not programmer. And when I run that, we'll see that we get that right here. And finally, we can update the information in our dictionary by using the update method. So I'm going to go ahead and remove some of this code here. And I'm going to put in person.update. The update method works similarly to the dict function, as in it takes similar arguments. But instead of creating and returning an entirely new dictionary, it simply adds the information that we pass it to the end of the dictionary that we call it with. So if I wanted to, say, create some values using key value pairs, I could do state equals and then give it a state, such as Florida, and go ahead and give it job equals programmer. And now when I run this, it's going to add these two key value pairs to this dictionary and then output the dictionary here, which we'll see down here. We have the state Florida and job programmer added to our dictionary. Another way to use the update method is to pass it an iterable containing collections that have two elements in it. So if I wanted to, I could pass it a list with a list inside of it. And in here, I will put state and Florida, and then a comma and another list. And in the other list, I will put job and programmer. And now I am passing it a list containing two list collections, and there are two elements in each of those two lists. And when I run this, we'll see that we get state Florida and job programmer in our dictionary down here. The last way that I'm going to show how to update information in the dictionary is by creating another dictionary and then passing that dictionary into the update method. So I'm going to create a dictionary that I'll call new info. And in this dictionary, I will give it the state of Florida and the job of programmer. And then down here in the update, I will simply pass in my new dictionary that I've just created. And when I run this, we'll see that we get the state Florida and job programmer into our original dictionary again. Now let's look at ways to remove elements from a dictionary. As you can see here, I have a dictionary person with the first name, last name, age, state, and job keys corresponding with the values John, Smith, 30, Florida, and programmer. I have a result variable, and then I'm going to print the result variable and print the person dictionary. The first two methods I'm going to show you are how to remove and return values. The first one is the pop method. So I'm going to type in my dictionary variable name .pop. And if I hover over this method, it tells us that it removes a specified key and returns the corresponding value. So if I pass in the job key, it is going to remove this key value pair from the dictionary, and it's going to return the value programmer to result. When I run that, we get the output programmer for result, and we get our dictionary with the job programmer key value pair removed. Now, if I were to actually remove job from my dictionary and run this, it's going to raise a key error because the key job does not exist. So I could pass in a default value to return if it doesn't find the key so that I don't get an error. And I could just simply say no job found. And if I run that, we'll get the output no job found, and my dictionary does not contain the key job anywhere in it. The next method is the pop item method. So I'm going to type pop item in here. And this method returns a tuple containing the key and value of the last
item in the dictionary. So in this case, state Florida is the last item in this dictionary. So it is going to return that tuple into result. And if I run this, we'll see that we get this output of the tuple containing state, which is the key, and Florida, which is the value. And then my dictionary no longer contains the key value state in Florida. We can also just use the del keyword to simply delete an element that we no longer want in our dictionary. So I'm going to type del, and then I will type the name of the dictionary and then square brackets, and then the key that I want to remove. And unlike pop and pop item, this isn't going to return anything. It's simply going to remove age from this dictionary. And when I run that, we'll see that age and 30 is no longer in our dictionary here. And if you wanted to simply wipe everything out, you could use the clear method. So if I typed in here person.clear and run this, we'll get the output of 2 empty curly braces, which indicates it is now an empty dictionary.
The next method I'm going to show you is the keys method. So I'm going to type in .keys in a pair of parentheses. And when I hover over the keys method, we'll see that it says it returns a set-like object providing a view on D's keys, where D is the dictionary that we are calling this method from. And if I run this, we'll see that I get this output down here that says dict keys, and then in parentheses it has this list containing our keys. There's also a method to retrieve just the values, and it is values. So I'm going to type .values in here. And if I mouse over, it says it returns an object providing a view on D's values. Again, where D is the dictionary we are calling this method with. And if I run this, I get this output that says dict values, and then in parentheses it has a list containing the values up here. And then we also have a method that returns both the keys and the values, and that is .items. And if I mouse over this, it says it returns a set-like object providing a view on D's items. So when I run that, I get this dict items, and then in the parentheses, I get a list of tuples that contain 2 elements, the key and the value associated with that key in each of those tuples. There are different ways to make use of this information. One way is by using a for loop to iterate through this information. So I could do for key in person.keys. And then in this for loop, I will simply print the value of key. And key is just a variable, so I could have named this anything I wanted. And if I run this, we'll see that I get these outputs of first name, last name, age, and state. And if I wanted to, I could use this to access these keys and do anything that I might need to do with them. The same works for values. So if I wanted, I could say for value in person.values and print the value out. And if I run this, we'll get the outputs of John, Smith, 30, and Florida. Now, if I were to do this with the items method, because it returns a list of tuples, I would need 2 variables over here. And since the first one is key, I'll put in key, and then the second one is value, so I'll keep that as value. And I will change this to items. And then in my print function, I will change this to say key, comma, value. And if I run that, we'll get the output first name John, last name Smith, age 30, and state Florida. And just to be clear, these are just variable names, so I could have made these anything I want, such as K and V. And if I did KV down here, it would work just the same way. But since I am using the names key and value, and that's how we refer to dictionaries, I just want that to be clear that these are just variable names. It can be anything you want them to be as long as they're a valid Python identifier. So now I want to show you the dictionary class method from keys. So I'm going to go ahead and get rid of all this information here, and I'm going to go ahead and create a list containing the values 1, 2, 3, 4, and 5. Now, to use the class method, I am going to first create a variable that I'm going to call my _ dict equals, and then I'm going to type the name of the class, which is dict, dot, and then call the class method, which in this case is the from keys method. And it tells us that it creates a new dictionary with keys from iterable and values set to value. Now the iterable is going to be the list that I just created, so I'm going to pass that in as my first argument. And if I don't put anything in for a value, it's just going to default to none. So if I were to print my dict here, down here we're going to see I get a dictionary containing the keys 1 through 5, which is what my list is,
but each of the default values were set to none. Now I could put a comma here and make this any value that I wanted. So if I wanted to set them all to be hello world, I could. And if I run that, we'll see now my dictionary contains the keys 1 through 5, but now all the values are set to hello world. Now let's say I wanted my dictionary values to be an empty list. So in here, I will pass it an empty pair of square brackets. And if I run this, we'll see that I get a dictionary with the keys 1 through 5, and each value is set to an empty list. Now, if I were to say my dict and pass in my key 1 and append a value of high to that list and run this again, we'll see that it's actually going to put high in every single list. That is because when you use the from keys method, the value that it's initializing for each of the dictionary keys is all referencing the same object. So if it's an immutable object such as a number or a string or a tuple, it's not a big deal. But if it's a mutable object like a list, you'll get this result here. So to fix this, we can use dictionary comprehension instead. And the way dictionary comprehension works is I would use a pair of curly braces, and then I would pass in a variable that is going to end up being the key, and then I would do an expression. And in this case, I am going to say empty list for the variable that's going to be my key in, and then I could put any sequence in here, but I am going to put in my list. I'm going to go ahead and comment this out so that that piece of code right there doesn't run. I just want to see my list. So when I run this, we'll see that I do in fact get a dictionary containing the keys 1 through 5 with empty lists in each one of them. And if I uncomment this out now, when I run this, it is going to append this first list here to have the value high in it. And when I run that, we'll see that I do in fact get this list that has high in it for key 1, and key 2, 3, 4, and 5 were not affected. And I could also do something else for this list. So if I wanted to, I could initialize different values. I could say x to the power of 2 for each x in my list, where x is the elements of this iterable. Let me remove this because that will cause a problem. And if I run this now, we'll see that I get a dictionary containing the keys 1 through 5, and the values are the square of those keys. And just as a quick reiteration, if you wanted to create a dictionary with a set amount of keys initialized to a specific value, you would use the class method from keys. And if you want to create a number of dictionaries with distinct values, you would use dictionary comprehension. Now let's learn about Boolean values so that we can start performing conditional logic. Some key features of Booleans are that they only support 2 values, true or false, and in the Python language they are case sensitive, so if you use them you must use a capital T and capital F. Booleans are often obtained by comparing values using the comparison operators, and they would be the equals operator, which is 2 equals sign, the not equals operator, which is an exclamation point and equal sign, the greater than operator, the less than operator, the greater than or equal to operator, and the less than or equal to operator. Booleans are often used in conjunction with logical operators to evaluate conditions, which will be not, and or. And like mathematics, these have precedence. So when you use them, the not will be evaluated first, then the and will be evaluated, and finally or will be evaluated. The Python language also supports the concept of some values being inherently truthy or falsy. So some examples of truthy values would be numeric values that contain values other than 0, strings that contain any values at all, and non-empty collections such as this list. Some examples of falsy values would be numeric values with the value of 0, empty strings, and the none type. There are also the is and is not operators, which perform identity comparisons to check if 2 objects are the same object in memory. This is not to check if they contain the same values, but to check that they are actually the same object. So if you wanted to know if 2 objects were the same, you would use the is operator. And if you wanted to know if 2 objects were not the same, you would use the is not operator. There is also the in and not in operators, which check if a value is present in a sequence or collection. So if you wanted to know if a specific character or word was in a string, or if an element was inside a list, you would use the in operator. And if you wanted to check if that value was not present in the string or list or other collection type, you would use the not in operator.
Let's look at some examples of comparison so that we can see how Booleans actually work. As you can see, I have some variables with some initialized values here, and I have a variable result, which I've initialized to none, and this is where we're going to do our comparison operations and then print out the result down here. So the first thing that we're going to try is the equals operator, and we will check to see if A is equal to B by typing A, then two equal signs, and then B, which will evaluate if 5 is equal to 10. And if I run this, we're going to get the output false because 5 is not equal to 10. Now, if I check to see if C was equal to B, which is going to check if 10 is equal to 10, and run that, we will get the output true because 10 is equal to 10. The next comparison operator we'll look at is the not equals. So now I'm going to check to see if 10 is not equal to 10, and it's going to return false because 10 is equal to 10. And if I were to check to see if A was not equal to B, so is 5 not equal to 10, and run this, it's going to tell me true because 5 is not equal to 10. And if I wanted to check to see if 5 was greater than 10, I could use the greater than comparison operator. And when I run that, it's going to tell me false. And if I swap these, so B is on the left and A is on the right, to check if 10 is greater than 5, when I run this, we'll get the output down here of true. And if I switch this greater than to a less than, so we're going to check if 10 is less than 5, it's going to tell me false. And if I swap this A and B to check if 5 is less than 10, we will get the output true. And if I wanted to check to see if 5 was less than or equal to 10, when I run that, we will also get the output true. Or if I wanted to check to see if 5 was greater than or equal to 10 and run that, we get false. But if I were to check to see if C, which is 10, is greater than or equal to 10, we get the output true. These comparison operators also work on strings, but maybe not in the way that you would expect them to. So I'm going to go ahead and remove these variables here and work on strings directly. And the first thing I'm going to tell it to do is check to see if a capital A is greater than a lowercase a. And if I run this, we're going to get the output false. This indicates that a lowercase a is actually greater than an uppercase a. And you might be wondering why. Well, when Python compares strings, it's comparing their lexicographical or dictionary order based on their Unicode code points. So the lowercase a actually comes in at a higher Unicode number than the capital A. So if I were to switch this, we would see that the capital A is in fact less than the lowercase a. So you have to be careful if you're using the greater than or less than signs with characters. So if I were to say have an AAZ here, and then over here I have an AZ, and I'm checking to see if this is greater than this right here, it's going to give me false. Because in lexicographical or dictionary order, lowercase a, Z would come first before lowercase a and Z. And if I were to throw another A here and see if it's greater than, it's going to still tell me false because now they're equal. So if I put in an equal sign operator and run this, it'll tell me that they are the same string. Now, if I wanted to add one more A here and run this, now we get true because in a dictionary, AAZ would come after AAAZ. So just be careful if you're using the greater than or less than or greater than or equal to or less than or equal to comparison operators with strings. If you are using equals or not equals with them, it just simply checks to see if the strings are the same sequence of characters. Now let's take a look at the logical operators not, and or. And we will start with the not operator since it has the highest precedence. And the not operator simply negates whatever the Boolean value to its right is. So here we have A equals B, which is 5 equals 10, which is false, but this not operator is going to negate that false value and make it true. So when I run it, we get the output true. And it works the same for true values. If I have this here, which is 5 is not equal to 10, then that is a true value, but the not is going to negate that and make it false. And when I run that, we'll see that it outputs false. The next operator we'll look at is the AND operator. And the AND operator requires that the Booleans on either side of it to be true for the entire thing to evaluate to true. If either the left or right side of the AND operator is false, the entire evaluation will be false. So if I have A is less than B and C
is less than D. When I run this, we're going to get the evaluation of true because 5 is less than 10 and 10 is less than 15. Now, if I were to switch this symbol here to say A is less than B and C is greater than D, which 10 is not greater than 15, we have a true on the left side and a false on the right side. So when I run this, I'm going to get false. So again, with the and, both Booleans on either side of it have to be true for the entire thing to evaluate to true. And the last logical operator is the OR operator, which requires that either the left or the right side be true for the entire evaluation to be true. So if I have B is equal to C, or C is equal to D, B is equal to C is 10 is equal to 10, which is true, or C is equal to D, which is 10 is equal to 15, which is false, but because the value on the left side is true, the entire thing is going to evaluate to true, which we see here in our output. Now, if I were to say B is not equal to C or C is equal to D, so we have a false on the left side and a false on the right side. When I run that, we get the output false. However, if I were to change this so that the evaluation on the right side is true, such as C is less than D, when I run that, we get true again. So now let's look at combining these logical operators together. And I'm going to put these evaluations into parentheses just to make them a little easier to read. So we'll check A is less than B and C is greater than A, or A is equal to 5. So when we look at this, the first thing that's going to happen is the AND is going to evaluate A is less than B and C is greater than A, which both evaluate to true. So that evaluation is going to come out to true. And then it's going to check OR A is equal to 5, which is also true. So since both the left and the right side of this OR are going to evaluate to true, the entire thing is going to be true. And let's look at another example. So we'll do not, and then in parentheses, we will do A is less than B, or D is less than A. And then outside the parentheses, we will do or B is greater than D. Now, when this evaluates, it's going to check the parentheses first. So it's going to be A is less than B, which is true, or D is less than A, which is false. So this whole thing is going to evaluate to true. And then this not here is going to negate that true value, make it false. So then it's going to be false or B is greater than D, which is also false. And the entire thing is going to come back as false. So that's what we get right here. Now let's look at one more that uses all three, but I'm going to remove all these variables and just use the true and false values just to make it a little easier to see. So I'm going to do result equals, and we're going to do true or false and not true. And since there was no parentheses used here, the way that this is going to go is it's first going to evaluate this not true here, which is going to come out to be false. And then it's going to evaluate the and, so it's going to be false and false, which is going to evaluate to false. And then last, it's going to check the or, so it's going to be true or false, which is going to come out to true. And when I run that, we'll see that we get the output true down here. Logical operators can be a little bit confusing when you first start using them, especially when you're using the not operator. Anytime you're thinking about stuff in a negative way, it usually doesn't quite sit right, and it takes a little while to practice and understand it. But after some trial and error, I'm sure you will understand it just fine. Now let's look at some examples of the is and the in operators. Now the is operator is used to check if two objects are the same object. Not that they are of equal value, but that they are the actual same object in memory. And right here, you'll see that I have str_1 equals hello and str_2 equals hello. Now these are two separately created and initialized variables. However, because strings are immutable types, these are, in fact, the same object. String 1 and string 2 are the same object. So if I were to put in here str1 is str_2 and run this, the result is going to be true, and it's going to output true. Well, how can we actually see that this is the case? Well, Python has a built-in function, id. And if I just put ID with some parentheses and hover over it, it tells us that it returns the identity of an object and is guaranteed to be unique among simultaneously existing objects. And right here, we'll see that it returns an integer value. So if I were to say result equals ID of string 1, and run this, we'll see that we get this number here, and this is the ID of the string1 object. Now, if I run it again, we'll see that we get a different number. It is the same object, but each time we run this, it's getting stored in a different place in memory, so it gets a new unique identifier. So if I were down here in the print to change this to print both the result, which is going to contain ID of string1, and then I did a comma and also passed in the ID of string2, we're going to see that these, in fact, are the same numbers. So right here, we have this long number here that ends in 5520, and then we have this long number here that ends in 5520. Now, if I were to change string2 to equal goodbye instead of hello, and run this again, we'll see that we now have different numbers. This one ends in 7152, and this one ends in 8336. And if I were to remove that and have this now check is str1 is str2, when I run this, it's going to say false because they are not the same object. Now, this does not happen with mutable objects. So an example of a mutable object is a list. So I'm going to create two new variables called list1, and we will simply give it 1, 2, 3, and then we'll create list2 and give it the value of 1, 2, 3 as well. If I can hit 3 instead of 4. And down here for result, we will do list1 is list2. And when we run this, we're going to get false. That even though these are the same values, unlike strings, which are immutable objects, lists are mutable. So it works a little bit differently when you are checking to see if they are in fact the same object. These two lists are stored as completely separate objects in memory. And we could also use the is not keywords, which is just going to negate this value. So since this would have came out as false if it was list1 is list2, when I throw in the not in there, it's going to give us true because list1 is not list2. However, if I were to create a third variable called list3 and I set it to be equal to list1, now if I were to say list1 is equal or is list3, I'm going to remove the not, we're going to get true because it is pointing to the same list. And if I were to change or modify list 3 in any way, because list 3 and list 1 are the same object in memory, any changes to list 3 would also happen to list 1. So just remember, for immutable values such as strings, numerical values, tuples, if they are exactly the same value, they will also be the same object in memory, whereas immutable types such as lists, sets, and dictionaries will be different objects even though they may have the same values. Now let's look at the in operator. So I'm going to go ahead and create another string. I will put hello world, how are you in it. And we are going to use the result to check to see if the string how in string 1. So we are looking to see if the sequence of characters HOW is anywhere in this string here. And if I run it, it's going to tell us true because we have how right here. And if I were to just simply put H in it, it's going to also say true because there's a H right here. Now, if I were to look for something like Z, which is not in it, we get the value false. And the same thing works for list or any other collection. So we know that the value 1 is in our list 1 up here. So if I were to check is 1 in list 1, we would get true. And I could throw in the not keyword on the left side of in here. So it says 1 not in list 1, which is false, and we'll get false. And that is pretty much it for the is not, in, and not in keywords. The portion about mutable and immutable objects is important to remember because that's going to come up again when we get to functions, because there are issues that can arise when using default values with mutable objects such as list. Now let's explore the concept of some values being inherently true and some values being inherently false. To do this, we are going to use the bool function. If I hover over the bool function here, it tells us that it returns true when the argument x is true, false otherwise. And it is talking about this value x right here, which is any value we pass into the function. Truthy values are any object that inherently has value. So for numeric types, any non-zero number, strings that are not empty, lists or tuples, sets, dictionaries that have at least one element in them, stuff like that is true. And then empty strings, the none type, numeric types that contain 0, or collections that do not have any elements in them would be false. So if I were to put a 1 in here and run this, 1 is inherently truthy, so we get the value true. However, if I put in a 0 and run this, we get the output false. It works the same for floats. So if I put 0.0, we also get the value false. I put in a string that has no characters in it at all, we get false. And if I put even just one character in it, we get true. And it also works with lists. So if I were to pass in my list 1 here that contains the value 0, 1, 2, 3 and run this, we get true back because there is value here. But if I were to pass in an empty list, which is just a pair of square brackets with nothing in it, we get back false. The Python language also provides built-in functions for any and all, which will check through a collection to see if any value is truthy or if all values are truthy. So I'm going to replace this with the any function. And if I hover over it, it tells us that it returns true if bool x is true for any x in the iterable. So if we pass in any kind of iterable, a list, a tuple, a string, anything that is an iterable, it will return true if any value is truthy. So I'm going to pass it list 1 here, which has the truthy values of 1, 2, and 3. So this is going to return true. And when I run that, we get the true. Now, if I change this any function to the all function and mouse over it, it tells us that it returns true if bool x is true for all values in x in the iterable. Well, this has a 0 right here, which is inherently false. So when I pass the list 1 into it for the all function, this is going to return false because not every single value in here is truthy. So we get this false right here. And now that we've been able to see the bool constructor, the any function, and the all function, I want to show you some empty objects and some non-empty objects. So I'm going to scroll down a little bit. I'm going to make my terminal smaller so that we can see everything. I'm going to go ahead and uncomment this. And in case you're wondering, the hotkey to comment out multiple lines is holding down Control and then hitting K, then C. And to uncomment them, you hold Control, hit K, and U. So now we have our empty objects, which is just a list of all the different objects that would be considered empty or falsy. So we have a list, an integer, a float, an empty single quote string, an empty double quote string, an empty dictionary, an empty tuple, an empty set, an empty frozen set, the none type, and false. So if I print any for empty objects, it's going to check to see if any of these objects at all are truthy in nature, which is going to come back as false. And I'm going to give myself just a little more room here. And when I run this, we'll see that we get the output false because none of these empty objects here are truthy in any way. So I'm going to go ahead and comment this out by holding Control and hitting KC. And I'm going to scroll down and show you non-empty objects. Here you'll see we have a list that's non-empty. It has one element in it. We have an integer that is non-zero. We have a float that is non-zero. We have a single quote string with a single character in it. We have a double quote string with at least one character in it. We have a dictionary with one key value in it. And we have a tuple with a few elements in it. We have a set with a few elements in it. We have a frozen set with a few elements in it. And we have the true Boolean type. So down here, I have print all for non-empty objects. So this is going to tell us if every object in here is in fact truthy in nature. So when I run this, it's going to tell us true because all of these objects are truthy in nature. Now let's take a look at conditional statements so that we can use this Boolean logic to actually make decisions. Conditional statements are the if statement, the elif statement, and the else statement. The way these work is the if statement is the only one that's required. And if the condition that the if statement is checking evaluates to true, then the code that is indented under that statement will execute. If you want to have additional options, if the if statement evaluates to false, you can use the elif statement. And if the elif statement evaluates to true, then the code that is indented under it will execute. And you can have any number of elif statements. And then finally, if your if and any elif statements all evaluate to false, you can use the else statement to have kind of a catch-all that will execute if that ends up being the case. Then there's a thing called a ternary operator, which is a concise way to assign a value based on an if-else statement and a single line of code. So if you have a variable that you want to assign a value, one of two values to based on whether or not a condition is true, one for if the condition is true, one for if the condition is false, a ternary operator is a very concise way to go about doing that. And over here on the right, we have some syntax for it. You'll see it says if condition, and the condition is a Boolean operation or a function, anything that returns a Boolean that could evaluate to true or false. And if this evaluates to true, then the code under it executes. Then the elif condition, which you can have any number of elif conditions. If the if condition is false, then the elif condition will be evaluated. And if the condition is true, the code under it will execute. And then finally, if the if and elif conditions are all false, the else statement will run. Then for the ternary operator, the syntax is value if true, if condition, else value if false. And when I jump into my development environment, you'll see that I got a couple of variables here ready to go to perform some conditional statements on. And I am going to output results into the variable result and print that out to the terminal. So the first thing I'm going to do here is put in an if statement, and I'm going to have it check to see if x is less than 3. And then I'm going to end this line with a colon. And when I hit enter, you'll notice that Visual Studio Code has automatically indented this and given me 4 blank spaces here. And the code underneath that is not indented has this little red squiggly line. And if I mouse over it, it says expected indented block. This is because whenever you use a colon, it expects the next line of code to be indented. What I'm going to do if x is less than 3 is set the value of result to equal x is less than 3. And when I run this, we'll get the output no true statements, which is what result is initialized to, because this evaluates to false since x is 5. So I could be like, okay, well, let me double check to see if maybe x is equal to 4. And then under here, I can put result is equal to x is 4. And if I run this, again, we'll get no true statements because neither this evaluation or this evaluation has returned true. So then I could drop in an else statement with just a colon after it. It doesn't need a condition. It doesn't take a condition. It's just the catch-all if all the conditions above it evaluate to false. And I could say result equals x is not less than 3 or equal to 4. And if I run this, we get the output here. X is not less than 3 or equal to 4 because since these evaluated to false, this code right here executed. And you can do as many elif statements as you want. So I could add another here and say elif x is equal to 5. Then under that, put result equals x is 5. And when I run this now, we'll get the output x is 5 because after this returns false, and then this returns false. This condition right here evaluates to true, so that is what gets executed. And then since one of these executed, the else statement does not execute. And the condition that's being checked can be anything as long as it returns or evaluates to a Boolean value of true or false. So if I wanted to have something like x is less than 10 or x is greater than 3 and y is equal to 10, result equals, that's correct because I'm not going to type all that out. When I run this, we'll get the output that's correct because this here evaluates to true. The x is greater than 3 and y is equal to 10 gets evaluated first because and comes before or in the precedence, which evaluates to true because x is greater than 3 and y is equal to 10. And then it checks x is less than 10 or this value that gets evaluated over here, which becomes true or true, and the whole thing evaluates to true. So this code right here gets executed. Now let's look at some nested if statements. Over here, the first statement I'm going to write is if x is less than 100. And under this, I'm going to put another if statement in. I'm going to say if x modulus 2 is equal to 0, result equals x is even. And then underneath here, I'm going to throw in elif statement in and say elif x mod 2 is equal to 1. Result equals x is odd. And below that, all the way to the left side, I can throw in an else statement and put result equals x is greater than or equal to 100. And if I run this now, since x is less than 100, so this is going to be true, it's going to drop down to this block of code. And when it checks this one here, this is going to evaluate to false because 5 mod 2 is going to return 1. So this one here is going to evaluate to true, and result is going to be set to x is odd. And when I run this, we'll see that we get the output of x is odd. And if I were to change x to 6, run this again, we'll get the output that x is even. And if I were to change x to 100, none of this would evaluate to true, so our else statement will run. And we get x is greater than or equal to 100. And if I wanted to, I could go even deeper. I could throw in another if x is less than 10, result equals x is even and less than 10. And if I were to set x to 8 here and run this, we'll get the output x is even and less than 10. And we've now gone 3 if statements deep into our nesting. And whenever you are using if statements, be sure to keep track of your indentation, because if I were to put this else here and tab out this results, then this else is going to apply to this if statement here. So just keep track of that. As you can see, Visual Studio Code provides these handy little white lines to see where the indentation is. And another thing is, like you see right here, I can put as many tabs as I want. And if I were to make x equal 100 again, so that this else statement right here runs, if I run this, we'll see that x is greater than or equal to 100. It doesn't really care how much indentation there is. It could be all these spaces I have here. It could be one space. It's going to work just fine, but it has to have indentation after it. And the typical convention in Python is to have 4 spaces. So now let's look at the ternary operator. So I'm going to remove most of this here, and I am going to set result is equal to x if x is greater than y, else y. And what this is doing is it's basically checking to see which of these 2 variables here is higher. So if x is greater than y, then it's going to set the value of result to the value of x. And if not, so y would be greater than x, it would assign the value of y to result. But since x right now is 100 and y is 10, if I run this, we will get the output 100 because x is the greater number. And if I were to swap this around, so it's checking to see if x is less than y, which it's not, then it will assign the value of y to result. And when I run this, we'll see that we get the output of 10. Real quick, before we get into loops, I want to go over the range data type. Ranges represent an immutable sequence of characters. They are commonly used to generate numbers in a specific range and are often used in for loops to iterate over a sequence of numbers. One of the interesting things about ranges is that they generate numbers as they are needed rather than storing them in memory. So if you have a very large range, it doesn't eat up valuable memory. Because they are an iterable object, they do work with any function that takes an iterable object, such as the length function, to see how many numbers are going to be in the range. You can also use the in operator to determine if a specific value is in the range. And since they are numeric in nature, you can use them in something like the sum function, which takes an iterable that contains numeric values and adds them all together and returns the total. So with that, let's look at some examples. I have my range variable over here, and I'm calling my range function. And if I hover over my range function, it's going to tell us right here that it requires the stop number, but it also takes a start and step if I want to use the optional start and step. Now the stop number is non-inclusive, so I'm going to put a 4 in here. And when this generates the numbers, it's only going to generate 0, 1, 2, and 3, since the stop number is non-inclusive. And if I don't include a start or a step, they default to starting at 0, and the step or increment value is set to 1. However, Because this does not generate the numbers until they're actually being used, if I try to print this right here, it's not going to print the numbers 0, 1, 2, and 3. It's simply going to print this right here, but it's also going to add in the start number. So when I run this, we'll see that it just outputs range from 0 to 4. So if I actually wanted to be able to see the numbers that this is going to generate, I need to either use a for loop to iterate through them and print each individual number, or I could simply pass this range into a list, which will generate all the numbers then. So I'm going to call the list function and pass it the myRange variable. And when I print this now, it's going to print this list to the terminal. So down here, we have the output in a list of 0, 1, 2, and 3. And if I wanted to, I could make this go from 4 to 10 by adding a comma and making the 4 now be the start and adding the 10 to be the end. And this time when I run it, it's going to give me the numbers 4 through 9 in my list, which we have right here. And if I wanted to add a step to say I only want every other number, I could pass in a 2, and now it will simply print out 4, 6, and 8. So we have 4, 6, and 8 in our list here. If I wanted to see how many numbers were going to be generated by my range, I could put my range inside the length function. And when I run that, it's going to output 3, which is what we just got here. And then if I wanted to, I could also use the sum function. And if I run this, we'll get 18. And if we scroll up here, we'll see that 4 plus 6 plus 8 does indeed equal 18. As I mentioned earlier, ranges are often used in conjunction with for loops to iterate over a sequence of numbers. So I just wanted you to have a good idea of how to use ranges, because going forward, when we get to the for loop section, we're going to see a lot of things like for I in range, and we might pass in the length of a list or any other number in here. Like let's say I want to perform something 10 times, I would pass in the range 10. And then if I printed I and ran this, it's going to print out all the numbers from 0 to 9. So that's why I wanted you to have a good idea of how ranges work so that when we get to the for loop section, it's not confusing to you. Python supports 2 different types of loops, the while loop and the for loop. And we'll take a look at the while loop first. The while loop is a control flow statement that allows a program to repeatedly execute a block of code as long as a condition remains true. And some key features of while loops are that they evaluate a condition before each iteration. This means if that condition is false, the while loop will not execute. You can use the break keyword to terminate the loop prematurely. You can use the continue keyword to skip the current iteration and go to the next iteration. And you can use an optional else clause, which is code that will execute once the condition of the while loop is false. Over here on the right, we'll see some syntax examples. And we have while condition and then a colon, and then underneath it is indented code, and that code is to execute if the condition is true. Then we have another example that shows while condition with the colon, and then indented under that is the code to execute if condition is true, and an optional break statement to break out of the while loop. Under that, we have while condition with the colon, and then indented under that is code to execute if condition is true, and the optional continue keyword if we want to skip the current iteration and move on to the next one. Then we have a while condition with a colon with an optional else clause. So under the while condition, we have indented code that executes if the condition is true, and then we have the else clause, which is code that will execute once this condition becomes false. Now let's take a look at for loops. For loops are similar to while loops, but they are control flow statements that iterate over a sequence or iterable object and execute a block of code for each item in that sequence or iterable object. Key features of for loops are that they also support the break keyword to terminate the loop prematurely, and they support the continue keyword to skip the rest of the current iteration and move on to the next. They also use an else clause that is code to execute after the for loop finishes, but like the while loop, it does not execute if the break keyword is used. Over here on the right, we have some syntax examples. You'll see that it is for item in sequence, and the sequence could be an iterable object as well. And then indented underneath that, we have code to execute for each iteration. Then we have for item in sequence with the code to execute for each iteration and a break keyword if we want it to break out early. Then we have for item in sequence with the code to execute for each iteration and the continue keyword if we want to skip the current iteration. Then we have for item in sequence with the code to execute for each iteration indented underneath it, and then an optional else clause where it is code to be executed after the loop finishes. Now let's look at some examples of the while loop. As you can see here in my development environment, I have a while loop set up and ready to go.
I have created a variable named counter and initialized it to 0. And then for my while loop, I have while counter is less than or equal to 5. So this is my condition. And as long as this condition evaluates to true, the code that is indented underneath of it will execute. And I have print counter, and then I'm incrementing counter by 1. And if I run this, we'll see that I get the output 0, 1, 2, 3, 4, 5. If I instead wanted to do something like only print counter when counter was even, I could do this by introducing an if conditional and using the continue keyword. So down below my loop, I will put if counter mod 2 is equal to 0, which is the case when counter is an even number. Then print counter and continue. And I will remove this print counter line here. And now when I run this, I'm actually going to have a problem. It is going to just continuously print out tons and tons of zeros and never stop. So I'm going to hit Control C to stop this in Visual Studio Code. And the reason being is that this continue keyword right here immediately ends the current iteration and forces it to the next iteration, which means this line of code right here to increment my counter never executes, so my counter never gets above 0. So if you use the continue keyword, make sure that you do something to change your conditional before the continue keyword, or you could end up in an infinite loop. So I'm going to put counter plus equals 1 here. And when I run this again, we get the output 0, 2, 4 like I expected. And if I wanted to execute some code after this while loop finished, below the while loop, I would put in the else statement, and then indented underneath that, I would put whatever code it is that I wanted to run. In this case, I'm just going to tell it to print the word done. So when I run this now, I get 0, 2, 4 and done. Now let's say that there's a condition where I didn't really expect it to happen, but it's happened, and because it's happened, I want to immediately get out of this while loop. So if I were to change this to say if counter is equal to 3, for whatever reason I didn't expect counter to become 3, and I immediately want to break out if it does happen, below that I would simply type in the break keyword, and I'm going to put my print counter down here so that it actually prints it out. And now when I run this, we'll see that I get 0, 1, 2, 3 doesn't execute because it breaks out of the while loop before the code down here runs. But you'll notice that it also doesn't run this code here that says print done. And this is because when you use the break keyword, any else clauses will not execute. Another way you could use a while loop is simply by typing while true. And then if I were to do something like print high down here and run this, it's just going to print high forever because there is no way for true to ever become false, and there's nothing in the while loop to actually break it out. So if I hit Control C to end that, I can put something up here that will provide a condition to break out of this while loop. So I could put something up here like if input, and then prompt the user to enter Q to exit, and then have it actually check to see if the value that was entered is in fact Q, and then I could break. Now when I run this, it's just going to continuously prompt the user to enter Q to exit, and while they don't enter Q, so if I enter W, it's going to keep running. If I enter E, it's going to keep running. If I enter R, it's going to keep running. But as soon as I enter Q, it exits the program. However, using a while loop like this is a little risky because you introduce the possibility of ending up in an infinite loop that never breaks out. So make sure that if you do use a while loop like this, that you have a very clear way to break out of that loop. And the last thing that we will look at for while loops is using nesting. You can actually put a while loop inside of another while loop. So I'm going to change this variable to be num1 and initialize it to 1. And then I will put while num1 is less than 4. And then underneath that, I'm going to initialize a second variable called num2 and initialize it to 1. And then under that, I'm going to create a second while loop and say while num2 is less than 4. And then for this while loop, I am going to tell it to print num1 times num2. And then I want to make sure that I increment my value so that this condition can be evaluated properly. So I'm going to increment num2 by 1. And then outside of this while loop, so I have to make sure I have my indentation correct, I am going to increment num1.
And now when I run this, this while loop is going to execute first with num1 equaling 1. And then it's going to initialize num2 to equal 1. And then it's going to say while num2 is less than 4, print num1 times num2. So this is going to be 1 times 1, 1 times 2, 1 times 3. And then when this while loop increments to its next iteration, num1 will now be 2. So when this one runs, it's going to be 2 times 1, 2 times 2, 2 times 3, etc. until it gets through all of them. And if I run this, we'll see that I get the output 1, 2, 3, 2, 4, 6, 3, 6, 9. Now let's look at some examples of for loops. I have created a list of animals containing cat, dog, and bat. And then for my for loop, I say for animal in animals. And this is just the variable name that is going to represent each value in my iterable object. And then under the for loop, indented, I am printing this animal. So if I run this, you'll see that I get the output cat, dog, and bat. If I wanted to exit this loop, if I ran into the value dog, I could put in an if conditional and say if animal equals dog, then break. And if I run this now, you'll see that I get the output cat, and that is it, because once it runs into the value dog, it is breaking out of this loop before this code here executes, and then the loop itself no longer executes. However, if I just wanted to skip dog and continue on through the list like normal, instead of break, I could use continue, which will force it to end its current iteration and start the next one. And if I run this, we'll see that I get cat and bat. And if I wanted to execute some code or just output that the loop is finished, I could put in an else clause and then tell it to do something such as print done. And when I run this, we'll see that I get cat, bat, and done down here. However, if I were to do this with the break keyword and run this, we'll see that I only get cat, and this code right here does not execute because, like with the while loop, if you use the break keyword, the else clause will not execute. Now let's say that I actually wanted to do some work on the elements in this list. I'm going to go ahead and remove some of this code here. And if I were to type in something like animal, which is the variable that the for loop is working on, equals goat, and run this, you'll see that it outputs goat 3 times here. But if I go down below my for loop and actually print out my animals list and run this again, you'll see that it's outputting goat here, but my list still contains the values cat, dog, and bat. Now the reason is because when you use a variable like this, it's not accessing the elements in the iterable object the same way it would if you were using indexing. So if I actually wanted to work on these elements, I could do something like for I in range, and then in the range, I'm going to pass it the length of my iterable object. So I'm going to call the length function and pass that in animals. And this looks a little convoluted, so I'll explain it. The I here is going to represent the variable that the for loop is iterating through, and range is going to generate numbers from 0 up to the length of the animals list, which is in this case going to be 3. And since range uses a non-inclusive n number, this is going to run for the values 0, 1, and 2. So if I look at my list, I have index 0 at cat, index 1 at dog, and index 2 at bat. So this works out perfectly to actually be able to work on my list. So now for my animals, I would do animals because I'm actually referring to my list. And then in a set of square brackets, I would put I and then change it to goat. And then down here in the print statement, I will also do animals with these square brackets and the variable I in there. So the first time this runs, this I is going to be 0 and it's going to access this element. The second time it's going to be a 1 and access this element, and then 2 and access bat. So now when I run this, we'll see that it prints out goat 3 times here, and it's actually changed my list to contain the value goat, goat, goat. It's important to understand that for loops do operate on any iterable object. So if I were to put in for char in and then pass in a string such as hello world, and then down here, print char, and I'll get rid of this, and Got this little squiggly here because I forgot my colon. And if I run this, it's going to output each individual character from the string hello world on a different line. Now the last thing I'm going to show you for for loops is how to nest them. So I'm going to go ahead and remove all this, and I'm going to make very simple for loops here. I'm going to say for x in range, and I will have it start at 1 and go up to but not include 5. So this will be the values 1, 2, 3, and 4. And then directly below that, I will put in another for loop, and I'll say for y in range 1 up to but not including 5. And then below that, I will tell it to print x times y. And now when I run this, the first for loop is going to start at 1. And then the second for loop is also going to start at 1. But all the elements in the second for loop are going to be iterated over. And then it's going to go to the next one in the first for loop. So this is going to be 1 times 1, 1 times 2, 1 times 3, 1 times 4, and then 2 times 1, 2 times 2, etc. until it's iterated through all of these. So when I run that, we get the output of 1, 2, 3, 4, 2, 4, 6, 8, 3, 6, 9, 12, and 4, 8, 12, 16. So as you've seen here, for loops make it very easy to repeat a block of code to either perform something a set number of times or to operate on some sort of iterable object such as a list or a string. Up to now, we have used many functions. We have used the print function to output text to the console. We have used the length function to get the length of iterable objects, and we have used many methods on many different data types. Starting in this video, I will show you how to create your own functions. A function is a named block of reusable code that performs a specific task. If the function is inside a class, it is called a method and it belongs to that class. Functions allow you to organize your code into logical units, making it easy to read, understand, and maintain. Some key features of functions are their signature, which is the definition of a function, including its name, optional parameters, and optional return type. Parameters are variables that are declared in the function signature that act as placeholders for arguments. Arguments are the values that are passed into a function when it is invoked. The body of the function is the code that is executed when the function is invoked. And the return value returns the result or output produced by the function's operations, and if no explicit value is returned, then the none type value is returned. The basic syntax of a function is the def keyword, def, then a function name and a pair of parentheses and a colon. Inside the parentheses, you can put optional parameters. Then below the function definition, you would put your code to execute and any optional return values. We have some examples of function syntax here where we have the def keyword followed by a function name and an empty set of parentheses. And then indented below it would be the code to execute upon invoking the function. Then we have an example of a function that takes two parameters, a and b. When you call this function, you would have to pass two values into it. And when it was invoked, the code indented below it would execute. And then we have a function that takes two parameters and returns the sum of those two parameters. So you would pass two numbers into it and it would return the sum of those two numbers. Or since Python is a dynamically typed language, I could pass two strings in here and it would return the concatenation of those two strings. And if I jump into my development environment, you'll see that I have a blank slate and we are going to create our first function. So I'm going to type the def keyword and I am going to call this function print_greeting. And we are not going to put any parameters in this first function. So after the parentheses, I'm going to put a colon and hit enter. And you'll see that Visual Studio Code has indented this because anything after a colon needs to be indented. And all we are going to do is have this print a message that says, hello, welcome to functions. And then somewhere below this, I would call this function by simply typing the function name and a pair of parentheses. And now when I run this, we will get the output down here, hello, welcome to functions. To break this down, this will be our function signature. In this case, we only have a name. We do not have any parameters, and this function is not returning anything. And this here would be the body of the function. And then this here is how you invoke a function by simply typing its name and then a pair of parentheses. And if there was any parameters, we would put those parameters inside the parentheses. So let's create a function that actually takes parameters and then does something with them. So we will create a add function and we'll give it two parameters, a and b. And then below it, we will tell it to print a plus b. And then down below this somewhere, we can call our add function. And if we pass the values 5 and 10 here, when I run this, this is going to call the add function and pass 5 and 10 in as the arguments. And then the function itself is going to print 5 plus 10 to the console. So down here, we get the output 15. And if we wanted, instead of having the function output this sum, we could have it instead return this sum. So I could have it return A plus B. And then down here, I could put this in a variable called result. So now when I do this, where I have a variable equals and then a function, the function is going to be invoked. And whatever the return from that function is what gets assigned to this variable. And then below that, I can call the print function and pass the result variable in as my argument. And when I run this, we still get the output 15, but this time the function is returning this value and putting it in this variable, and then we are printing out the variable.
Before continuing on with functions, I want to show you the pass keyword real quick. The pass keyword is a way to put an empty placeholder into an area of code where you otherwise would not be allowed to leave empty code without generating errors. So if I try to create a function here, and I put def add, and then below this, I try to do something else like print the value high, we'll see that I'm getting an error here. And if I hover over print, it tells me that it expected an indented block. So I'm not ready to put my code in here yet. So what I can do is put in the pass keyword. And now if I run this, we'll get the output high with no errors. And I can even call this function. And since functions return none if a explicit return value is not created, I will simply get the output none. This also works with the if conditional. So if I remove this and I put something like if 20 is greater than 10, and then below it, I will just put pass. And if I hit the play button here, it runs with no errors. It also works with for loops. So I could say for I in range 3, and then inside this for loop, put the pass. And when I run that, again, it runs with no issue. So I just wanted to show you how this keyword works. So if you ever run into a situation where you need to put an empty placeholder where you otherwise would not be able to leave empty code, this is what you can do. Let's create a function with optional parameters. Let's go ahead and define the function by typing the def keyword and giving it a name. We'll call it greet. And in parentheses, we will give it 2 parameters. One will be required, which is name. And the second one we will call greeting. And we will make this optional by, after typing the name of the parameter, putting the equal sign, and then we can give it a default value. We could leave it as an empty string, but I'm going to give it the default value of hello. I'm going to put my colon and hit enter. And for the function body, I'm going to create a variable called message. And I'm going to use an F string to create a greeting based on our parameters. So I'm going to do F, and then in quotes, I'm going to do curly braces, going to pass it the greeting variable, put a comma, and then in another set of curly braces, pass in the name. And then below that, I am going to call the print function and print out the variable message. So now if I drop down here and I call the greet function, and for the first time I call it, I'm only going to pass it the name Bob. Now when I run this, it's going to call the greet function. The argument that I pass, Bob, is going to go into the name variable. But since I didn't pass a second parameter in here, greeting is going to get the value hello. So when this runs, message is going to be hello, Bob. And if I run that, we'll see that we get the output hello, Bob. But let's say that we want to give a custom greeting. We could say Tina and then put a comma, and we could put how we want to greet Tina. So I could put something like howdy here. And now when I run this, we get howdy Tina. Let's create another function, and this time we will use keyword arguments. So it's kind of a long name, so I've already got it typed out here, and we're going to create a function that calculates the volume of a pyramid. It's going to take 3 parameters, a length, a width, and a height, and we will default the height to equal 1. So underneath here, I'm going to create a variable called volume, and I'm going to set it to be equal, and I'm going to use a set of parentheses here, and I want it to be length times width times height, and then this entire thing needs to be divided by 3. And then we can call the print function and pass it in the variable volume. Instead of simply just typing the name of the function
and passing the parameters in as they are, I'm instead going to use keyword arguments so that I don't have to necessarily put them in the same order. So to do this, you would type the name of the parameter, then the equal sign, and then what you want to set that parameter's argument to be. So I can pass in 4 for the width, then a comma, and then I'll type in length equals, and we'll give it 5, and then we can do height equals, and give it something like 10. And when I run this now, we will get the output 66.666667, and that is the volume of this pyramid. And you'll notice that these are not in the same order as the parameters up here, and this is because we used keyword arguments. When you use keyword arguments, you can pass them in any order that you want. However, any positional arguments that you use must come before any keyword arguments. So since I have width and length here swapped, but height is in the right position, I would think, okay, I can not have to put height in there because it's already in the right position. But as soon as I remove the keyword argument, I get a little red squiggly. And if I hover over this, I'll get this error that says positional argument cannot appear after keyword arguments. This means that all positional arguments, which are either variables or literal values, must come before any of these keyword arguments where you have the name of the variable equals and then the value that you want it to equal. We've already seen one function that had a return statement, but let's look at a function that has multiple return statements. So here I have defined a calculate letter grade, and it is going to take a single parameter, which is the grade. And then based on that grade, we are going to return a letter. We can do this by using an if conditional statement. So if grade is greater than or equal to 90, return the letter A. And then below that, we can say elif grade is greater than or equal to 80, return B. And then for the last one, we can say elif grade is greater than or equal to 70, return C. And if we wanted to, we could even throw in a catch-all and say else, return F. And down below this, we can call this function. And we will actually call this function inside of the print function's parameters. And the first value that I will pass it is 95. And if I run this, we'll see that I get the output A. And if I drop this down to 85, I get the output B. If I drop it down to 75, I get the output C. And if I drop it down to 65, I'll get the output F. And the reason that this works is once the function encounters a return statement, it breaks out of the function. None of the code past the return statement will execute. When the grade is 90 or above, it sees this return and that's it. Nothing else below this, no matter what it was, would execute. It would immediately return back to the caller, which in this case would be the parameter that we are passing into our print function. Let's look at how we can add some detail to a function signature to help any programmer that might be using that function understand what types of arguments to pass into it and what they can expect to get back from it. If you look here, I have defined a function, calculate pyramid volume, and I gave it 3 parameters, length, width, and height. And it simply takes those 3 parameters, gets the product of them, divides them by 3, and returns that to the caller. So down below the function here, I'm going to say result equals, and I'm going to call the function, and I'm going to pass it in a pyramid with length 5, width 5, and height 5. And then down below that, I will print out my result. Now, if I hover over this function name here, the pop-up tells us that it takes length of any, width of any, height of any, and the return type is any. And where that any is the data type that we would either pass in for the parameter or the return type, which is what's after the arrow. So we don't really know what types of arguments we're supposed to pass into this function. We don't know if it's in numeric values like integers or floats, or if it's string values or lists or what. So we are going to add some type hinting to help whoever might be using this function know what they're supposed to pass into it. And we do this by going into our parameters, and after the variable name, we put a colon, and then we can put the data type that is expected to be passed in for that argument. Now, if you wanted to do multiple data types, you could do a set of quotes, type in one data type, then do the pipe character, and then type in another data type. And just to make this a little bit easier to see, after width, I will go ahead and do one more. I think it'll fit. So I'll do my int, then pipe, and then float. And then after this comma, I'm going to hit enter, which will push this text down just so that it doesn't get off the side of my screen here. And then after height, I will do one more int and then pipe character and float. And then after the parenthesis, but before the colon, I am going to put in a function annotation arrow, which is made up of a dash and a right chevron. And then since this is returning a quotient will always be a float. I am going to set the return type to be a float. And now if I hover over this function name, we'll see that next to length, width, and height, we get int and float, indicating that we should pass in some sort of numeric value and that we should expect the return type to be a float. So if I run this, we'll get the output of 41 point, whole bunch of 6s and a 4, which is a float. And now if I were to call this, or any other programmer using my code were to call this, they would know exactly what types of arguments that they should pass into this function. Now, the thing is, Python does not enforce this. So if I were to do something like pass in a string here, I'm going to get a type error, but it's not from the function call itself. It's from trying to divide this string here by 3. And we'll see that right here, it says for division, string, and int. And if you'll recall, when you use the multiplication operator with a string and int, so when I pass the string 5 in as length, and then the multiplication operator tries to multiply that by 5, it is just going to repeat this string 5 times, and then it's going to try to repeat the 5 string 5s by 5 again, making this right here come out to 25 string 5s divided by 3. So that's why we're getting this unsupported operand type error. Now let's take a look at how we can take this one step further by adding additional information using docstrings. Docstrings can be used on packages, modules, classes, and functions, and they are a way to provide additional information. So let's look at the way that this works with a function. As you'll see here, I have my calculate pyramid volume function, and then below it I have this triple quoted string, and it is the first line after my function definition. I put this triple quoted string, and there are different ways to format these, but this style here is the Google style, which says that on the first line with the first opening triple quote, you should have a single sentence that explains that says what the function is or does, and then below that you would put any additional information, and then below that you would have your arguments, your return types, your errors that it might raise. So if we look at this, it says it calculates the volume of a pyramid. And then under args, I have my length, width, and height. And I give a little more information about it. So I have that length is the length of the pyramid's base, width is the width of the pyramid's base, and height is the pyramid's height. And then I have a returns, and I have a float containing the pyramid's volume, and that's where I end the string. If I hover over this function, I get all this extra information down here on the bottom, saying that it calculates the volume of a pyramid, it explains what the different parameters are for, and it tells me what it's going to be returning. So docstrings and type hinting are not necessary, but they help tremendously with organizing your code and understanding what that code is supposed to be doing. And they especially help when it's other programmers or it's code that you haven't seen in a while and you're coming back to it. It'll just really help you understand what it's doing and how to use it. Now let's look at how we can get multiple values back from a function by packing them, and how we can pass multiple values into a function by unpacking a collection. We'll start with the packed returns first, and we'll see that I have a function here called getCircleInfo that takes a single parameter for a radius, and it uses that to calculate the area and circumference. Now if I wanted to return multiple values here, such as area, circumference, and pi, I would simply type in my return statement, and then separate each of the values that I want to return by a comma. So here I've put in return area, circumference, and pi. And down below here, I am going to call the print function, and I am simply going to pass the getCircleInfo function in here with the radius of 5.0. And now when I run this, we'll see that I get a tuple back containing these 3 values. So the first element is the area, the second element is the circumference, and the third element is pi. Now, if I actually wanted to get these individual elements back, I have to unpack the tuple. So I'm going to go ahead and remove that there.
And to unpack the tuple, you simply provide enough variables for it to unpack into. So I'm going to create 3 variables, A, C, and P for area, circumference, and pi. And then I'll invoke my getCircleInfo function, and I'll pass it that value of 5.0 again. And then down here, I will print A, C, and P. And if I run this, we'll see that I get the output of the same values that I got from this tuple, but you'll see that they are no longer in the parentheses or separated by commas because they are now their own individual variables. Now, if you were to only use one variable here for your function call and then print just that variable out, it will actually put the entire tuple into that one variable. So when I do this, the entire tuple gets put into the variable A. And if I try to only put 2 in and run this, I get a value error because it's saying there's too many values to unpack. It only expected 2. This is because I only provided 2 variables for it, but it's returning 3. And if I try to put too many variables in here, I get a similar error, value error, not enough values to unpack, expected 4, but only got 3. And again, this is because I provided 4 variables, but it only returned 3. Now let's look at how we can pass multiple values into a function by using a single collection. Here you'll see I have a function called calculatePyramidVolume that takes 3 parameters, length, width, and height, and it multiplies length times width times height, divides it by 3, which returns the volume of a pyramid. Right here I have result equals calculatePyramidVolume with the values 5, 4, and 3 passed in as arguments. And when I run this, we'll see that I get the output 20. That's the volume of my pyramid. But let's say that I have collections that I want to be able to pass in here instead of the actual values. So I'm going to create some real quick. I'm going to create a list with those same values, 5, 4, and 3. I'm going to create a tuple with those values. And I'm going to create a dictionary. And we'll use the keys 1 for 5, 2 for 4, and 3 for 3. And that's kind of important to know what keys I use there because we're going to see that something a little different happens with dictionaries. So now let's just pass in my list. If I were to simply pass in my list here and run this, I'm going to get an error. It's a type error because it says it's missing 2 required positional arguments. What's happening is this list is only being passed into this variable right here, so it's missing values for width and height. So to unpack this list so that it passes in these 3 individual values, you simply put an asterisk before it. Now, when I pass this in, it's going to pass it in as if I would have put these 3 values in here instead of my list. And when I run that, we'll see that I get the output 20, just like it did when I passed in the 5, 4, and 3 directly. It's the same with tuples. So if I pass in my tuple, make sure I have my asterisk just to the left of it and run this, I'll get that same output of 20. However, if I pass in a dictionary, and I have the keys 1, 2, and 3 here, when I run this, I'm going to get the output 2. And this will be the volume of a pyramid that had a length of 1, a width of 2, and a height of 3. And this is because when it unpacks a dictionary, it's unpacking the keys of that dictionary. So if you wanted to actually use the values, you would simply put in the .values method. And now this is going to return that object that contains the values 5, 4, and 3, and then this asterisk will unpack that into their individual values of 5, 4, and 3. And when I run that, we'll see that I get the correct output of 20. And just as a quick recap on the packed returns, when you return multiple values from a function, you are returning a tuple, and you can operate on that tuple just like you would any other tuple. And when you are unpacking collections using this asterisk, you are separating the values that are inside the collection into their individual elements. Now let's take a look at the args syntax. The args syntax is used to pass a variable number of non-keyword arguments into a function, and the args parameter name can be any valid variable name, but by convention it is typically args, A-R-G-S, with a preceding asterisk. The preceding asterisk is necessary to indicate that it should collect any extra positional arguments passed into the function. So to use the arg syntax, you would type an asterisk and then your variable name, and I'm going to use the conventional name args, A-R-G-S, and then down in my function here, I'm going to simply have it return the args for now. So I'm going to tell it return args. And then down here, I have result equals calculate sum. And I'm just going to pass in a few positional arguments. And I'll say 1, 2, 3. And if I run this, we'll see that I get a tuple containing the values 1, 2, and 3. And that's what this does. This takes any extra positional arguments that we pass into the function and puts them into a tuple so that they can be used somewhere in the function. I'm going to actually do something with this. I'm going to create a variable called total equals 0, and then a for loop that says for num in args. So it iterates through each element in the args. And I'm going to tell it to add that num to total. And then finally, it is going to return the total variable. And when I run this, we will see that I get the output of 6 because it's added 1, 2, and 3 together and returns 6. And I could put any number of arguments in here. And if I run that, I will get the sum of all the numeric values that I passed in. Now, I could have used a better way of doing this because Python does have a built-in sum function. So I could have simply called the built-in function sum, passed it in the arguments, and return that. And when I run that, I still get the output 54. The arg syntax can also be used in conjunction with other positional arguments. So here I have a function called animal names. It takes the positional parameter for species, and then it takes a variable number of names for those species. And then it's going to create a string list of those names by using the string join method to separate the values in names by a comma. And then it's going to create a variable message which puts the species names and then the list of names in and returns that message. So here for my result variable, I will have it call animal names, and I will pass it in cat for a species. And for names, I will give it whiskers, mittens, and shadow. And now when I run this, I will get the output cat names, whiskers, mittens, and shadow. And if I wanted to, I could do dog and then do Max, Bella, Toby, and we'll add one more of Luna. And when I run this, we'll see I get dog names and then Max, Bella, Toby, and Luna. Now it's important to know what parameters your function takes. So if I hover over this, we'll see that it takes species and then it has the asterisk names indicating that it takes a variable number of names. But if I tried to do something like put dog here at the end and run this, then it's going to say max names, Bella, Toby, Luna, dog, because the way this is set up here in the function's parameters, species comes first as a positional argument. So since it's first, whatever value is passed in first is going to go into the variable species, and then all other values past it are going to go into the arg syntax names. And if I tried to move species to the other side of the asterisk names, and I run this, and you'll see that I have dog here, but instead I get an error. It says type error animal names missing one required keyword only argument. And it's a keyword only argument because of this. So in order to actually use this species here, I have to put the keyword species equals and then my dog. And now when I run it, I'll get the output correct. Dog names, Max, Bella, Toby, and Luna. But this is not very intuitive. It's not a good way to do this. So you're going to want to put all your positional arguments before your variable arguments. And if I tried to do something like put species dog here, you'll see that I get all these red squigglies because you cannot have a keyword argument before positional arguments. So now let's take a look at a function that uses a positional argument, an args syntax argument, and a keyword argument. So I have this function here, describe animal, and it's going to take an animal type and a list of names and an optional habitat. And it's going to join the names list together. And then it's going to create this description that says the animal type animals in the habitat are, and then the list of animals. And you'll notice this little backslash character here after my quote. This is because I pushed the last bit of this string down to the next line. And this is just a way to let the Visual Studio Code or the Python interpreter know that I want to continue this as all one string. And finally, it returns a description. And to use this function, I will create a result variable equals, and then I will call the function, and I'm going to pass it in the values lion for animal type. And then for names, I will give it Simba and Mufasa. And then for habitat, I will give it habitat equals Savannah. And now I will print the result out. And when I run this, down here, I'll get the output. The lion animals in the Savannah habitat are Simba, Mufasa. And if I want to change this up, I could do giraffe. And for the names, just to be a little clever, I am actually going to pass it a list of names, but I have to unpack that list using the asterisk. And I will do Spike and Melvin. And their habitat will be grassland. And if I run this, we get the output. The giraffe animals in the grassland habitat are Spike and Melvin. This is just taking this list and unpacking it so that it passes in the individual values of Spike and Melvin into our names args syntax. And then we could do monkey. And for monkey, we can have the names Coco and banana. But for the habitat, I am going to remove it and just let it use the default value of unknown. So when I run this, it says the monkey animals in the unknown habitat are Coco and banana. And just like in the previous example, the way that these are ordered up here in the function's parameters is important. You can't have the keyword argument before the args syntax. If you try to run this, the second argument that you pass in here, Coco, is going to go into the habitat parameter. And if we run this, we'll see that, and we get the monkey animals in the Coco habitat are banana. So it's putting Coco into the habitat variable. So try to keep them in the order of positional arguments, args syntax arguments, and then keyword arguments. Now let's look at how we can pass in a variable number of keyword arguments using the kwargs syntax. The kwargs syntax allows you to pass a variable number of keyword arguments into a function, and it collects these keyword arguments into a dictionary. The two asterisks before the parameter name indicate that it will accept multiple keyword arguments, and you can access the key value pairs in kwargs just like you would any other dictionary. And like with args, kwargs is just a conventional name, but it could be any valid variable. So let's take a look here. I have a function called print details, and it takes the kwargs syntax as a parameter. And in this function, it is going to first print the kwargs dictionary, just so that I can show you how it turns these key value pairs into a dictionary. And then I have a for loop that is going to iterate through the items in kwargs. This is the dictionary method items, and it's going to output the key and value separated by a colon. Now, if I were to run this right now with this empty call to print details, it's just going to give me an empty dictionary. And since there are no items being returned by the kwargs.items method here, this for loop will not run. So I'm going to pass some keyword arguments into our print details function here. I'll pass in name equals Jill, age equals 23, and city equals Raccoon City. And when I run this, I'll get my kwargs showing that it is a dictionary containing the keys name, age, and city, and the values Jill 23 and Raccoon City. And then for my for loop, it's outputting our key value pairs here. So I have name Jill, age 23, and city Raccoon City. Now let's look at some examples of using kwargs with some positional parameters. So I have a function here that's called describe fish, and it takes a fish name as the first parameter, and then the kwargs. And I am going to take advantage of kwargs being a dictionary. So instead of putting a bunch of keyword arguments with default values inside my parameters list, I am simply going to create variables in the function that uses the dictionaries.get method to check to see if there is a key color, and if there is, it will return that color, and if not, it will return unknown color. And I will do the same for habitat and for fins. And then it's going to generate a description based on these variables. And then finally, it is going to return the description to the caller, which in this case will be the result variable. So I have here a call to the describe fish, and I am going to pass in the values of goldfish for fish name. And then for my keyword arguments, I'm going to pass color equals orange, habitat equals aquarium, and fins equals 3. And when I run this, we'll see that we get a goldfish is an orange fish that inhabits an aquarium. It has 3 fins. And you'll see that I do not have a space after this period because I forgot to put a space after the period here before I split my string into two separate strings on two lines. Now, if I were to do something like remove the keyword argument color equals orange here and only pass in habitat equals aquarium and fins equals 3, I'll get the output. A goldfish is an unknown color fish that inhabits aquarium. It has 3 fins. And I could do the same with habitat. I could remove it, run that. It says a goldfish is an unknown color fish that inhabits unknown habitat. It has 3 fins. And I could remove fins altogether, not pass in any kwargs. And if I run that, we get a goldfish is an unknown color fish that inhabits unknown habitat. It has 0 fins. Now let's say that I did want to set some keyword arguments up here in the parameters. If I tried to put them after the kwargs, it's going to give me an error. You can see the little red squiggly line there. And if I hover over it, it says parameter cannot follow. And then it's got 2 asterisks and double quotes parameter. If you're using a keyword argument and the kwargs in the same function, the keyword arguments must come before kwargs in the parameters list. If I wanted to, I could remove fins, but now I would have to make sure that I put fins in the correct position down here. So I could put just 3, and then I could put in some color equals, and we'll make it a red goldfish this time, and habitat equals, he lives in the ocean now. And if I run this, we'll get the output. A goldfish is a red fish that inhabits ocean. It has 3 fins. And if I wanted to, since it is a keyword argument, the order of the keyword arguments doesn't necessarily have to match the order of the parameters up here. So I could put at the end here, fins equals 3, and run this, and it will work just fine. A goldfish is a red fish that inhabits ocean. It has 3 fins. And it is putting color equals red and habitat equals ocean into our kwargs, and fins equals 3 is correctly going into our fins parameter. So if you're creating a function that uses positional arguments, keyword arguments, and kwargs, this is the order that you would want them. You would want to have your positional arguments first, then your keyword arguments, and then your kwargs. So now let's look at some examples that use all 4 possible parameter types. So we have positional arguments, args syntax, and then keyword arguments, and then kwargs syntax here. And just to keep this simple, I'm simply going to have this function output the different parameters. So name will be output here next to processing data. Args will be output here next to args arguments. Age will be output next to age here, and kwargs will be output next to kwarg arguments. For the first example, I am simply going to call the function. So process data, and I'm not going to pass it anything. And I will get an error because it does have one required positional argument name. And that is the only required argument in this function. I'll pass it a name data1. And when I run this, we'll see that it's processing data, data1. And then for my args argument, it's simply an empty tuple, age defaulted to 0, and then kwargs is an empty dictionary. So then I could pass it in data2, and then for some variable positional arguments, I'll give it 1, 2, and 3, and I will set age to equal 30, and I'll give it another key value pair of city equals New York. Now when I run this, we get processing data, data2, and then the other positional arguments get put into the args tuple. And then age is set to 30 because I used the keyword argument to set it to 30. And then for kwargs, I have a dictionary containing the key city with the value New York. And finally, if I were to only pass in one positional argument for data 2, and then I could set age to 35, and then maybe city to New York, and I'll create another key value pair that I will call language equals English. And when I run this, we'll see that processing data comes out as data 2. My args is an empty tuple, so none of these values went into args. Age got set to 35. And then my kwargs got 2 items in its dictionary now, city, New York, and language English. If you were to use all 4 possible parameter types, so we have positional arguments, our variable number of positional arguments, the args syntax, our keyword arguments, or our variable number of keyword arguments, our kwarg syntax. This is the order that you would want to put them in. starting with positional, then variable positional, then keyword arguments, and variable keyword arguments. Now let's look at how we can create generator functions. When a function contains the yield keyword, it becomes a generator function. Instead of returning a single value with the return keyword, generator functions use yield to produce a sequence of values. When you call a generator function, it doesn't execute the entire function at once. Instead, it returns an iterator object that can be used to retrieve the values one by one. The yield keyword is used in the context of generators to create iterable objects that produce a sequence of values. Generators are useful for efficiently processing large amounts of data or for working with infinite sequences, where you may not know the exact number of elements in advance. They allow you to generate values on the fly, which reduces memory usage and improves performance. In my development environment, you'll see that I have a function defined, and this has the yield keyword in it, which means that it is a generator function. And you create a generator function just like any other function. You start with the def keyword, then you give it a name, and then inside parentheses, you give it any parameters that you may want it to have. And then underneath, I have num equals 0, so I'm initializing num to 0. And then I have a while loop that is going to check while num is less than or equal to limit, and it's going to execute this code here. So down below here, I'm going to create a variable called evens and assign it the value of generate even numbers, and I'll pass 4 in as a parameter. And real quick, I am going to just try to print evens, and you'll see that the values that are generated by this are not in this variable right here. When I run this, we'll see I get this output that says generator object, and then it has my function name, and then it has this at and all these characters and numbers here. This is a memory address where this function is currently residing in memory. So to actually print these values, I need to use a for loop. So I'll say for num in evens print num. And if I run this now, I get my outputs 0, 2, and 4. And the way that this is working, when we create our generator object, we have none initialized to 0, and it is going to check while num is less than or equal to limit, then yield num, so it's sending yield back to whatever we have that's going over our iterator object. So in this case, it's a for loop. And then it's going to print that value here. And then it's going to go back to the generator function and then continue from where the yield statement was. So it's going to go back to here and then drop down to the next line and increment num by 2. And then it's going to go back to the while loop. And now it's going to be 2 is less than or equal to limit. And then it's going to yield 2. So down here in my for loop, it's going to output 2 in our print function here. And then it's going to go back up into the generator function again and continue on from there down to this line, increment it to 4, go back to the loop, pass that 4 back down into our for loop here. And then when it goes back, it's going to increment num to 6. And then the loop conditional will no longer be true, so it stops generating numbers. Now let's look at a function that generates an infinite sequence of numbers. So I'm going to remove this and add in the generate primes function. There are two main variables, primes and num. The list primes will store the prime numbers found so far, and num is the number that is being checked for primality. A generator expression, this here, checks if num is not divisible by each number prime that's in the primes list. The all function then checks if all these conditions are true, and if they are all true, num is prime and it is yielded from the generator. So down here, I am going to create a variable called prime generator, and I will assign it the value of generate primes. So now I have my generator object, and then below this, I am going to use list comprehension to generate a list of primes. So I will say primes, which is going to be my list of prime numbers, and then in square brackets, for my expression, I am going to use the next function, and I'm going to pass it in my prime generator, and then I'm going to put for I in range, and then inside the range, I would put the number of primes that I want to generate. I'll start with 5, and then just below this, I will print my primes list out. And now when I run this, I get this output 2, 3, 5, 7, and 11, which are the first 5 prime numbers. And since my generate primes function generates an infinite sequence of prime numbers, I can put whatever value I want here. So if I wanted to generate 500, I could generate 500, and then I get the first 500 primes. Since this is all a little bit complicated. I'm going to try to explain it a little better. I'm going to change this to only output the first 4 primes. And I have a print function that I'm going to call, and you don't necessarily need to understand everything that's going on here, but basically what this print function is going to output is the num, which is the current number that I'm checking for primality, and then a list containing the Boolean values of whether or not this num is evenly divisible by each number that's in the primes list. And then it is going to output whether or not the all function is returning a true or false value. And if the all function does return a true value, that number is prime. So now when I run this, we'll get this output down here. We have our first 4 prime numbers, 2, 3, 5, and 7. And we'll see next to 2, the all function is outputting true. Next to 5 and 3, it is outputting true. And next to 7, it is outputting true. And all of our Boolean values in here where this is true are true. So 3 has a single true Boolean, 5 has 2 true Booleans, and 7 has 3 true Booleans. And you'll notice that 2 is an empty list. And this is because if I hover over the all function, it says right here, if the iterable is empty, then it returns true. And with that hopefully coherent explanation out of the way, I will try to walk through these iterations. So the first time this runs, num is 2 and our primes list is empty. So when it's saying num mod prime is not equal to 0 for prime in primes, well, this is an empty list. So this is why we get this true here. And since this returns true, it yields num, which starts out at 2, and then it appends num to our primes list, and then it increments number by 1. So the next time it goes into the loop, num is now 3. So it's saying num mod prime for each prime number in our primes list, which in this case is only 2. So 3 mod 2 is not equal to 0. 3 mod 2 equals 1. So this does evaluate to true. That's why we have this true here. And since all the values in this list are true, our all function returns true. This is a prime number. And then we go to the next number. So now num is 4, and we have 4 mod prime for each prime number that's in this list, which the first one is 4 mod 2, which is 0. So this is going to evaluate to false, which is why this first element in this list is false. And then it's going to go to 3. So it's going to be 4 mod 3, which is 1. So it is not equal to 0, so this evaluates to true, and that's why we get the true here. But since we're checking to see if all the values in this list end up being true, the all function returns false on this, and 4 is not a prime number, hence it is not in our list down here. Generator functions and the way that they are working back and forth with loops and stuff that goes over iterator objects can be a lot to wrap your head around, and I hope that I explained it in a way that made sense, and walking through the first couple of iterations helped explain how generator functions work. Generator functions are a powerful tool in Python that allow you to work with large data sets and infinite sequences efficiently. They are particularly beneficial in scenarios where memory usage is a concern. So I strongly encourage you to practice using them and think of different ways that they might be useful, and just work with them until you feel like you have a solid understanding of what they are and how they work. There is another type of function that we could use, and that is the lambda function. Lambda functions are small anonymous functions that can have any number of arguments but can only have one expression. They are defined using the lambda keyword and are often used for short and simple functions that don't require a separate def statement. The syntax for a lambda function is right here. It is the keyword lambda, and then any arguments that you would like to operate on, a colon, and then after the colon, the expression, how you would operate on these arguments. So I'm going to go ahead and remove this and put in a very basic lambda expression. In this example, we define a lambda function called square that takes one argument x, and it returns the square of x by raising it to the second power. We call the lambda function just like any other function, passing an argument, in this case 5, and we get the result 25. So if I run this, we get the output down here of 25. And this lambda function is the equivalent of me typing def square, putting x in my parameters list, and then under here doing return x to the power of 2. But the lambda function is more concise, as I've been able to put it on a single line rather than having to put it on 2 lines. But let's look at a somewhat more interesting example. So I have this here where I have created a numbers list 1 through 5. And then I am creating squared underscore numbers equals, and then I have list, and then in parentheses I have map, and then in those parentheses I have a lambda function. And the way the map function works is it makes an iterator that computes the function using the arguments from each of the iterables. So basically what it's going to do is it's going to go through each element in the numbers list and pass that element into this lambda function. And then it is going to put that result in a new list called squared numbers. And if I run this, we'll get the output 1, 4, 9, 16, and 25, which are the squares of the numbers list here. We could also use lambda functions to filter elements from a list. So I have a new numbers list here that is 1 through 6. Then I am creating even numbers, which is a list that contains the filter function. And in the filter function, I am passing it this lambda function here, which is going to check to see if x mod 2 is equal to 0. And it's going to do this for each element in the list numbers. If I hover over the filter function here, it says it returns an iterator yielding those items of iterable for which function item is true. And what that means is that it wants a function that is going to return a value that it can determine if it is a true or false value. This does not necessarily have to be a Boolean value of true or false. It could be any object as long as it is truthy. And if I run this now, we'll get the output 2, 4, 6. We can also use lambda functions to help us with sorting. So here I have a student list that contains 3 tuples, one for Alice, Bob, and Eve. And in these tuples is their name and age. And I want to sort this list by the ages that are in the tuples. So to do this, I will call the sort method on the students list. And the way the sort method works is it takes a key argument, which is a function, in this case, a lambda function I am creating on the fly. And whatever value that function returns is the value that is used to sort the elements. Since I want to sort the elements by the student's age, the lambda function will take in a tuple from the list and return the value that's at index 1 of that tuple, which happens to be the student's age. And if I run this, we'll see that I get Bob 20, Eve 22, and Alice 25. We can even pass lambda functions in as arguments to other functions. So here I have defined a function apply operation that takes 3 arguments, x, y, and a optional argument operation, which defaults to a lambda function. And this lambda function takes 2 arguments and adds them together. And the return from the apply operations function is going to return the value that is returned from the lambda function. So here we are calling the lambda function and passing in the values that we have for x and y. And then we have multiply equals, and we're creating a new lambda function. And this time it takes 2 arguments, a and b, but it multiplies them together. And then I have add equals apply operation, and I only pass it in 5 and 3, which is going to make the operation argument default to this lambda function here. And then I have multi equals apply operation, and I've passed it in a 7 and 8, and this time I have passed it in my multiply lambda function that I created up here. So it is going to multiply these 2 numbers together. And when I run this, we'll see that I get the output 8 because 5 plus 3, which is happening in this lambda function here, is 8. And then 8 times 7 is 56, which is what I get when I pass the multiplied lambda function into the operation argument. So the operation is calling this lambda function here and multiplying the values passed in for x and y. So as you can see, lambda functions are a handy tool for writing concise and functional style code in Python. They are particularly useful when you need to define a simple function on the fly without creating a separate function using the def keyword. However, for more complex logic than larger functions, it is generally better to use regular functions for better readability and maintainability. Now that you know how to use functions, I am going to introduce you to the concept of scope. Scope is the region or context in which a variable or name is defined and can be accessed. It determines how other program portions view a variable and how long that variable can exist in memory. Understanding how scope works is important to accessing variables, avoiding naming conflicts, and knowing the lifetime of a variable. Variables created inside loops or conditionals are in the scope of the function or class where that loop or conditional is, or if they are now not in a function or class, they are in the global scope. Scope precedence means that Python looks for names in the order of local scope, enclosing scope, global scope, and finally built-in scope. The innermost scope always takes precedence if a name is defined in multiple scopes. The local scope is the innermost scope in Python's variable scoping rules.
When a function is called, a new local scope is created for that function, and any variables defined within that function become local to that scope. When the function returns, the local scope is destroyed and the local variables cease to exist. For enclosing scope, this is going to be a little bit of a mouthful, but bear with me. The enclosing scope refers to the scope of an enclosing function within which a nested function is defined. When a function is defined inside of another function, the inner function scope is nested within the scope of the outer function, making the outer function's variables available to the inner function. The enclosing scope allows the inner function to enclose or capture variables from its containing function even after the outer function has returned. The global scope refers to the top-level scope of a Python script or module. Variables and functions defined at the top level of a script or module are in the global scope and can be accessed from anywhere within that script or module. The global scope is outside of any function or class, making global variables accessible throughout the entire code base. Global variables are created when values are assigned to them, and they will persist until the script or module execution ends. The built-in scope refers to the scope that contains all the built-in functions, classes, and objects provided by Python's standard library. These built-in elements, such as print, length, list, etc., are always available for use without the need for importing any module. The built-in scope is the widest scope and is automatically available in any Python script or module without any additional setup. It acts as a repository of standard functionalities that come with Python, making them readily accessible from any part of the code. And on the right side of the screen over here, I do have some examples, but when it comes to scope, because it's such a tricky concept to wrap your head around, I think it would be better to actually see them in action. Let's look at some examples of scope in Python so that we can get a better understanding of how to access variables and functions from different areas of the code. So I have an example here. I have created a variable called myGlobalVar, and I've initialized it to 10. I have a function called modifiedGlobal, and then in that function, it is printing the value of myGlobalVar, and then below that, I am actually calling the function. Now, if I run this right now, it's going to output myGlobalVar in 10 just fine because the function has no problem accessing a variable that's in the global scope. Now, if I wanted to set this myGlobalVar to a different value inside the function, I'm going to move this print statement out here. And in my modified global, I'm going to put myGlobalVar equals 20. Now, when I run this, we're going to get it's still outputting 10. Well, the reason that this is happening is because inside the function, when it initializes this variable at this value, it's going to create the variable and put it in this function's local scope. It doesn't care if there's already a variable in global scope with that same name. So in order to actually change myGlobalVar from within a function, we have to use the global keyword. And we use it by putting global and then the name of the variable that we want to treat as a global variable inside this function. So now if I run this, I'll get the output 20 because it's actually changing this variable here from inside the function. And to see what variables or functions might be in the global scope, we can call the globals built-in function. So if I call print and then I call the globals function, and because this returns a dictionary, I only want to see the keys. So I'm going to call the dictionaries keys method. And when I run this, we'll see here that modify global, which is the function name, is in the global scope, and myGlobalVar is in the global scope. But what's interesting is if I remove this one here, the one that was actually initialized in the global scope, and only leave the one that's in the function, when I run this again, we'll see that myGlobalVar is still in global scope because inside the function, when this created it, it created it in the global scope. So now let's look at an example that has local scope, enclosing scope, and global scope. I'm going to remove this code and put in some new code. You'll see that I have myGlobalVar initialized to 10, and then I have an outer function, and then inside this outer function, I have myLocalVar initialized to 25, and then I have two print function calls, which are going to print the values of myLocalVar and myGlobalVar, because the outer function has access to its local variables and any variables that are in scopes that are outside of it. And then I have an inner function defined within the outer function with a myInnerVar initialized to 50, and it's going to print all three variables because it has access to its variables, which will be its local scope, and then the variables just outside of it and its enclosing scope, which will be my local var, and the variables outside of that, which will be the global scope for my global var. And if I run that, we'll see that we get my local var and global var for the outer function. And then we get my inner var, my local var, and my global var from the inner function. And because these print functions here are built in to the Python standard library, these are actually built-in scope. So this example here is using all 4 scopes. It's also good to know that any variables that are created inside loops or conditional statements are in the scope of whatever those loops or conditional statements are. So here I have this for loop and this if conditional that are in the global scope, and it's creating this loop var. And I'm going to go ahead and move this print statement down here. And then this if conditional, which is creating the if var. And when I run this, it's going to output the created in if conditional and created in the for loop just fine. There's no issues. Now, if I were to tab these out and put these in a function, so I could call it just define my funct, you'll see that I get an error here that says if var is not defined, because these loops are being created inside the function. Outside the function, the Python interpreter has no idea what these names are. So the loop var and if var would now be in the local scope of my funct. Built-in scope would be your types such as string, range, float, int, tuple, and then functions that are built in like print or length or globals or locals. Any built-in function type or error would be in the built-in scope, and they are in the outermost scope, which is accessible to anywhere in the program. And the last thing we'll look at is how precedence works. So I have a car variable initialized to Chevy, and then I have an outer car function, and it is going to print the value of car, and then an inner car function that is going to print the value of car. When we get to the inner function, this value of car, the inner function is first going to look in its local scope. And because I have this code commented out, it's not going to find a car variable. So it's going to jump into its enclosing scope where, again, this line is commented out. So it's not going to find a car variable. So then it's going to jump out into the global scope and look for a car variable. And if one wasn't there, it would then look into the built-in scope to see if there was a built-in variable car. But since we have one in global scope, this is what it is going to find. The outer function is going to check its local scope where it will not find the car variable. So it's going to jump into its global scope and find it out here. So the first time I run this, the value of car is going to be Chevy in every case. Now, if I were to remove this comment so that the inner car function has a car variable, then this value here is going to be for this right here. But the outer function is still going to have to jump out into the global scope and get the value Chevy. So now when I run it, the outer car is still Chevy, the inner car is now Dodge, and the outside any function or class, which is the global scope, is still Chevy. And if I remove this comment, now the inner car is going to find the value Dodge, the outer car print function is going to find the value Ford, and then the global scope is still going to be Chevy. So when I run this, we get outer car Ford, inner car Dodge, and outside any function or class Chevy.
Now I'm going to show you how to use the variable that's in the outer function from within the inner function. But before I do this, I'm going to add the global keyword in here and put car there. So when I run this now, we'll see that I get outer car Ford, and then inner car and outside any function or class car is Dodge. Now, if I were to remove the car that is outside either the outer or inner function and run this again, I'll get the same output. Ford for outer car, and then inner car and outside any function or class car is Dodge. And this is because when we use the global keyword, if there is not already an existing variable in the global scope, it creates it in the global scope. And if there is one, then it simply modifies the one that is already in the global scope. So how do we work with the variable that is in the outer function? We do this by using the non-local keyword. And the non-local keyword works just like the global keyword, except for it goes into the enclosing function instead of going all the way into the global scope. And I'm going to copy this print function here for my outer car, and I'm going to put it down below my call to the inner function. So when I get to this point, it's still going to output that the car is equal to Ford. But after I call the inner car function, the non-local car is going to modify this variable to equal Dodge. So when I run this, now I get outer car Ford, inner car Dodge, outer car Dodge, because it's been changed with this function call here. And then outside any function or class is still Chevy. So now you should have a pretty good understanding of how scope works, and some of the key things to keep in mind about scope are accessing variables and functions, knowing when variables are going to go out of scope and be destroyed, and not causing naming conflicts by trying to create names that already exist in the scope that you are working in. Now let's take a look at modules and see where we can get third-party modules to use in our own projects. Modules are files containing Python code for organized and reusable functionality. There are built-in modules that offer ready-to-use functionality like math operations and file input-output, and there are external modules which can be installed to extend Python's capabilities for specific tasks. Modules are imported using the import keyword and accessed using dot notation. They enhance code modularity, maintainability, and reusability, and Python's extensive module ecosystem provides solutions for various needs. There are literally hundreds of thousands of Python modules available. The syntax to import modules into your Python code is using the import keyword followed by the module name, which imports a module and executes its contents, and it allows access to its functions, variables, and classes. You can also import a module name as alias, which will give the module a new name for you to use. So if it's a really long module name and you want to shorten it, you can shorten it to whatever alias you want, and then you would type that name dot and then whatever function, variable, or class inside the module that you want to use. And there's from module name, import, and then a specific variable, function, or class. This allows you to import only a piece of the module and not the entire module. So to find third-party modules, you can, in your browser, go to pypy.org, which is spelled pypi.org. And at the time of this recording, you can see here that there is 468,397 current projects and over 4.6 million releases. So if you wanted to find a module that's based on something like game development, you could search game development, and you would get all these modules here that have something to do with game development. Or you can search for stuff by navigating through these filters over here. So you can go into framework, and then maybe you only want to see what has to do with the Django framework or what modules have to do with the Flask framework. So there are many, many, many modules to choose from. So let's look at some examples of importing and using modules in our own projects. We will start by importing and using Python's built-in math module. So we will type the keyword import followed by the module name, which in this case is math. Now to use the math module, we would type the module name and then dot for dot notation. And then we can access all these functions, variables, and classes inside the math module. So if I wanted to, let's say, use the factorial function in the math module, I would type math.factorial and pass it in a value. And if you don't know what a factorial is a number that multiplies itself minus 1 until it gets all the way down to 1. So it will be 5 times 4 times 3 times 2 times 1, which in this case, the factorial of 5 is 120. So if I were to print this x variable here, we will get the output 120. The next thing I want to show you is how to import specific elements of a module. So if I didn't want to import the entire math module, which if I were to put this dot here again, show you there are many, many, many functions inside the math module. And let's say I didn't want to import all of those. I only wanted to import the square root function. I would type from math import, and then the specific function that I want to import from the math module. So in this case, square root. So now I no longer need to type math dot to use the square root function. I can simply type sqrt and then pass it a value. So if I put in the square root of 16, for example, it's going to come back as 4. We can also import multiple specific functions, classes, or variables on the same line. So I can type from math import, and I can do sine, cosine, and tangent if I wanted to do some trigonometry.
And then down here, I could do x equals sine 1, and then also do y equals cosine 1, and z equals tan 1. And then down here, I can print x, y, and z. And we get the output of sine, cosine, and tangent 1 down here in the terminal. Now let's say that you were going to have to use the module name quite often and you didn't want to type out the entire name for whatever reason. You could use the as keyword to use an alias. So this time, let's go ahead and import the random module. And I don't want to have to keep typing random over and over and over again. So I'm going to import random as just R. And then we are going to use this to generate a random numbers. I'm going to do x equals R dot, and we'll say random, randint, R-A-N-D-I-N-T is the function to generate a random integer. And it says that it returns a random integer in range of A, B, including both endpoints, which means both numbers could be in the return value. Neither one of them are non-inclusive. So I will generate a random number from 1 to 10, and I will output that to the console. And when I run this, we'll see that this time we got 7. And if I run it again, I get 10. If I run it again, I get 7 again. 7's that lucky number. And I get 8. And that's how you would import a module as an alias. You can also create your own custom modules to use. And just to keep things simple, I am going to create a new Python file in the same folder as my modules.py file. So I'm going to create a new file here, and I'm just going to call it mathutil.py. In this math utility file, I'm going to keep it very simple and define an add function that takes 2 parameters. And I'll just call those A and B. And I am simply going to return A plus B. And then I will go ahead and create a subtract function that I'm just going to call sub A and B for the parameters, and I will return A minus B. I'm going to go ahead and save that. And then back in the modules py, I'm going to import mathutil. So now I can use mathutil.add. And if I give it 3 and 4 for the values, and I'm going to go ahead and put this into a variable called x. When I output x to the console, we will get the result 7. And if I wanted to use the subtract, the sub function that we created, I would type in mathutil.sub. And if I pass in 3 and 4, it's going to output -1. One issue that could arise when making and importing custom modules is code from the imported module executing when the current script is executed. When a Python script is executed, the Python interpreter sets the built-in variable __name __ to the string __ main __ for the script that is being run. This indicates that the script is the main program being executed. When a script is imported as a module into another script, the __ variable is set to the name of the module. I'm going to create a new file called importme.py and put some code in it that I only want to execute when the script is executed directly and not when it is imported as a module. So here, if I do new file, call it importme.py, and I'm going to paste this code in here. And you'll see that I have this main function, and in the main function, I am printing this is the main function in the importme.py file. And then outside any functions I have, this is a regular statement inside the script. And down here, I'm calling the main function. I'm going to go ahead and save this and go back into my modules py. I'm going to remove this. And actually real quick, just to demonstrate, if I run this, I'll get the output. This is a regular statement inside the script. This is the main function in the importme.py file. Now, if I go into modules.py and I import the importme module and I run this again, we'll see that I also get this output. This is a regular statement inside the script. This is the main function in the importme.py file. And if I add another print statement just to see that this is in fact running, I'll just say hello. And now when I run this, I'll get the output. This is a regular statement inside the script. This is the main function in the importme.py file. And then this output of hello, which is coming after the other 2 outputs. So back in the importme.py, what I could do to make this not execute this function whenever this is imported as a module is add an if statement. So here I am going to say if __name __,
is equal to the string underscore underscore main underscore underscore, then I want to execute this main function. And if I run this, we'll see that this does in fact run because this name variable right here is being set to underscore underscore main because I am executing this file directly. And I get the output down here. This is a regular statement inside the script. This is the main function in the import me.py file. And now if I go back into my modules and run this again, the statement that's inside the main function will not get displayed. So this is a regular statement inside the script and hello, and this is the main function in the import me.py file did not execute because I am using this if underscore underscore name underscore underscore equals underscore underscore main underscore underscore string. That's it for the basics of importing and using modules and creating your own custom modules. So now let's look at how you can download and install third-party modules using the Python installer package. So if I try to use a third-party module that I don't have installed, such as NumPy, if I type in here import NumPy, we'll see that I get an error saying that it could not be resolved. It has no idea what NumPy is. I'm gonna go ahead and delete that. And if I jump over into the pypy.org website, and in the search bar here, I type in NumPy, we're going to get a list of projects, and you kind of got to be careful on what projects you're grabbing because these are not all the official NumPy module. To the right here, you'll see dates, and usually when you're looking for the official module, it's going to have the most recent update date. But if you look at this one actually says NumPy 3 version 0.2. This one says NumPy 1 version 0.0.1. This one here is the only one that says NumPy by itself, and this is the official NumPy package that we want. So I'm going to go ahead and select that, and we'll see up here it says pip install NumPy. This is the command that you would type to install it, but let's go ahead and look at the documentation. So if we scroll down a little bit here, we'll see that we have a link for the documentation. I'm going to click that, and then I'm going to open the web version, and I'm going to click to the Absolute Beginner's Guide button here. So we get the absolute basics for beginners, welcome to NumPy, and down here for installing NumPy, we can either do conda install NumPy or pip install NumPy. And as of Python version 3.4, pip comes standard with it, so this is what we're going to use. Now to use this, we could do it from Visual Studio Code, but since not everybody's going to be using Visual Studio Code, we can do it from the command prompt. You can do that by either hitting your Windows key or going to the search bar and typing in CMD and opening the command prompt. And in the command prompt, you're going to type pip space install space NumPy. And when we run this, it is going to download and install the package. Once the package has been successfully installed, we can close out the command prompt and jump back into the development environment. And now when I type in import NumPy, we will no longer get an error. We get some information about NumPy. Back in the documentation, if we scroll down a little bit, it says how to import NumPy, and it tells us to use import NumPy as NP, and they explain that they shorten the imported name to NP for better readability, and they recommend that you always do that. So we'll use the alias NP. NumPy is commonly used for scientific and engineering related stuff, and it creates arrays which are much faster than lists. So let's go ahead and create an array variable. Then I'm just going to call my underscore array equals MP dot, and I'm going to call for the array function. And we can pass it a list of numerical values, which it will create an array with. So I'm going to do the list, which is square brackets, and I'm going to put these in here out of order. I'm just going to pass it these 5 values here, and then I'm going to print my array just to see how it's going to output this array to the terminal. And when we run this, we get the output of the array. Now you'll notice, unlike a list, when the array prints, it does not put commas between the values down here. The array itself has some built-in functionality to it. So I could do my array, then dot, and I can sort this array. And if I print the array out after it's been sorted, you'll see that it puts it in numerical order, 1, 2, 3, 4, 5. And that is it for installing and using third-party modules. I encourage you to look through them, explore them, look for modules that might have something to do with something that you're interested in.
Python is used heavily in the scientific and engineering community, so there are tons and tons of modules such as NumPy that help along that lines. There's a lot of modules for machine learning. So just look through them and try to find something that interests you and give it a shot at figuring out how to use it. Let's take a look at error handling, which is a way for programmers to catch and gracefully handle errors that may occur during program execution and prevent the program from crashing. Some key features of error handling are the exception, which is the error that occurs during program execution, the try except block, which is a block of code that catches and handles the exception, the except statement, which specifies the type of exception to catch, the finally block, which is an optional block of code that executes regardless of an exception happening, and the exception type. Python has numerous built-in exception types, and it allows programmers to create custom exceptions. Over here on the right side of the slide, I have some syntax examples. We have the try keyword followed by a colon, and then below it, it's indented code to execute that may raise errors. And then we have the except keyword with a colon, and below it is indented code that will gracefully handle the error should they occur. And then below that, I have another example. This one next to the except keyword has a specified error, the zero division error. And then we have a finally keyword with a colon that has indented code underneath of it that will execute regardless of if an error has occurred. If I jump into my development environment, I can show you that I have a variable here that is set to be equal to 10 divided by 0. And if I try to execute this program, we'll see that I get an error, zero division error, and it's giving me a message division by 0. You cannot divide a number by 0, so this raises an error. So to handle this in a way that the program won't crash, we would use a try except block. So now I have a try keyword followed by a colon, and then indented underneath of it, I'm saying x equals 10 divided by 0. And then I have an except keyword. And instead of crashing the program, this is what I want to happen should this error arise. So when I run this, I get this output of, oh no, something went wrong from my except block. However, this is not exactly a very helpful statement should an error arise, so we can do exceptions for specific errors. So here I can put in the error that I'm looking for, such as the zero division error, and then underneath this, I can give a message like, you cannot divide by 0. And now when I run this, I get this message, you cannot divide by 0. But what happens if that's not the only error in this code? Let's say that I have a list, and I'll give it the values 1, 2, and 3. And then let's say I try to access that list and say z equals my underscore list, and I give it the index of 3, which this list only has indexes 0, 1, and 2. So index 3 does not exist. Well, if I run this, you'll see that my program crashed and it's giving me an index error telling me that the list index is out of range. So to handle this, I could put these errors in parentheses and pass in another error here. And now I have to modify my message because it's not only catching the zero division error. So I'll have it say you cannot divide by 0 or use an index out of range. And if I run this, now it catches that index error and it says you cannot divide by 0 or use an index out of range. But now I'm faced with another problem that I don't know which of these two errors is happening, so I won't know how to fix my code. So you can have multiple except statements. So I'm going to fix this, have it give me an except statement for the index error and an except statement for the zero division error. And now I can have you cannot divide by 0 under the zero division error and have it say you cannot use an index out of range under the index error. Now if I run this, I'll get the you cannot use an index out of range. And if I swap this here to be up at the top of my try block and run this, now I will get the division error. So you cannot divide by 0. And that is because the first error that is encountered underneath the try keyword inside the try block is the error that causes the exception. So even though there is a index error down here, this line of code right here is causing the error. So these two lines of code never actually execute. But I may still have a problem here. There may be other errors in here. So I may try to pass in a variable name that doesn't exist for my list here, and this will cause a name error. But I don't have an exception down here, and I may not know that that's even a possible error that can happen. So what I can do to help
solve that issue is put in an except down here that kind of catches all. It catches any error that happens, and I can give it the output of, oh no, something went wrong. And now if I were to swap this, be on top, so that my name error happens, I'll get this output, oh no, something went wrong. But that's not very helpful. It doesn't really tell me what's going on. So the way that you can have a catch-all exception but actually have information about the error is by using the general base class of exception, but you also have to use the as keyword and then give it a variable name. And by convention, it's typically E, which is short for exception. Now this here is the common base class for all non-exit exceptions. So this is the base class for zero division error, index error, name error, anything that's a non-exit error. So now, because I'm using this as E, I can access the attributes of this. And down here in the print function, I can say error, give it a colon, and then a comma to separate my values and pass in E. And now when I run this and I get this name error, down here, I'm going to get the output error name Y is not defined. So now, with this catch-all, I can actually get information about any errors that happen that may not be a zero division error or an index error. And then I can have a finally block. And this code here will run no matter what. So if I wanted to, I could put in print done checking for errors. And if I run this, we'll get the output with my error, and then we'll get the output done checking for errors. Then just to show that it works, if I go up here and I remove any of my errors, so let's go ahead and get rid of all that error code. I'll just create a list in there. If I run this again, we'll see that I still get my done checking for errors output from my finally block, even though none of these errors happen. Now that you have some idea on how to handle errors, let's look at working with files. The with and as keywords are used together to work with context managers. Context managers are objects that define the dunder methods enter and exit, and they allow you to allocate and release resources when entering and exiting a block of code. The with statement provides a clean and concise way to work with context managers and ensures that the resources are properly managed even if an exception occurs. The syntax of the with statement with the as keyword is shown here. We have with, context manager expression, as, and then the variable. And variable can be any valid Python variable name. And then under this would be the code block that executes and uses the context manager. When the with statement is executed, the enter method of the context manager is called, and any value returned by it is assigned to the variable specified after the as keyword. Then the code block inside the with statement is executed, allowing you to work with the managed resources. After the code block is executed, or if an exception occurs, the exit method of the context manager is called, allowing you to release the allocated resources or perform necessary cleanup tasks. The with statement is a useful tool for handling resources in a clean and efficient way, and is commonly used for working with files, database connections, network connections, and other resources that need to be properly managed. The open function is used as a context manager with the with statement to open files. Once the code block inside the with statement is executed, the file is automatically closed regardless of whether an exception has occurred. So let's look at some examples of this actually working. In this code, I tried to open a file in read mode. If I hover over the open function, we will see that the second parameter is mode, which takes a string to indicate what mode the file should be opened in, basically the permissions we are opening the file with. Since the file I am trying to open in read mode does not exist, the Python interpreter raises a file not found error exception. If I run this, we will get the output file not found. And when I run that, we get this output down here, file not found. I could create the file in the accept block by using the with open statement and passing in a W for the mode. When using the W for the mode, if the file does not exist, it will be created. If the file does exist, the contents of it will be truncated and new data will be written to it. So I'm going to remove this print statement here and pass in this with open code so that we can actually create this file. And when I run this, we'll see that I get this example text over here. And if I open it up, it contains hello world. However, since using the W for mode will truncate an existing file or create a new file, using the try except block is actually unnecessary. And if I remove all this here, take the tabs back just a little bit and delete this example file and run this again, we'll see that we get our example.txt file with hello world in it just fine with no issues because we are using the write mode. One problem with this, however, is this does overwrite everything that's in that file, and you may want to attempt to write to a file without actually overwriting any existing file. So to do this, you would use X mode. So if I replace this code here, you'll see now I have a try except block, and with this with open statement, I am using X for the mode, which is for exclusive creation. And if I tried to run this right now, I am going to get this file exist error. So this print statement right here is going to execute, and I'll click run, and then we get this output file already exists. However, if the file did not already exist, so if I delete this and run this, we'll see that we don't get any output down here, and it recreates the example text file with hello world in it. We can append a file by opening it in the append mode by passing an A for mode. So if I replace this code here with this right here, since we already have our example.txt file, we're just going to append some additional information to the end of that file. When a file is opened in append mode, it does not truncate the file's contents. Instead, it starts writing data at the end of the file, preserving the existing content. Like with write mode, if the file did not already exist, a new file is created. So real quick, I just want to go back into the example, show you that it's still just hello world in here. And back in my code, if I run this and then go back into the example text file, we'll see that it's appended the appending additional content and appending even more content lines to the end of the file. Now I want to go over these modes a little bit and kind of explain in a little more detail what they're actually for. These modes kind of control what our permissions are with a file. So in append mode, I have permissions to write to the file, but I do not have permissions to read from the file. So if I were to remove this here and change this to a read method and try to run this while I'm opening the file in append mode, it will actually give me an error that says unsupported operation and tell me it's not readable. The same thing will happen if I try to open the file in read mode and try to perform some sort of write operation. So if I just pass an empty string in here and run this, I get this unsupported operation not writable. So if I remove this mode here and then start typing quotes, Visual Studio Code will give me this pop-up of all these possible mode options. And if I scroll through here, you'll see there are literally dozens of them. And if I go to like the write mode has this W+, read mode has a R+ right here, and append mode has this A+ right here. What the plus is it's saying that you can both read and write to the file. However, there are still some caveats to that. If I tried to call the read plus with a file that did not exist, I would still get an error for file not found. If I were to call the W plus on a file that does exist and not even do anything with it, not write to it or read from it, it will still wipe the contents of that file out. And with the read plus and write plus, the handle in the file, which kind of controls where the cursor is how you could think of it, starts at the beginning of the file. Now with the write plus, it's going to overwrite the file and wipe out everything that was in it and start putting new data in it, whereas the read plus will simply start at the beginning of the file and start overwriting characters. So if I were to open this file in read plus and pass in the value test in a write method, and if I go in an example real quick, we'll see it still says hello world. But if I run this, because this read plus started at the beginning of the file and simply started overwriting with these characters here, now I have testo world instead of hello world. The append plus is slightly different in that the handle starts at the end of the file and starts writing from there. But if you did something to move the handle somewhere sooner in the file, it would start overwriting text if you kept on putting new data in. Now that we've covered the different permissions and how to create and write to a file, let's look at some examples of different ways to read from a file. Since our file exists, if we open the file in read mode, we can print the contents to the console, which is what I have here. I'm opening the file with the read mode, and I am calling the print function and passing in file.read, which is going to return all the contents of our example.txt. And when I run this, I get the output hello world, appending additional content and appending even more content. If I hover over the read method, you'll see that it takes an argument for size. And what this does is says how many characters we want to get from the file. So if I pass in a 5 and run this again, we'll see that I get the output hello. Now, whenever you call a readline, or readlines method, they start wherever the handle currently is in the file. So if in the same with block you were to call file.read with 5 for size multiple times, it will keep returning the next 5 characters from where the previous read method left off until the end of the file. So if I go in here and I modify my print statements and add a few more, I'm going to run this and we'll see that I get first 5 is hello, second 5 is the comma, the space, and then WOR. Third 5 is LD and exclamation point, and then there's a line skipped and a capital A. And then the fourth 5 is PPEND. What you should take note of is this one here. And what happened was this reached the end of the first line. So the characters that it got back was L, D, the exclamation point, and then the new line character. And using file.read, it registers that new line character and includes it. And as you can see, it pushed the A down to the next line. Another way that we could read from a file is by using the readline method to read one line at a time. So if I go ahead and replace this code, I will open the example file and print file.readline. And this is going to return the first line of the file since I did not pass in a limit. And when I run this, we'll get the output of hello world. The same thing that happened with the read method would happen with the read line method if we passed a limit into it, except it will not continue to the next line if it reaches the end of the current line. So I'm going to modify my print statements here. And this time when I run it, you'll see that I get the first 5 is hello, the second 5 is the comma space WOR, third 5 is LD exclamation point, and then I get the blank space, but then the fourth 5 is APPEN. And the reason being is this third 5 included LD exclamation and then the new line character, and that's why we have this blank line here, but it did not go to the next line until our fourth call of the readline method. Another way that we can read data from a file is using the readlines method, which returns a list containing the strings of each line in the file. So if I go ahead and replace this code, this time I will print file.readlines. This has an S on it. And if I hover over, it takes an argument of a hint. And if I run this, I'll get this list containing hello world and the new line character, appending additional content in the new line character, and then just appending even more content and no new line character because there is not a fourth line in this file. And if I hover over this real quick and we look at this hint argument that it takes, the best way that I can describe how this works is if I put a number in there, it is going to start wherever the handle currently is and go that many characters into the file and return all the lines that it encountered while going to that character. This does not count the new line characters that are at the end of some lines. For example, hello world has 13 characters in it, so any number I put in up to 13 will only return the first line, hello world. But if I put in any numbers from 14 to 43, it will get the first 2 lines, and anything over 43 will return all 3 lines. And this is assuming that I only make one call to read lines with each time that I open the file. So if I passed in a 13 here, we'll see that I get the hello world in my list with the new line character. And if I passed in a 43 here and run that, we'll see that I get the hello world with the new line character and appending additional content with the new line character. And if I put in 44 and run that, I get all 3 lines from the file. And since the read line starts where the handle currently is in the file and returns the entire line where the hint is, if I call read lines 3 times with the same with open statement, but only passed 1 in each time, I would get back a different line in each list. So if I modify my print statement here and run this, we'll see that for first read lines, I got the first line in the file, second read lines, I got the second line in the file, and third read lines, I got the third line in the file. Since these methods for working with files, reading to them, writing to them, appending them, start wherever the handle currently is in the file, there is a way to manually move the handle for these operations. There is a built-in seek method that you can use to move the handle to a specific location in the file. So if I wanted to do something like print just the word world with the exclamation point, I could use the seek method to set it to start before the 7th character and only print 6 characters. So if I were to change this code under the with open statement to file.seek7, this will put my handle before the 7th character and then print 7th character seek and pass in file.read and tell it to read the 6 characters from where the current handle is, and run that. We'll see that I get 7th character seek and I get this output of world with the exclamation point. And I also just want to point out that this does work with other file types other than text files. So if I were to change this file extension to docx, which is a Word document, change my mode to write, and then here change file.seek to file.write and just pass it in hello and run this. It will create a new document called example.docx, and you can see that next to it, it has the Word logo. And if I open it up, it has the content hello in it. Working with comma-separated values or CSV files is a common task in Python, especially when dealing with data. To work with CSV files, you'll need to import the CSV module, which provides functions for reading from and writing to CSV files. From this code here, you can see I have imported the CSV module, and I created a list containing 4 lists. The first list is the headers, name, age, and location. The rest of the list contain a name, age, and location of a person. We will open a CSV file using a with statement and the open function and give it write permissions, but we also pass in the keyword argument new line equals an empty string. Setting new line equal to an empty string in the open function when working with CSV files is necessary for cross-platform compatibility. In some operating systems, such as Windows, the new line character is represented as \r\n, while in systems like Linux and Mac OS, it is represented as just \n. By setting new line equals an empty string, you tell Python to handle new line characters in a universal way. Now when I run this, the data.csv file will be created and added to the Explorer. And when I click the run button here, you'll see data.csv pop up over here, and if I open it up, we have our name, age, and location, and then we have our 3 people containing their name, age, and their location. Now that we have our data.csv created, I'm going to remove this code and replace it with this here. We can read data from a CSV file by passing R in for mode and using the csv.reader method. The csv.reader method returns a list containing the comma-separated values for each row. Under the with statement, I have csv_reader equals csv.reader to create a variable that I can access the attributes of the CSV reader with, and a for loop to iterate over each row in the CSV and print it. When I run that, we'll see that I get these 4 lists down here. This is our header information containing name, age, and location, and then our 3 people with their names, ages, and locations. We can also append new data to the CSV file by opening the file in append mode and writing new data to the CSV writer. So I'm going to replace this code here. I've created some new data lists containing a name, age, and location for 3 new people. And then with open data.csv, I am using the append mode. And again, I have my new line equals an empty string. And here I have csv_writer equals csv.writer. And I am doing csv_writer.writeRows, and I'm passing in the new data. So when I run this, and then I go into my data.csv, you'll see that I have added these 3 new names to the end of it, and I have 6 names, ages, and locations total now. You may already have a CSV file that has headers, and you can read data from a CSV file using the csv.dictReader method. So if I replace this code here with this, the csv.dictReader maps the information in each row to a dictionary whose keys are given the optional field names parameter. If the field names parameter is omitted, the values in the first row of the CSV file will be used, and the original ordering is preserved. So what I have here is I am opening my data.csv with read permissions, and I have this field names list, which contains my header information of name, age, and location. And then I have csv_reader equals csv.dictReader, and I am passing in the file and the optional field names. And then here, I am checking to make sure that my CSV reader is not on line num equal 1, because that is our header row, and I don't want to output the header. I just want to output the dictionaries with each of the people's information. So when I run this, you'll see that I get dictionaries containing the key value pairs, name, Alice, age 25, location, New York, and similarly for the other 5 people. And if I were to remove this little piece of code right here, and run this, you'll see that it will output this header one here that has the key value pairs of name and name, age and age, and location. So that's why I had the if CSV reader.line num is not equal to 1, so that it's every row but the header. So I'm going to get that back in there so I don't print the header row again, but I'm going to change my print statement to now print the information that it's in there, and I am going to use the header information to access the actual values. So when I run this now, I get the outputs of just strings that are not in a dictionary. These are just the values that I've accessed using these keys up here. And since for the dictReader method, field names is optional, if I were to remove it here and run this again, we'll see that it still prints the same output with no issues. We can also open or create a CSV file and write data that uses the keys in a dictionary as headers using the csv.dictWriter method. So I'm going to paste in some new code here where I've created a new set of data containing dictionaries with key value pairs. And then my open statement here is got write permissions. Unlike the dictReader method, the dictWriter method requires an argument for the field names parameter. So I created a list containing the keys from the dictData dictionary to pass in as field names. After creating the dictWriter, I will call the writeHeaders method to put the headers in the file, then call the writeRows method and pass in the dictData dictionary. When I run this code, we will see a new CSV file created in the Explorer that contains the data in the dictionary. When I run this, we'll see that dictdata.csv popped up over here. And if I open this, it has the name, age, and location header, and then the information for the 3 people that I passed in. Just like we did with the csv.writer method, we can append new data to the CSV file that has headers. Going to replace this data. I've created a new dictData list containing 3 dictionaries with key value pairs with name, age, and location as the keys. In my with statement here, I am opening the file with the append mode. And you'll notice this time I do not have csv_writer.writeHeaders because we are appending data and I don't want to put the headers back in a second time. So if I go up here and run this and then look in our dict_data.csv, you'll see that we have 3 new entries for Jill, Ethan, and Leon. The examples that I just showed here were really only scratching the surface of working with CSV files or data in general in Python. The built-in CSV module is a great place to start, but there are third-party modules such as pandas that give you a flexibility to do a lot more. And if you are trying to get into data analytics or machine learning, stuff like that, you're going to want to learn how to use CSV files. So I encourage you to find a module, even if it's the built-in CSV module that you can practice with to learn and understand how to import and export and just work with CSV data. Now it's time to start talking about object-oriented programming by introducing you to classes. A class is a blueprint for creating objects, which are instances of that class. They provide a way for the programmer to define and organize related data and functions into a single entity, which encapsulates attributes, which are variables, and methods, which are functions, that operate on the data within a class. Classes are fundamental to object-oriented programming, and they provide a powerful way to model real-world concepts and build complex systems. A class is defined by using the class keyword, followed by the class name. After a class is defined, you can instantiate or create instances of that class by using the class name followed by a pair of parentheses. Each instantiated object is independent and has its own attributes and methods. Attributes are variables within a class that hold data specific to each object, and you would use dot notation to access those attributes. They can either be instance variables, which are unique to each object, or class variables, which are shared among all objects of that class. Methods are simply functions that are defined within a class and they perform operations on an object's data. Like attributes, they are accessed using dot notation. The special init method, which is prefixed and suffixed by 2 underscores, is called the constructor, and it is automatically invoked when an object is instantiated. It initializes the object's attributes and sets their initial values. Classes support inheritance, which allows a programmer to create a new derived or child class based on an existing or parent class. The derived class inherits all the attributes and methods of the base class, and it has its own unique attributes and methods. Classes also provide a way to encapsulate data and methods together. Encapsulation means that the internal details of the class are hidden from outside access and only the public interface is accessible. This basically means that programmers that are using the class do not need to know how the class works, only how to access and use the methods and attributes. This concept promotes data abstraction and allows for more manageable and modular code. Classes also support polymorphism, which allows objects of different classes to be treated as objects of the same common base class. It allows you to define methods with the same name in different classes, and each class can implement the method in its own way. Polymorphism enables code flexibility and supports code reuse in various contexts. Let's take a look at actually creating some classes. Classes can be used to model real-world objects, so let's go ahead and create a class called person. We do this by typing the class keyword and then the name that we would like to give our class, in this case is person, and then a colon. And below the class declaration, we can add attributes such as variables and methods. In this case, I will add 2 variables. So we will do fname for the first name, and I will initialize it to an empty string, and lname for the last name, and I will also initialize that to an empty string. Once we have created a class, in order to instantiate a class object, we would type a variable name. In this case, I'm just going to call it P. And then we would say equals, and then type the class name, followed by a set of parentheses. And this right here is the class instantiation call. This creates an instance of this person class and stores it in the variable. Once the class is created, you can use and modify the attributes within it using dot notation. So I am going to change fname to equal my first name Jesse and lname to equal my last name Warner, and I am going to print my first and last name to the console. So when I run this, we get the output Jesse Warner. However, creating a class like this is not recommended because these are class attributes. They are not instance attributes, meaning that code could be put anywhere in the program that can modify these attributes. So I'm going to remove this line of code right here, and above where I create my person object, I am going to say person dot fname equals and give it the value of Bob. Now when I run this, it's going to output Bob Warner. And any person object that I create from now on is going to have fname initialized to Bob instead of an empty string. So if you were planning on creating a class and then explicitly modifying every attribute in it afterwards, this may be an okay way to create classes, but that's not really how you want to go about doing it. There is a better way to do it. And to demonstrate this, I have created a new class called dog. And in it, you will see that I have this def keyword and then this method here that is underscore underscore init underscore underscore, and it has some parameters. This method here is the constructor, and it is a special method. Whenever a new instance of a dog object is created, it automatically calls this constructor with whatever values we pass into it. And you'll notice this first parameter here is self. This name here, self, is by convention is not required to be self. It can be any valid Python variable name. And the purpose of the first parameter here is whenever a new dog object is created, Python is going to pass an instance of that object into the constructor, and that is going to be put in this self variable. So this is not something that you need to worry about entering a value for. The only thing that you would have to enter values for is name and age. And you'll see down here we are using dot notation with this variable in order to access the instance attributes of the dog object. So here we have self.name equals name, then self.age equals age, and down here I have self.weight equals unknown, and I put this in here just to show that we do not need to pass a variable in to create an instance attribute. We can create an instance of the dog object and then sometime later explicitly set the weight to whatever we want to set it to. So now let's create 2 dog objects. We'll call the first one dog1, and we will put in the name dog, and then in parentheses this time we'll see that it wants a name and an age. So the first parameter will be Max, and then for the age I will make him 3 years old. And then for dog2 we will pass in the values of Bella and make her 2 years old. And then to demonstrate using the instance variables, I will print out some information about these dogs. So I have two print function calls here and an f string. And I am calling dog1.name, so it's going to be Max, is, and then dog1.age, which is going to be 3 years old, and then it's doing the same for dog2. And when I run this, we'll get the output Max is 3 years old and Bella is 2 years old. Now, real-world objects don't only have attributes, they also have functions. They do stuff. So let's go ahead and give the dog class the method bark. And we do this just like we would create any other function. We use the def keyword and then the name and some parentheses and then a colon, and below the colon, we would say what we want this method to do. And I'm just going to tell it to print the dog barks. I'm going to go ahead and remove these print function calls and instead call dog1.bark. And when I run this, we'll see that I get an error. It says dog1.bark takes 0 positional arguments, but 1 was given. But that doesn't seem right because I didn't pass a value into these parentheses here, so what's it talking about? Whenever you call an instance method such as bark here, the Python interpreter automatically passes the instance of that object in as the first argument. So we need to provide a variable that can hold that argument. So this is where we would again put the self variable. And then inside the method, we can then use this self variable to access the instance attributes for this object. So instead of just saying the dog barks, I am going to turn this into an f string and then in curly braces put self.name to access the specific instance object that is calling this method's name. So now if I run this, I'll get Max barks. And if I change the dog1 object to the dog2 object, we'll get the output Bella barks. Now let's look at an example of a class that uses both instance attributes and class attributes. So I'm going to go ahead and remove my dog class here, and I'm going to put in class counter. And you'll see we have the class attribute count, which I've initialized to 0. And then I have the constructor, and I am going to give each counter a name. And then inside the constructor call, it's going to call counter.count and add 1 to it. And since this is a class attribute, it is accessible by all instances of this counter class. So down below the class, I am going to create a counter object that I've called counter1, and I've instantiated the counter object and given it the name 1. And then I have a print function that is going to print counter, its name, and then the count for the class attribute count. And you'll notice that I am using the counter1, so this instance object's dot notation, to access this count variable. And if I run that, we get counter1 count 1. So now I'll create a second counter object. So I have counter2 equals counter, and I've passed in the name 2. And I have 2 print statements. Now I am going to reprint counter1.name count and access the class variable count by using the instance object dot notation for counter1 and for counter2 here. And when I run this, we'll see that the first counter1's count is 1. And then after the second counter object is instantiated, counter1's count is now 2. And then counter2's count is also 2. So as you can see, using an instance object to access class attributes is not a problem. But what happens if we try to change the class attribute by using an instance object? I'm going to go ahead and remove this print function call here. And then down below counter2, I'm going to say counter2.count and give it the value of 7. And then I'm going to create a third counter, which I will call counter3. And give it the name 3. And I will add another print function to print out the counter and its count when it accesses the class attribute count by using the instance object. And then I am also going to add a print function that prints out the counter variable from the class itself. Now when I run this, we'll see that we get counter1 count is 3, but counter2 count is 7 because we changed it here. But then counter3 count is 3, and when we access the class attribute directly by using the class name instead of one of the instance objects, it is also 3. What happened here was when we did this counter2.count equals 7, it created a shadow copy of the count attribute for the counter2 object. And because of precedence, The interpreter will first check the instance object's attributes to see if there is a count attribute in there. And since we created a shadow copy of it here, it will find it. And that's why we got the 7 down here. Now, if it wasn't in the instance object's attributes, it would then jump into the class attributes and see if there was a class attribute for the variable name that we were trying to access. And since we did this, we can no longer access the class attribute count using counter2. We would always get the shadow copy that the Python interpreter created back. So if you do have class attributes, it's best to try to leave those as class attributes and not do anything to modify them using an instance object. Let's look at an example of a class that uses class methods. Here you'll see that I've created a new class that I've called date, and in the constructor I have given the parameters for year, month, and day, and in the constructor body I am initializing the instance variables to whatever values we pass in for year, month, and day. And then below the class I've created a date object that I've called date1, and I've initialized it with the values 2023, 12, and 25. Then I have a print function that uses an f string to format this data, and when I run it, we'll get the output year 2023, month 12, day 25. Now let's imagine a scenario where we are creating these date objects based off of a user input. We don't know how the user is going to input the date. They may input it with dashes or slashes or even spaces separating the year, month, and day. And to solve this, we can use a class method. So in my date class below the constructor, I'm going to put in a new method. And the first thing that you'll notice here is this right here, which is a decorator. It starts with the @ symbol followed by the decorator name, which in this case is class method. And if I hover over this, it'll tell us that it converts a function to be a class method. A class method receives the class as implicit first argument, just like an instance method receives the instance. And what that's saying is just like when we put the self parameter up here to receive the instance object itself, this CLS parameter is going to receive the class itself from the interpreter whenever we call this method. We also have this other parameter here that takes the date string. And then in the body of this method, we have year, month, day. So we are trying to unpack a collection into these 3 variables here, equals map, and I'm calling the map function. And the map function is going to take the list that is returned by calling the split method at the dashes and pass each one of those values into the int function. And then it is going to create a collection of the integers that it was able to create from this string. And then that is going to be unpacked into these 3 variables here. And then we return CLS and then in parentheses, the year, month, and day that we've gotten right here. And in the return statement here, where we have CLS and then a set of parentheses and then year, month, day, this works exactly the same way as if I were to call date and then pass in these values here. The CLS variable here is acting as the class itself. So now that I have this from string method, if I go down here and for date1, if I change this to be date dot from string, and then in here I pass in a string of 2023-12-25, and I run this, I'll still get the same output of year 2023, month 12, and day 25. But this time I've created the date object using this from string class method. But the way this is set up, it will only work with strings that contain dashes separating the numbers. So let's change that so that it's a bit more dynamic. So I will add a new parameter in here called sep, which is short for separator. And I am going to default it to the dash character. And then down here where I'm calling this split method, instead of passing in a character, I'm going to pass in the sep variable. And if I run this now, this will work just fine because our string is being separated by dashes, and that's what we've defaulted separator to. But if I wanted to use slashes instead, I could replace these dashes with slashes and then put a comma and pass in the slash character. And when I run this, we'll see that I still get the same output, year 2023, month 12, and day 25. And now if I wanted to, I could separate these numbers by any character I want. So even if I wanted to do the $signs, I could change all these to be $signs. And I will change this to be New Year's. And if I run that, we get the output year 2023, month 1, day 1. So as you've seen in this example, one way to use class methods is to provide additional ways to create object instances of that class.
You can also use class methods to modify and work with class attributes. The next thing that we will look at is static methods. I'm going to create a class that will only contain static methods, and static methods are commonly used when a method does not depend on any instance-specific data, but is still related to the class. They are often used for utility functions or helper methods that perform operations related to the class, but do not require any instance state. As you can see here, I created this class called mathUtility, and I have 3 methods inside of it: add, multiply, and square. You'll notice that I did not create a constructor for this. And if I were to create an instance of the mathUtility class and try to call these methods, it would not work because the instance object will be passed into this first parameter, and then it would try to add that instance object with whatever value we pass in for b. So unlike when using an instance method, which has the instance object passed in as an argument, or a class method that has the class passed in as an argument, static methods do not have an argument passed into them by the interpreter, and you create a static method by putting the static method decorator above the method signature. So up above define add here, I am going to type the @ character and then type in static method. And if I hover over this, it says it converts a function to be a static method. A static method does not receive an implicit first argument. And I'm going to copy that down to my other 2 methods here. And down here outside of my class, I am going to create 3 variables: add, multiply, and square. I'm going to set add to the value of mathUtility.add and pass in the values 1 and 2. And then multiply equals mathUtility.multiply, and I'll pass in the values 3 and 4. And then square equals mathUtility.square, and I'll pass in the value of 6. And then I have a print function that is going to format and output some information down here. And it's important to know that we are not creating an object instance of the mathUtility class whenever we do this. We are simply getting a value back from this static method that is going to be assigned to this variable. And if I run this, we'll get the output add 3. So 1 plus 2 is 3, multiply 12, 3 times 4 is 12, and then square 36. 6 to the second power is 36. As you can see, static methods are very useful when you have methods that are related to a class but do not require any specific instance-related data. Let's create a class that uses special methods. Special methods, also known as magic methods or dunder methods, are predefined methods in Python that allow you to define custom behavior for your objects. These methods are identified by their double underscores, hence the name dunder, before and after the method name. Using special methods allows you to create custom and intuitive behavior for your classes, making them more Pythonic and easier to use in different contexts. For example, implementing the equality and string dunder methods can make your custom class behave more like built-in data types and improve its readability and usability in code. These 2 methods are the methods that we are going to implement in our class. So in my development environment, I have created a car class that has 4 attributes for color, make, model, and year. And the first dunder method we are going to add to this class is the string method. This method will define the string representation of our car object if we pass the object into the string or print function. So in my class here, down below the initialization method, I'm going to define the string dunder method by putting 2 underscores, str, then 2 more underscores, and then in parentheses, I will put in the self parameter. And then after the parentheses, I will add the function annotation arrow and str just to indicate that it will return a string, and my colon. And then in this method, I am going to simply return a string representation of a car object. And this string here will be an F string that says A and passes in the color, make, model, made in, and passes in the year. And if I go down here outside of the class and create 2 car objects, one will be a black Chevy Silverado made in 2023, and car object 2 will be a red Ford Explorer made in 2015. And if I run this, I get the output a black Chevy Silverado made in 2023 and a red Ford Explorer made in 2015. And I could make this string anything I want. It could be something completely unrelated to this class if I wanted to, or it could use every variable in the class like I've done here. The next method we will add is the equality dunder method. The equality dunder method defines the behavior for the equality operator when used on objects of the car class. It gives us the ability to determine how we are going to compare 2 car objects to see if they are equal.
So in my car class, under my string dunder method, I'm going to do define 2 underscores EQ for the equality dunder method, then 2 more underscores. And this time I am going to pass in the self parameter as well as the other parameter. And the other, it will be the object that we are comparing to the current object that's calling this method. And I will add the function annotation arrow to indicate that this is going to return a Boolean. And the first thing that I want to do is check to see if the other object is even a car object, because if it's not a car object, there's no point in checking to see if they are equal. And we can do this by using the built-in isInstance function. So I'm going to say if isInstance, and I will pass in other, and then I will check to see if it is a class car. And if it is, we will return the Boolean value of self.make equals other.make and self.model equals other.model and self.year equals other.year. So basically what we're trying to make sure of is that the make, model, and year are all the same. We don't really care if the color is the same. And if the isInstance built-in function returns that the other object is not even a car object, we will return false. And if I scroll down here, I will create a third car. And this time I am making a blue Chevy Silverado made in 2023. In my print function calls, I am going to print if car1 is equal to car2. And then in the second one, I am going to print if car1 is equal to car3. And these are going to output Boolean values of either true or false. And if I run this, we'll get false because car1 is not equal to car2. Car1 is a Chevy Silverado made in 2023. Car2 is a Ford Explorer made in 2015. However, car1 and car3 output true because based on our equality dunder method here, where we are only checking the make, model, and year, these two cars, which are both Chevy Silverados made in 2023, will be considered equal even though they are different colors. The string and equality dunder methods are the only ones that I am going to demonstrate here, but there are many more. There are dunder methods for the less than or equal to, greater than or equal to comparison operators. There are dunder methods to define the behavior of arithmetic, so adding 2 of these objects together, subtracting one object from another, multiplication, division. There are tons of dunder methods that you can work with, and I encourage you to look through the Python standard library documentation, check them out, and practice working with them a little bit. Now let's look at the object-oriented programming concept known as inheritance. Inheritance is a fundamental concept in object-oriented programming that allows a class known as the derived class, subclass, or child class to inherit attributes and methods from another class known as the base class, superclass, or parent class. In Python, inheritance is achieved by specifying the base class as an argument to the derived class, and the derived class inherits all the attributes and methods of the base class, and it can also have its own attributes and methods. This allows you to reuse code and create a hierarchy of classes where each subclass can add new functionality. In Python, a derived class can inherit from a single class or multiple classes, and derived classes can also be base classes for other derived classes, allowing you to create multi-level inheritance. In my development environment, I have a dessert class that has the attributes name and flavor, and a cook method that outputs you bake the and then puts in the flavor and the name. The dessert class and any derived classes will be able to use this cook method. The derived class is going to be the cookie class. To create a derived class, you do it just like any other class. You start with the class keyword, and then you put in the name of the class. But instead of just putting a colon, we are going to put a pair of parentheses, and then inside the parentheses, we are going to put the name of the class that we are deriving from, which in this case is dessert. Then we do our colon, and underneath this, we can put in any attributes and methods. The cookie class is only going to have one method, and it's going to be dunk. So I'm going to define the dunk method and give it the self parameter. And the dunk method is simply going to print you dunk the, and then put in the name of the object in milk. And now that I have my dessert and cookie classes, I will create objects for each of them. I will call the first one pie, which will be a dessert object. And I will give it the name pie and the flavor of apple. And for the cookie, I will simply call it cookie.
And although I did not actually set up an initialization function in here to take any parameters, because the cookie class is derived from the dessert class, I have to pass in the same parameters as I would if I was creating a dessert object. So I'm going to give it the name cookie and the flavor chocolate chip. And I will demonstrate calling the methods on these objects. So the first thing I'll do is type pie.cook. And when I run this, we'll get the output, you bake the apple pie. And now if I do it on the cookie, we'll see that the cookie, which is derived from the dessert class, can call this cook method that's in the dessert class. And when I run this, it says you bake the chocolate chip cookie. Now, if I try to do something like pie.dunk, I will get an error. It says attribute error, dessert object has no attribute dunk. That is because the base class cannot see the attributes or methods that are in the derived classes. But if I did cookie.dunk, I will get the output, you dunk the cookie in milk. Let's say that we did want to add an attribute that is unique to the cookie class. We would have to use the init dunder method with the self parameter as well as parameters for the base class and the derived class. So under the cookie class declaration here, I am going to add the init dunder method, and I am going to pass in self for the self parameter, and then name, flavor, and price. And then I have to call the base class's init function explicitly and pass in the variables that it takes. So if I hover over this, it takes the self variable, the name variable, and the flavor variable. Now, because we are calling this explicitly, Python is not going to pass the instance into this method. So we have to do it by putting self right here, and then we would pass in the other required variables. And this name here is the same name that we are passing into our cookie class whenever we instantiate a cookie object. Same for flavor. And then under that, for the attributes that are going to be unique to the cookie class, that is where we would do our self dot notation for the attribute that we want to create in the cookie class, and then set it to the value that we want to set it to, whether it's some default value or a value that we passed in. So down here on my cookie, I will add the price, and I will make this chocolate chip cookie cost $4.99. I'm going to go ahead and remove these method calls here, and I will call the print function and tell it to print cookie.price, just so that we can see this, and this outputs $4.99. Another way that we could call the base class's initialization method here is, instead of actually using the class name, we can use super and a pair of parentheses, and then dot underscore underscore init underscore underscore, and then pass in our parameter. The super method allows us to call methods from within the base class. In this case, we are calling the init method, and the way the super method works, we don't actually have to pass in self, because the super method is allowing us to call methods in the base class from within the context of the derived class. So when we call it this way, it is going to pass in the instance of the derived class for us. And if I run this now, I'll get the output $4.99, everything works. And to further demonstrate the super method, I'm going to create another method inside the cookie class called bake and sell. And it is going to use the super method to call the base class's cook method from the context of the cookie object that is calling the bake and sell method. What this is going to do is it's going to call the cook method, and then it is going to say you sell the flavor, name, for, and then the price. I am going to change this here. I'm going to say tart equals, and I'm going to create a new cookie object. I'm still going to call it cookie, but its flavor is going to be cherry tart, and its price is going to be $6.99. And then down here, I am going to call tart.bakeandSell and cookie.bakeandSell. And when I run this, we'll see that I get the output. You bake the cherry tart cookie, you sell the cherry tart cookie for $6.99, you bake the chocolate chip cookie, and you sell the chocolate chip cookie for $4.99. And just to reiterate how this works, the bake and sell method in the cookie class calls super.cook, which invokes the cook method of the base class dessert. The super method ensures that the cook method is executed in the context of the cookie instance. So in this case, when tart calls it, tart is that cookie instance. And then when cookie calls it, cookie is that cookie's instance. So any attributes or instance variables defined in the cookie class are accessible. Understanding and working with inheritance at first can be a little tricky, so I urge you to practice. Try working with multiple inheritance where you derive a class from multiple base classes. Try working with multi-level inheritance where you derive a class from a base class and then derive another class from the previously derived class. And just work with it until you have a good understanding of how inheritance works. Let's look at an example of polymorphism. Polymorphism is a fundamental concept in object-oriented programming that allows objects of different classes to be treated as objects of a common superclass. It enables a single interface to represent multiple types of objects, making the code more flexible and reusable. Polymorphism encourages code reuse, and it makes it easier to extend the functionality of existing classes without modifying their implementation. In my development environment here, I have set up 3 classes. The monster class is the base class, and the dragon and goblin classes are the derived classes. The monster class has a method called attack, which it and its derived classes can use. The dragon class has a unique attribute element, and the goblin class has a unique attribute weapon. What I'm going to do to demonstrate polymorphism is called method overriding. I am going to create methods in the dragon and goblin classes with the same name as the method attack that's in the base class, and whenever a monster, dragon, or goblin object calls the attack method, a different version of the attack method will be called depending on the object type that is calling it. In the dragon class, I am going to give it the attack method, and it is going to print its name, breathes, and then the element that this dragon has. And in the goblin class, the goblin's attack method is going to print its name and then swings A and then whatever weapon I give it. However, unlike previous examples where I created an object and then whatever variable name I gave that object, I use that and dot notation to call its methods, I am instead going to pass the object into a function. The function will use the parameter I give it to call the attack method for each object. So down here outside of any of the classes, I am going to define a function called attack. And I am going to give it the parameter monster. And this is going to be the object that I pass into this method. And then in this method, I'm going to refer to that parameter and use its dot notation to call the attack method. And for my monsters, I will create a rat, which will be a monster object. And he will just simply have the name rat and 10 health. Then I will create a goblin, which will be a goblin object. And his name will be Goblin. He will have 100 health, and he will swing a sword. And then I will create a dragon, which will be the dragon object. Its name will be Dragon. It will have 200 health, and we'll say that it breathes fire. And now I am going to call this attack function right here, and each time I call it, I am going to pass in one of these objects that I just created. And then depending on the object that I pass in here will depend on which attack method gets called. Either the goblin's attack method, the dragon's attack method, or the monster's attack method. So down here below my objects, I will call attack rat and attack goblin, and finally attack dragon. And when I run this, we'll get the outputs rat attacks, goblin swings a sword, and dragon breathes fire. As this example showed, polymorphism allows us to call a single function, and as long as the arguments we pass into it have the necessary attributes, it will work with different objects. Now, I may have used the monster base class with 2 derived classes, but Python does not care what I pass into this function. It just cares if it has the attack method. So if I were to pass in like an integer value here, 10, which does not have an attack method, I'll get this error. Attribute error, int object has no attribute attack. Now, if I were to create an entirely new class that is not derived from monster, so it's completely new, but it also has the attack method, then it will work just fine with our attack function that is outside all of our classes. So I created this cat class, and it takes a name parameter, and then it has an attack method that prints out the cat's name, attacks the string. And down here, if I were to get rid of this rat here and turn it into a cat, say cat equals, and I will give this cat the name Mittens. And down here in this first attack call, if I pass it this cat object and run this now, I get mittens attacks the string. And this is the purpose of polymorphism, which is to allow objects of different classes to be treated as if they belong to a common class, providing a consistent interface for interacting with them, meaning that you can use a single method or function, which I've done here, to operate on objects of different types as long as those objects implement the required methods or attributes. So in this case, the attack method, which my monster class has, the derived dragon and goblin classes have it, and then this cat class that has nothing to do with the monster class also has it, and they all work equally as well on this one function.
Now let's look at how we can explicitly raise errors. We may want to raise errors for general error handling, debugging, validation, control flow, or even for security purposes. So if we look at the example I have here, I have created a function called positive value that takes a single parameter. And in the body of the function, it checks to see if this parameter is less than 0. And this is where we are going to do our error handling. If it is not less than 0, we will print out to the console the value x is positive. And where this pass is, I'm going to change this to the raise keyword. I'm going to raise a value error. And if I hover over this, it says that it's for inappropriate argument value of correct type. So we are only going to be passing in numbers here. So the value error makes sense because we are checking to see if the number is less than 0. So I'm going to go ahead and create a try except block. And under the try, I am calling the function with a -2. And under the except, I have value error as E, and I am printing out error and then the contents of the value error. Now, if I run this, we'll see that I get the error output, but there's no output. This is because this right here doesn't inherently have any information for us about why we're getting this error. So we can add a set of parentheses and pass in a custom message. So I could say X should be a positive value. And if I run this now, we'll get this output, error X should be a positive value. So this is one way that we could raise our own errors if we wanted to use this for input validation. Now let's look at how we can create our own custom exceptions, and we do this by creating a superclass that extends the base class exception. I'm going to go ahead and remove all this code here, and I am going to create a custom exception that checks for invalid email addresses. So I'm going to create a class called invalid email error that extends the base class exception. And under here, I have the initialization function that is going to take a single parameter message, and then I'm calling the super.initialization, and I'm passing it a custom string made with an F string using the string invalid email address, and then passing in whatever message we pass in when we initialize the class object. Then I am setting self.message to equal the message that we pass in. And then outside of this class, I'm going to create a function called validate email, which we will pass our email to be validated into. And then in this function, we are going to check to see if the @ symbol is not in it or the period symbol is not in it. And if either of these symbols is not in the email that we pass in, we will raise our custom invalid email error and pass the email into it. Now I will create a try except block that takes in some user input for an email address and validates that email. So here we have our try block that contains a variable email set to equal some input that's prompting the user to enter an email address. Then we're going to pass that input into the validate email function. And should an error arise, we will get the exception down here. But if an error doesn't arise, we will get email is valid and output the email. So if I run this and I give it a valid email such as jesse.warner@xyz.com and hit enter, we get email is valid and it outputs the email back to me. Now, if I were to run this and pass in something that is not a valid email, such as just my name, and hit enter, we'll get the output error invalid email address, and it's giving me what I entered. Now that you've seen how to handle errors, raise your own errors, and create custom errors, I encourage you to read through the errors in the standard Python library documentation and try to understand them a bit deeper and understand when and how to use them. Now I want to talk about naming conventions. With programming languages, after a while, a substantial number of developers will adopt a certain way of naming different elements, such as variables, functions, and classes, and it becomes somewhat of a de facto standard. This is no different in Python. However, if you work for a company, there's a high probability that your company has an in-house coding convention that dictates how to name different elements in your code. So if you work for a company, make sure you check with their documentation. Naming conventions help make the code more readable, and it allows others to better understand and collaborate on your code. Some common naming conventions in Python are that variables, functions, methods, modules, and packages use snake case with lowercase letters. Constants use snake case with uppercase letters. Private names are prefixed with an underscore and then use snake case with lowercase letters. And it is important to know that Python does not enforce private names or constants. And class names use Pascal case, where the first letter of each word is an uppercase. And on the right side here, you'll see that I have some examples. I have snake case that is written in snake case with all lowercase letters and an underscore separating the two words. I have Pascal case written in Pascal case, where the first letter of each word is uppercased. And then I have some examples for variables, functions, methods, modules, and packages, where I have my underscore string. And for the function, I have add underscore number. For the constant, I have the all uppercase pi and all uppercase tripler. For private names, I prefix the variable with an underscore. And for class names, I have a capital M and capital U as the first letter of each word. For constants and private names, this is not something that Python enforces. A constant would be a variable that you do not want to change the value of throughout the entire program. So you would set it one time and that value never changes. And this gives you something to work with. So like if I wanted to work with circles and I knew I was going to be using pi a lot, I could make the constant pi and always refer back to it to get the value of pi. With private names, again, it's not enforced by Python, and this would be something like a variable that's inside a class that is only changed by methods that are in that class, and nothing outside of that class should be able to change or use that variable. Now, the naming conventions that I just described are not in any way enforced by Python, but if you are wondering how to go about naming different elements, doing so how I described here is a safe bet. Chances are if you read other people's Python code, it will be similar or exactly as I've described it here, so you will be able to understand it a little better if that's how you're used to writing Python code. Working with mutable objects in Python can sometimes produce unexpected results, so I want to go over how to create shallow and deep copies to make working with them easier. Variables are references to objects in memory, and when you assign an object to a variable or pass it in as an argument to a function, the variable or function parameter becomes a reference to that object. If you assign a new value to that variable or modify the object through that reference, the changes are reflected everywhere that reference is used. This behavior applies to mutable objects such as lists, dictionaries, and sets. Understanding the concept of reference and copy is crucial when working with mutable objects in Python to avoid unexpected modifications and maintain data integrity. In my development environment here, I have a function that is set up and ready to go that is going to demonstrate that when you change a reference, it is reflected everywhere that that reference is used. As you can see, I have a function here called reverse list that takes a single parameter. In this case, I am going to pass a list into it. And this function is going to output my list before reversing. Then it's going to reverse the list and it's going to output my list after reversing. And then after we make a call to this function, we're going to print the cars list. And what we're going to see is that although we're calling reverse on this function argument here, it actually affects the list that is outside of the function. And when I run this, we'll get three outputs. We'll get my list before reversing, and I have Ford, Chevy, Dodge. And then I have my list after reversing, so it's Dodge, Chevy, Ford. But then when I print my cars after calling the reverse list function, it's also Dodge, Chevy, Ford. And what we can see here is that my cars list was reversed even though I called the reverse on my list up here in the function. And that's because when I pass cars in as an argument for this, I passed a reference to that object. And since the object is mutable, the changes are on the object itself. Sometimes this may be perfectly fine. This may be something that we want to actually change the referenced object. Other times we may want to work with the elements that are in the reference object, but not actually change the object. And the way that we can do that is by passing a copy of the mutable object in instead of the mutable object itself. So I'm going to spend some time in this video showing you how to make copies of mutable objects to work with. So I'm going to remove this code and add some new code. And if we look over this code, we'll see I have an import statement where I am importing the copy module, which allows us to make shallow and deep copies. I have a list of numbers that I am going to be working on. And in my list, I have 3 values, 1, 2, and 3. And then the third index is a list containing the numbers 4, 5, and 6. I have an exact copy variable that is just going to equal numbers. So when I do this right here, exact copy and numbers are both going to reference the exact same object. Then I have shallow copy 1, which I am creating a copy of numbers by using the built-in list method copy. Then I have shallow copy 2, where I am creating a copy by using slicing notation with a pair of square brackets and a colon, and I'm leaving it blank on the left and right side of the colon to copy the entire list. Then I have shallow copy 3, where I am using the class method copy from the copy module. And then I have deep copy, which uses the class method deep copy from the copy module. And down here, I have an if conditional statement to check if numbers is exact copy. And if we'll recall, when you use is, it is checking to see if it is the same object. So when I run this, we'll get the output, yes, numbers and exact copy are the same object. So this variable here and this variable here are the exact same object in memory. Now, if I remove this, I have some more code here. And if I uncomment this out, we can look at this. And now I'm checking to see if numbers, exact copy, shallow copy 1, shallow copy 3, and deep copy are not the same object, but all contain the same values. And if they do, this will output that all 5 lists have the same values. And when I run that, we'll see that it does, in fact, output all 5 lists have the same values. And if I included copy 2 in here, it would also have the same values, but it was getting a little long on the text and it was going off the screen, so I left it out. But it basically shows that all 6 of these lists here, even though they were all created in different ways, have the same values, but they're not necessarily the same object. And if I remove this, I can bring up some more code. This time I have an if-else conditional, and we're going to check if numbers is shallow copy 1. So are numbers and shallow copy 1 the same object? And if it is, it's going to print numbers and shallow copy 1 are the same object, else it's going to print numbers and shallow copy 1 are not the same object. And when I run this, we'll see that I get the output numbers and shallow copy 1 are not the same object. This is because we used the built-in copy method to return a copy of the list to put into shallow copy 1. And if I remove this, we have another if conditional here, where it says if numbers 3, so the element that's at index 3 is the same as shallow copy 1's element at index 3. So this is, again, checking to see if the element that's in index 3, which is this list right here, is the same object as the element at index 3 in shallow copy 1. And when I run this, we'll see that we get the output. The list in numbers and shallow copy 1 are the same object. And this is why it's called a shallow copy, because it only copies the outer structure of the list, not the elements inside. The copied list contains references to the same elements as the original list, but if the elements are immutable, such as numbers or strings, modifying them in the copied list won't affect the original list. However, if the elements are mutable, such as lists or dictionaries, changes made to those elements in the copied list will also be reflected in the original list. And to demonstrate that, I will go ahead and remove this code. And what I'm going to do is change the shallow copy 1's first index, the 0 index, to be a 7. And then I am going to change the shallow copy 1's third index's first index to be 8. So where this 5 is here will be 8 in shallow copy 1. And now I'll print out shallow copy 1 in numbers, and we can see how those changes have affected these lists. So I'll do numbers first and then shallow copy 1. And when I run this, we'll get these lists where we have 1, 2, 3, and now I have 4, 8, 6 inside the inner list. And then for shallow copy 1, I have 7, 2, 3, and also 4, 8, 6. And this shows that this 7 was changed in the shallow copy 1, but it did not change in the numbers list.
However, the inner list changed to 486 and the numbers list when I changed it to 486 in the shallow copy. So I'm going to go ahead and remove that, and we'll look at how a deep copy works. So I have this code here that I will uncomment. And it says if numbers 3, so this inner list, is deep copy 3. So it's looking at the inner list inside our deep copy here, and it is checking to see if it's the same object. And when I run this, we get the output. The list in numbers and deep copy are not the same object. And I will do something similar with the outputs here. I will change deep copy's 0 index to 7, and I will change deep copy's 3rd index, 1st index to 8. And then I will print out the numbers and deep copy list. And when I run this, we'll see that numbers has not changed at all, including the inner list. It is still 456. But for my deep copy, I have changed the 1 to a 7, and the inner list is now 486 instead of 456. To wrap up this Python tutorial, I want to go over some of the common pitfalls that new developers often experience. And the first one that I want to cover is using a mutable default argument such as a list or a dictionary. The problem is with a mutable default argument, if it's modified within the function, the changes persist across multiple function calls. And what I mean by that is you'll see here that I have a function that adds an item, and it takes 2 parameters. One is an item that is required, and then a list that is not required and uses a default empty list. And then in the function, we simply take the list and we append the item that we pass into it, and then we return the list with the appended item. Now, because I am using a mutable default argument, when I call this function 3 separate times, it is going to keep referring to the same list instead of creating a new one. So when I run this, by the time I get to my 3rd function call, I am putting 3 items in that same list when I only want to put 1 item in that list each time I call it. So to correct this, we would use none for our default value for list. And then in the function, we would check to see if my list is equal to none, and then set my list to equal an empty list. And now inside the function, it will create an empty list and append the item to it and then return that list. And because it's not using the default value, it will not constantly refer to the same list. So when I run this now, we'll see that my return is a list containing a single item like I expected it to. The next thing that I want to go over is modifying iterables during iteration. Modifying an iterable such as a list or a dictionary while iterating over it can lead to unexpected behaviors or errors. And if you do need to modify an iterable, it's better to create a copy or use something like list comprehension to generate a new iterable. And to show an example of that, I have this list of animals here containing 4 animals, and then I have a for loop that is going to iterate over the animals, print them out, and then if the animal is equal to lion, I want to remove it from the list. Now when I run this, we're going to get the output kangaroo, lion, and bear. And what you'll notice is it did not output tiger. Now the reason that it did not output tiger is because when it got to lion here and it removed lion, these indexes changed. So the first time it went through, it was at index 0 and it output kangaroo. The next time it was at index 1 and it output lion, but then because the animal was equal to lion, it removed it. And once it removed it, before the next iteration started, tiger was moved to index 1 and bear was moved to index 2. So on the next iteration, the index was at 2, which was now bear, and completely skipped over tiger. So what you would want to do in this situation, or at least one way to do this, there would be many ways to correct this particular error, is you could iterate over a copy of the list rather than the list itself, but then perform whatever changes you want on the actual list. And the way that I'm going to iterate over a copy of the list is simply by using slice notation. So I'm going to put in square brackets and a colon, just like that. And now this is a copy of the animals list, not the actual animals list. So when I remove this animal from the list, it's still going to correctly print them in order. And when I run that, we'll see that I get kangaroo, lion, tiger, and bear. And if I want, I can down here just print my animals list just to show that lion was in fact removed from the list. Another common problem is unintended variable references. For mutable objects, Python uses references to the object, and assigning one variable to another does not create a new copy of that object. Modifying one variable can affect other variables that reference that same object, so it's important to understand object references and use techniques like copying or creating new objects when needed.
So I'm going to show an example of this. I have two lists here, list 1 and list 2, and I have list 2 equaling list 1. So now if I do list 2.append 4 and then print out list 1, which you'll see here, I'm printing out list 1, we'll see that list 1 has changed as well, even though what I modified was a list 2. So real quick, I'm going to comment that code out so it doesn't run. And when I run this, we'll see it says list 1 after appending 4 to list 2, and we'll see that we do have 4 in that list. Now this is not an issue for immutable objects such as integers or strings, and we'll see that here that I have x equals 10, and then y equals x, and then I change y to equal 20. But if I print this out, we'll see that x is still equal to 10. And right here, x after changing y to 20, and it's outputting the value of x, which is still 10. So if you're using mutable objects such as lists or dictionaries, just be mindful that if you set a variable equal to one of these mutable objects, you are creating a variable that's referencing the same object in memory. It is not creating a copy of that object. Another common issue that is somewhat circumstantial is mixing tabs and spaces for indentation. Many interactive development environments insert spaces whenever you use the tab key. Not all of them do. So if you're using a mixture of spaces and tabs, depending on how you open that file up or what program somebody else uses to open that file up, it could throw the indentation and spacing way off and just completely ruin the file and make it a pain to have to get all the tabs and spaces in order again for the file to execute. So just make sure that when you are writing code that you are consistent with your tabs and spacing. What I like to do is just set up whatever editor I'm using to insert 4 spaces whenever I do hit the tab key. Another thing that new developers often forget to do is handle their exceptions properly. So whenever you have code that could have an exception, like anything that involves input from a user, you either have to make sure that you are validating that input either using error handling or some other way, but just make sure that anywhere in your code that an exception could happen, that you are using a try except block to handle it if it does, so that it doesn't crash your program. And the last thing is a reminder on floating point precision, because the way that floating point numbers are represented in computers, performing calculations with floats can sometimes lead to unexpected results. And I will give a quick demonstration for that. So I will have x equals 0.1, y equals 0.2, and I will say z equals x plus y. And if I print z out, I'm not going to get 0.3 like you would expect. I'm going to get 0.3 and then a whole bunch of zeros and then this 4 on the end of it, because it is slightly imprecise. I mean, this is an extremely small, imprecise amount, but depending on what you're doing, this might actually matter. So just be aware that when you're using floating point numbers, they're not always perfectly accurate.